conclusions about human nature are likely to have large-scale human consequences, and therefore they have to be advanced with scrupulous care and with a recognition of how little is understood when we pass beyond fairly simple systems. That's true elsewhere in the organic world as well. I don't feel that the question that's raised for discussion can be answered with much confidence in the areas that are of greatest concern and significance for humans, at least not by me. So I'm going to keep to a few words about the questions rather than the answers, and how they've been conceived and the kinds of problems they raise when we do try to address them. Well, at a very general level, the question falls within a familiar pattern of inquiry in general biology. We're interested in determining what's sometimes called the norms of reaction. That is, the mapping of an environment into a phenotype which corresponds to a genetic constitution, particular genetic constitution. I happen to be paraphrasing a well-known evolutionary biologist, but the point is familiar. And we can understand human nature to be the norms of reaction of the species, abstracting away from variation, which is probably fair enough in the general study of humans, since variability seems to be fairly small, certainly relative to our understanding, but even relative to closely related species. Particularly informative in this quest is what has a phenomenon that's been called canalization by biologist C.H. Waddington some years ago. That's a process whereby the end state of development is relatively independent of environmental perturbations, so therefore heavily constrained by the genetic endowment and particularly informative about it. These ideas are actually reminiscent, closely reminiscent, I think, of traditional rationalist conceptions of the origin and nature of mental faculties. These efforts, 17th, 18th century, also concentrated on what appeared to be fixed and highly structured outcomes that were thought to vary little with experience, probably correctly, called common notions since the early 17th century. This whole perspective became influential in general human psychology in the 1950s. In part, that was under the influence of ethology, comparative zoology. At first, there was a good deal of debate over the way the proposals were formulated. Konrad Lorenz, who was particularly influential, insisted that specific behaviors were innate, by which he meant that the actual behavioral outcome is genetically determined. And as was quickly pointed out, that no one expects, no biological trait is expected to be a product of genetics, the genetic endowment alone, or trivially a product of the environment alone. The outcome is expected to be some complicated interaction, an interplay of genetic constitution and the environment, of course, the environment, with developmental interactions and processes that remain rather poorly understood. To discover the genetic constitution, these various factors have to be disentangled somehow, and it's valuable to apply the approach, the traditional rationalist approach, the canalization approach, and to take a close look at possible ranges of outcomes. The more highly structured and restricted they are, the more richly articulated and canalized, the more we're likely to be able to find something out about the organism. Well, the logic of the situation dictates that the endowment that determines what the organism can become, the scope of possibilities, also determines the limitations of development. So, for example, the same endowment that makes it possible for a certain embryo to become a mouse is going to prevent it from becoming a bird. And we should expect the same to be true when we approach higher mental faculties across the board, in fact. So, for example, it ought to be true when we consider the largely unknown capacities that enable humans to acquire deep understanding in certain domains of inquiry, and by the same token, prevent this in some other, at least possible, domains of inquiry, which might be actual and which might even be important, and which might, for example, include the study of human nature. The human nature raises questions that we may not have intelligence enough to answer. Descartes speculated, maybe rightly, and maybe it's not a matter of enough intelligence. Now we look at it differently, but the wrong kind of intelligence, not an option for Descartes. Such an intrinsic structure of intelligence, which has to be there, should not occasion regret. Throughout the biological world, the limitations follow from the very same endowment that makes possible rich end states, rich outcomes. So it should be an occasion for celebration that there are things we can't do, even if some of them turn out to be things we might like to do. Well, that's been the framework for the study of language for about the last half century. The norms of reaction are sometimes called a language acquisition device, what Steve called the language instinct, the human genetic endowment that determines a specific language given a particular course of experience, and by the same token, prevents other language-like systems from developing in the mind. About these aspects of human nature, a fair amount is known, at least more or less understood, but I'm not going to talk about that. In principle, it ought to be possible to approach other higher mental faculties in the same way. In practice, the difficulties mount very quickly. Language appears to be relatively isolated from other cognitive capacities. I'm referring here to its structure, not its use, and not to components of the structure, which may be shared all over the place. When you turn to other aspects of mind, for example, our moral nature, it's much harder to isolate components for separate study, abstracting them from reflective thought and many other factors. Nonetheless, the topics have been investigated in various ways. There have been illuminating thought experiments. There's been some experimental work with children. There's comparative studies of cross-cultural and even extending to other species. Not uncommonly, the real world offers occasions, instances, illustrations of how the faculties function. Often these are painful choices. And probably saw a couple of weeks ago that in England, British judges, and along with moral philosophers and the church and many others, were agonizing over the question of whether it's legitimate to murder a child, one of two Siamese twins, in order that the other might have a chance to survive. Questions like these test our moral faculties. A hard test in this case, maybe an impossible one, and pursuing them may enable us to discover something about their nature. That's the kind of thought experiment that has been quite interestingly pursued. Sometimes this perspective, this generally ethological perspective, if you like, is counterposed to another one. It's called the relativistic one, which in an extreme form holds that apart from the basic physical structure of the person, humans have no nature. They only have history. Their thought and their behavior can be modified at will and without limit. Actually, nothing like that can be literally true, but such views are rather widely articulated in some form. In a version that's due to Richard Rorty, I'm quoting now, humans have extraordinary malleability. We are coming to think of ourselves as the flexible, protean, self-shaping animal rather than as having specific instincts. Therefore, there can be no moral progress in human affairs, just different ways of looking at things. We should put aside the vain effort at exploration of our moral nature or reasoned argument about it. We should keep to what he calls manipulating sentiments if we happen to be for or against torture or massacre or whatever. I'm probably misinterpreting. I can't imagine that the words mean what they seem to say, but at least that's what they seem to me to say. These proposals have, maybe not surprisingly, evoked a good deal of criticism. One recent paper in the Philosophical Foundations of Human Rights discussing Rorty and others suggests, I'm quoting again, that nobody would have taken a Nazi seriously who had claimed in 1945 that the sole basis for moral condemnation of the Holocaust is just culturally relative emotional manipulation based on shrewdly devised sentimental stories. Well, if that's so, and I assume it is so, we want to know why. Why is that so? And if nobody, the word nobody, includes all normal human beings, well, we're back to the question, the hard question of intrinsic human nature. Back to the question, but not an answer. This notion of unique human malleability, contrary to what Rorty suggests, is not at all novel. It's quite conventional. It goes at least back to the man-beast-machine controversies that were inspired by Descartes. Here's one typical example, argument in 1740 by James Harris, English philosopher, that saying that unlike animals and machines, the leading principle of man is multiform, originally uninstructed, pliant, and docile. Weakness of instinct leads to vast variety, but also to extreme malleability. That's an idea that has a long and quite inglorious history since that time. Well, with no metric, no way of measuring, how variable humans are as compared with others, and with very little understanding, it's pretty hard to make any sense of such judgments. But whatever merit they have, they don't seem to seriously offer an alternative to the approach that I outlined before, this roughly ethological approach. We can take for granted, it's undoubtedly true, that a person's understanding and judgment and values and goals reflect the acquired culture, norms, and conventions. But how are these acquired? They're not acquired by taking a pill. They're constructed by the mind somehow on the basis of scattered experience, and they're constantly applied in circumstances that are novel and complicated. These are important facts. They were discussed about the same time as James Harris, more than 250 years ago, by David Hume. He pointed out that the number of our duties is in a manner infinite, and therefore, just as in other parts of the study of nature, we should seek, I'm quoting now, general principles upon which all of our notions of morals are founded, principles that are original instincts of the human mind, enhanced by reflection, but steadfast and immutable as components of fixed human nature. If we don't do that, it's hard to see how we can make sense out of the fact that our duties are commonly new, we understand them, we respond to them in complicated and novel circumstances. Well, like Adam Smith, Hume took sympathy to be, as he called it, a very powerful principle in human nature and the grounding of much else. That idea was reconstructed in a Darwinian framework about 100 years ago by the anarchist natural historian and zoologist Peter Kropotkin, what you might call the founding volume of sociobiology or evolutionary psychology. There is recent work which suggests some possible evolutionary scenarios that might have led to this development. There's a review of current work on the topic in a recent book edited by Leonard Katz of philosophy department here. To this picture, we should add some other conceptions that have been very fruitfully studied experimentally in the past several decades, and I think can reasonably also be traced back to 17th century origins of modern science, including the brain and cognitive sciences. One strand of this is the recognition that innate capacities are only latent. They have to be triggered by experience to be manifested. To borrow Descartes' analogy, innate ideas, he said, are like susceptibility to a disease. The susceptibility is innate, but you don't get the disease unless something happens. That's what he meant by innate ideas. Another fruitful idea that was well examined extensively in the 17th century is that the phenomena of the world don't actually constitute experience. Rather, they become experience as our modes of cognition construct them in specific ways, and therefore they must conform to those modes of cognition. These modes of cognition are a distinctive property of our nature. They differ for different organisms. They're what Lorentz, back in the 1930s, called a kind of biological a priori, differing for different organisms. And that's also true of the experience that's the basis for the rich mental constructions that we call cultures or norms or conventions. The process of mental construction of experience and interpretation of it based on fairly common genetic constitution, well, that's, it must be rich to the extent that the structures are, the outcomes are highly structured and constrained and relatively invariant, canalized, if you like. And that appears to be invariably the case when, at least anything we understand. And if that's so, then the relativist approach is going to turn out to be profoundly innatist, at least if it is to address the kinds of questions that are studied elsewhere, the issues of acquisition and nature and use of attained systems, as, say, in the study of the visual system or linguistic systems or other properties of organisms. Actually, I doubt that there really are conflicts of principle separating these apparently contrasting views. Rather emphasis on one or another aspect of what an individual person is, and of course empirical questions, vast number and few answers about relevant aspects of human nature. Well, final word on the import of any tentative conclusions one might entertain about human nature. One way to assess their importance is to observe how deeply they enter into conceptions of right and justice and actual struggles that these conceptions engender. So examples of the kind I mentioned in the British case, while maybe unusual, such cases do arise quite commonly in our lives. That's essentially what Hume was talking about. More generally, every approach to how human relations should be arranged, whether it's revolutionary or reformist or committed to stability, it is based on some conception of human nature, maybe tacit conception. If it has any claim to moral standing, it's put forth with at least tacit claim that it's beneficial to humans, meaning because of their nature. So, for example, take Adam Smith's harsh condemnation of division of labor and his insistence that in any civilized society, government must, in his words, take pains to restrict it and mitigate its harmful effects. That conviction was based on an empirical assumption, his words, that the man whose life is spent performing a few simple operations will become as stupid and ignorant as it's possible for a human creature to be, which is morally impermissible, he argued, because it violates fundamental human rights grounded in human nature. Like other capacities, human understanding will not flourish along its own course without external triggering. It's latent. In Smith's words, without the occasion to exercise the understanding. And therefore, people must have the occasion or it's an infringement on their fundamental rights. That's a pretty standard Enlightenment doctrine. Another one of the founders of classical liberalism, Wilhelm von Humboldt, argued that humans are born to inquire and create, and infringement on this natural right is unacceptable. An infringement on that right would prevent them from exercising those intrinsic capacities to the fullest extent possible, hence illegitimate. Accordingly, as he put it, if an artisan produces beautiful work on command, we may admire what he does, but we will despise what he is, a tool in the hands of others, and not a free human being acting in voluntary association with other free people. The strong popular resistance to the modern industrial system was inspired by similar conceptions. When the system was taking shape right around here in eastern Massachusetts 150 years ago, there was a lively independent press run by artisans, shop workers, many of them young women from nearby farms. And it makes interesting reading today. They weren't borrowing from any, intellectual tradition. They were expressing themselves. These are mostly quotes. The contributors denounced what they called the new spirit of the age, gain wealth, forgetting all but self. They condemned the loss of dignity and independence, of rights and freedoms, the degradation and loss of self-respect, the decline of culture, skill, and attainment as they were subjected to what they called wage slavery, forced to sell themselves, not what they produced, becoming menials and humble subjects of despots, reduced to a state of servitude that was not very different from chattel slavery of the southern plantations, so they felt. These are quotes, actually. And those ideas were not at all uncommon at the time. They were upheld in large part by the Republican Party, for example. And they were of profound concern to the masters. Huge capital and intellectual resources have gone into the effort to drive them out of people's minds, very consciously. This goes back to the early days of the Industrial Revolution, and dramatically so in the past century, when one of the major industries, modern industries, public relations industry, was created essentially for that purpose. In the words of some of its leading figures, back in the 1920s, it was created to regiment the public mind every bit as much as an army regiments the body of its soldiers, to impose a philosophy of futility and a focus on the superficial things of life, like fashionable consumption, and to prevent people from harming themselves by taking charge of their own affairs, just as a responsible parent would prevent a child from running into a busy street. All of this was justified explicitly as good for people, reflecting human nature and reflecting the fundamental inadequacies of the less intelligent, including their unique malleability. And that's a crucial assumption that removes any moral barriers rooted in human nature that might be conceived in different ways, as indeed it was conceived by the subjects of these benign manipulations. Conflicts over human nature, what are in our tradition called inalienable rights, they lie at the heart of the slow evolution of a human rights culture over the past few centuries. An optimist could hold, maybe realistically, that history reveals a deepening appreciation for human rights, as well as considerable broadening of their range, including in very recent years. That is not without reversals, sometimes sharp reversals, but I think the general tendency is detectable and real. Inquiry into these slow changes, so for example, the debates over slavery, for example, which were rational debates. Inquiry into these slow changes suggests that what may have happened could have been attainment of a clearer insight into our own basic values, rooted in our nature. These are issues that are very much alive today. For example, conflicts over ratification of human rights conventions, or to take a current case, very sharp and divide in the world today over unilateral military intervention for allegedly humanitarian reasons. I think a case can be made that these are the appropriate terms for framing the issues, to some extent comprehending the history, And it's at least imaginable, though hardly imminent, that scientific inquiry might offer some guidelines for approaching the extremely significant issues that arise, perhaps offering some answers to questions that, as far as I can see, we can only speculate about today. Thanks.
My question is for the entire panel, but I guess mainly because I'm most familiar with Professor Chomsky's work. In the same vein of the last question, I'm just interested in each of you, what you use as primary and secondary sources as far as history sources, current event sources, and the organizations that possibly, publish these and put these out. And the reason is because I guess with a kind of a new wealth of information, it's kind of hard to kind of mull through this. I'm 25, so the internet's been around for a good part of my lifetime, and it just inundated with a lot of neat information. But how much of it is useful is a different question. So I would like to know what you subscribe to and where you get your first, the information where. To analyze what's going on in the world day to day. I mean, it's.
Well, there's never, at least in the recent history, for those of us who are reasonably privileged and don't have to spend the entire day trying to feed our children and so on, there's never been a shortage of information. You're just flooded with information. And the same is true in the sciences and everywhere else. So like a good physicist is not someone who knows most data. In fact, any person, it's probably, correlation's probably the opposite. I won't mention any names, but there's one old friend of mine who was a Nobel Prize-winning scientist who once said that when he teaches his courses, he makes up the facts the way they ought to be, and then he sort of challenges the students to try to check and see if he got it right, and let them find out. And the point that he was trying to make is that it's the information in itself is just a nuisance. I mean, like the data, the phenomena of life are a nuisance. You have to know what questions to ask.
This is from a man who carries more information in his head than anyone I've ever known.
You have to ask the right questions, and there's no, if I may borrow the word, algorithm for doing that. So it really wouldn't help to list. You could look at footnotes and things we've written, and that'll tell you what we looked at. But you have to find for yourself what kind of questions you want answered, and search for answers to those questions. And nobody can tell you where you'll find them.
Noam Chomsky is the principal architect of generative linguistics and has been the driving force in recent evolutions of the theory, including in the development of the principles and parameters framework, which one commentator has described as, quote, the first really novel approach to language in the last 2,500 years. Professor Chomsky has also been a key figure in the development of the cognitive sciences generally, indeed the most important figure in their development according to Harvard's Howard Gardner. He is perhaps most famous for his writings and lectures on international politics and in media theory. It is less well known, however, that Professor Chomsky has been an important figure in Anglo-American philosophy over the last 50 years, and that he has been a key interlocutor with all the leading philosophers of language and mind within that tradition. He's had lively exchanges with, for example, Willard Van Orman Quine, Hilary Putnam, Donald Davidson, Saul Kripke, John Searle, Michael Dummett, and now a new generation of philosophers. And I guess the first question has to be the following. Given everything that's on your plate, why do you bother with the philosophers?
Well, that's the most fascinating topic of all. It's what I grew up with and still am obsessed with.
Why do you think other linguists are not, or in general other scientists don't seem to be as engaged with the philosophical community?
Well, scientists tend, I think, to be involved in their own technical problems and often don't think much about, what it's about. So, I for many years taught courses in these questions and would have students read, say, Quine's papers in which he argues that everything they're doing is
complete what he called folly, and he gives arguments saying you can't possibly do it this way. The students will read the papers, but then go back to doing, and say, yeah, kind of interesting, and then go back to doing exactly the same work that they've just read is folly and can't be done, and so on and so forth. And I think that's not unusual. If you read the scientific literature, there's a lot of expressed contempt for what philosophers have to say about this. So you'll read somebody working on the neurophysiology of consciousness, big hot topic, and there'll be an obligatory first couple of paragraphs saying, well, the philosophers have muddled this up for centuries, but now we'll show how it's done, but with no engagement in the arguments that have been given or the thinking behind it.
Does it trouble you that, say, most other linguists don't engage philosophers on these issues?
It troubles me, because not so much that, it's connected to a deeper problem. I think it should trouble us that we're not thinking about what we're up to. And those questions happen to be the domain of what philosophers pay attention to.
Right. Let's turn to some of these philosophers and some of the things that they've said. The first one I want to look at is the Harvard philosopher Hilary Putnam. In the mid-'70s, he wrote a paper called The Meaning of Meaning, which is very influential. And I guess the key slogan that came out of that is that meanings just ain't in the head. Agree, disagree, or is that just incoherent?
It's incoherent without further explanation. First you have to tell us what meanings are. You can't decide whether they're in the head or not until we know what they are. If by meanings we have in mind what people have in mind when they're using the word in English, then sure, they're not in the head. They're all over the place. Talk about the meaning of life, it's not in the head. If you have some more technical notion in mind, you've got to explain what it is. If the technical, and there it's a matter of choice. You can define the technical notion so that it's in the head or so that it's not in the head. When you define technical notions, you have a choice. The way it's done in the sciences and the way it ought to be done is you define a technical notion in the context of an explanatory theory. You don't just define a technical notion out in space. So let's ask, what's the explanatory theory in which we're going to give a technical notion which will pronounce meaning or pronounce it some other way. And then we'll ask whether that theory is a sensible theory and does it place this technical concept in the head or not. But all that extra work hasn't been done.
Why can't we say there's just a pre-theoretical notion of meaning, and what we want to do is try and elucidate or precisify it in some way or other?
Yeah, you could do that, but there's a million ways of doing it. So what about the meaning of life, for example? That's part of the pre-theoretical notion.
Is it?
Is it? Sure it is. I thought people talk about the meaning of, what's the meaning of life all the time.
And you think that's the same notion of meaning as when you say, what's the meaning of the word?
No, there's thousands. It's a huge range of things. What did he mean by saying so-and-so usually has to do with what was his intention, or something like that.
Right.
So part of the pre-theoretical meaning has to do with people's intentions. In fact, when you talk about the meaning of a word, that's a rather English-specific locution. And we could focus on that if we like, but and if you want, you can try to clarify it. But again, to try to clarify a pre-theoretical notion makes sense within the framework of an effort to understand something, to an explanatory account.
Well, suppose we go with the following attempt to clarify, or at least introduction of a piece of technical terminology, which is philosophers will talk about the content of a mental state, or the content of some sort of expression. Is that helpful?
No, because content is a technical notion. It's not being used in the sense of the ordinary concept content.
Right.
And it, by now, since Putnam, in fact, and Kripke and others, it's typically used to refer to something out there. So the content of an expression is not in the head by definition, because we've defined it to be not in the head.
Right.
All right, then the question is, well, does that have anything to do with our notions of, does that have anything to do with our understanding of the way language works and is used? Okay, that's the question.
And
you can certainly, I think it has very little to do with it.
Well, suppose we thought of it this way. Suppose we thought of the enterprise being sketched in the following way. There are two ways in which you might study primates, for example. You might study primate anatomy, in which case you're just concerned about bones and muscles and tendons and so forth. And then you might also study primate ecology, in which case you're studying the relation between the primate and its environment. And I take it that what these philosophers are talking about here, when they talk about external content, is that they're saying a part of talk about meaning has to be analyzed in terms of thinking about the organism, the human organism, in relation to its environment, right? So
it has to, if you want to study the relation between the human organism and its environment. And that's fine. There's nothing wrong with studying the human organism and its environment. That's what sociologists are doing all the time.
Right.
But you have to do it seriously. If you want to do it seriously, you ask, first of all, let's go back to primates. When you study primates in their ecology, you don't just look at the anatomy of primates. You look at the physiology of primates, the what you might call mental processes of primates, the way they seem to be interpreting the world, the perceptual abilities of primates. In fact, what you try to do is exploit to the extent you can what we know about an individual ape. A chimpanzee, say, you want to know what do we understand about that ape? And that information we will bring to bear in the study of how the ape interacts with other apes and with the rest of the environment and so on. That's the way it's done with primates or with ants or anyone else, and I think that's the way it ought to be done with humans. So we should ask, okay, well, what do we understand about the internal nature of the creature that's doing all these things? And to the extent that we understand something about that, we can ask sensible questions about how it interacts with the external world, with other people, and so on and so forth.
do you think that could potentially inform the sort of internalist investigation as well?
Sure, it goes the other way. There's no order. You can study the sociology of ape communities, and that'll could tell you something important about the internal thinking processes of apes, or even their internal anatomy.
And vice versa, presumably.
Yeah, sure. Science goes all ways.
Here's another technical term that's been used, reference. You consider that to be incoherent as well, or?
Well, until it's explained, it's incoherent. Once it's explained, then it becomes non-incoherent.
Well, you see, one thing I've never quite understood is exactly what the problem is with reference, because, I can say, well, okay, now I'm referring to this coffee cup.
That's different.
Okay,
That's quite different.
Okay.
You're talking about an action of referring.
Right.
That's a common sense notion. It's part of
Right.
English and every
Right.
language I know of. There's some way to talk about such actions. But what philosophers have introduced is a different notion, a notion that's supposed to hold between a linguistic entity and something in the world. Now, that's not referring. Referring is an act that people do. Peter
this is the
Strawson
point that goes
pointed
back
this
to
out
Strawson,
50
right?
years
Yeah.
ago, but it goes way back.
Well,
and it's just a fact.
Okay, so let's
now,
take this.
If you want to make up a technical term which you pronounce the same way,
Yeah.
first of all, it's questionable whether you should pronounce it the same way because it's misleading. But if you do, let's at least keep clear that it's a technical term, kind of like physicists use energy. They don't mean it the way we do in ordinary language. They mean it the way they say they mean it. So let's take the technical term refer or denote or whatever you want to call it, and tell us what it's supposed to, tell us what you mean by it, and tell us what explanatory theory it enters into. So when a physicist defines energy, you're not interested in the definition. You're interested in the set of principles and assumptions and so on, problems and so on, within which that technical concept is introduced, and then you look and see how good the theory is. Well, here we don't have any theory. And we don't even have an explanation of what the technical notion is, so it's impossible to talk about it.
Yeah, I think it might be a mistake to think of it as a technical notion. I think it's just a sort of precisified way of describing certain basic core level facts, right?
Right.
So, for example, I might say, well, once you understand that people refer to things and so forth, it's not a hard step to say, well, okay, certain names are canonically used to refer to certain things and certain individuals. So the name Noam Chomsky, I can ask the audience here, what person in this room does that term refer to?
Well,
and no
you
one's
could
gonna
ask,
have trouble.
what do you use that term when you refer to something in the world? That you can ask. But when you ask what the term refers to, you're assuming that there is a relation between terms and things. And then you have to explain what that relation is, because that's a new one. We don't
Right.
have that in ordinary language. And in fact, I think it's leading us off into a wrong picture, as Wittgenstein would have called it. And it's leading us to a picture of language which is we know what it's based on. I mean, it's based on things like Frege's, the theory of arithmetic, and it's just the wrong picture for language, I think.
I want to change directions briefly. We may actually end up being sucked back into this issue. Donald Davidson, in a paper called A Nice Derangement of Epitaphs, said, or basically argued that there's no such thing as language. And I've always sort of thought that you may not want to admit it, but on some level or other, you probably agree with that, right?
No. In fact, I think he ended up contradicting himself. I think there's some discussion of it in here or somewhere. If you look at the end of the paper, it turns out he's presupposing that there is a notion of language in the technical sense of an internal generative procedure that relates sounds and meanings and so on. He says there's no notion of language in another sense, the sense of some community property or whatever. Well, okay, first of all, I don't even think that's true. It's not a scientifically usable sense. But I think the paper is just rife with confusions. I've written about it.
So you think there are such things as languages?
Yeah, like there's such
in
things.
In an informal sense.
Like there's such things as the meaning of life. And I understand it when people ask, what's the meaning of life? So yeah, there's such a thing as the meaning of life. There's such a thing as the financial crisis in Argentina. There are all kind of things in the world. But if you want to proceed to understand what you and I are doing, those notions just don't help. You've got to look at it differently, the way we look at primates, other primates, in fact.
Well, let me read a quote from something you wrote recently, okay? You say, "I doubt that people think that among the constituents of the world are entities that are simultaneously abstract and concrete, like books and banks, or that have the amalgam of properties we discover when we explore the meanings of even the simplest words, like river, person, city, etc."
Yeah.
You think the average person doesn't believe in the
cities? That's a technical question.
Okay.
It's a question if you try to figure out what a person's folk science is, how people think the world is actually constituted of entities, which is not, do I talk about books? Of course we talk about books. We talk about the meaning of life and so on.
Right.
But if you ask people, well, how do you think the world really works? That's the problem with ethnoscience.
Right.
It's like you go to some other community and you try to figure out what's their idea about how the world works. Like maybe the classical Greeks thought Apollo pulls the sun through the sky or something. That's their folk scientific picture of how the world works.
Right.
That's a hard topic. You can't just do armchair philosophy about it. That's why ethnoscientists have to work, And when they work, what they find, I think if they worked on people like us, instead of just talking about it in the common room, they would discover that our folk science, yours and mine, does not include entities that are simultaneously abstract and concrete, and does not include entities like the meaning of life. That doesn't mean we can't talk about them. Sure, we talk about them all the time, but we don't, at least I don't, and I presume other people don't, think of them as constituents of the way the world operates. We don't do that when we're talking to each other informally.
Now, that sounds a little bit more moderate than what you've said elsewhere. Here's a passage from, I believe this is from New Horizons, where you say, "In the domain where questions of realism arise in a serious way, in the context of the search for laws of nature, objects are not conceived from the peculiar perspectives provided by the concepts of common sense."
That's absolutely right.
Yeah.
But there's several different enterprises that you have to distinguish here. And I don't think it's more or less moderate. It's about a different topic. When you're trying to understand something about the nature of the world, you and I, anybody, you start with some kind of what's called folk science. Almost every society we know has some picture of the way the world works, which is more or less commonly shared. If you try to do this more reflectively and carefully, bringing in other criteria and probably bringing in other cognitive faculties. We don't know that for sure,
Right.
but I suspect it. Then it becomes the enterprise of science, which is a different enterprise and a peculiar one. It's not folk science, it's science. That works in other ways. This comment has to do with our culture in which the enterprise of science is understood,
Right.
our intellectual culture, and in that, when we try to find out how the world works, we discard the concepts of common sense very quickly.
But it sounds to me here like what you're saying is that the only things that are real, right, are the things that science tells us are real. So it sounds like what you're saying here is that, well, this table isn't real, but maybe, quarks.
Real is an
things.
honorific term.
Okay.
You can use it any way you like. I mean, to say, if I say something is true and then I add, well, it's the real truth, I'm not saying there are two different kinds of truth, the truth and the real truth. I'm just emphasizing what I said. And the term real is basically used honorifically. So yeah, you can use it honorifically in various ways. If we're trying to find out the way the world works and to really understand it in the manner of the sciences, we very quickly give up common sense notions. If we're carrying out folk science, less reflectively, probably using different cognitive faculties, we also give up common sense notions, but in different ways.
Well, you can say a lot of, claims about something being honorific, like real being honorific. Alan Gibbard, for example, has argued that terms like rational are honorific, or moral are honorific.
Well, I don't agree with that.
Okay.
I think real is quite different.
But what's the difference in these cases, then?
Because I think rationality is something that we can understand, and morality is something real, and it's part of us, and we can try to figure out what it is. We can try to figure out what our moral faculties are. We understand something about what rational action is, but about reality, we have to ask what we're talking about.
Right.
If we're talking about reality in the enterprise of trying to discover the way the world works in a physics department or a linguistics department or whatever, common sense notions are irrelevant. If we're trying to explore our intuitive understanding of the way the world works, common sense notions are relevant, but we discard them. If you're using it in a more informal way, like is the meaning of life real? Yeah, sure, okay.
Well, look, there's a sort of space between ethnoscience and science, right, and common sense and all of those. And it's been explored by philosophers for 2,500 years, and it's called metaphysics, right?
No, that's different.
Okay,
See,
but that is a question about what's real, right?
Ethnoscience is a branch of science.
Right.
Ethnoscience is the branch of science that tries to figure out what people's beliefs are about the way the world works.
Right.
Metaphysics is not that.
I understand that, but
Okay.
do you think that metaphysics is impossible?
No, science is metaphysics.
Oh, okay, good.
It's talking
Okay,
about what
good.
the world is made of.
All right. So, but then the question is, why do you think that science gets to claim what's real? Now, let me give you an example. So, in the scientific image, Bas van Fraassen is a scientific anti-realist. So he says the things posited by science, quarks, et cetera, are not real, but mid-sized earthbound objects are real. Now, you've got the flip side of that, right?
I don't have any side because I don't think the word real is sensible enough to use. They're all real in different senses. If you're trying to understand the way the world actually works, whether you're Bas van Fraassen or you or me, we're going to go to the scientists because they tell us how the world really works. If we're interested in exploring people's common sense beliefs, we'll go to the ethnoscientists and see what they discover.
What if we're interested in something like whether there are events or whether there are properties or whether there are mereological sums or something?
Well, let's take events, which plays a prominent role in modern semantics.
Right.
So here you can ask a lot of different questions. For one thing, you can ask whether in, say, Davidsonian semantics, where there's a lot of, or anything that developed from it, event-based semantics, whether the things, whether what are called events are internal to the mind or outside the head.
Right.
But I think they're internal to the mind.
Can't they be both?
Well, they could, but then we're asking another question.
Right.
If we're asking, well, how do these things that are internal to the mind relate to something in the outside world, we'll say, okay, let's take a look at what you mean by an event. So, for example, is the American Revolution an event? Yeah, it was an important event in history. Does that event include the fact that the man who the indigenous population called the town destroyer took off a little time in the middle of the revolution to destroy the Iroquois civilization? Is that part of the event called the American Revolution? Well, not when you study it in school, you know. You want to find out about that event, you got to probably the Iroquois remember, but the ones who were left, or you've got to look at serious scholarly history. Then you find out that one part of what was going on in the event that we call the American Revolution was a side operation in 1979 to wipe out the Iroquois civilization so that the colonies could expand if they got rid of the British. Well, is that part of the event or isn't it? Well, you know, here come hard questions about what we're really going to call events in the outside world. And those questions don't have answers because they are, they're highly dependent on our interests, our perspective, our goals, all kinds of factors. So I don't think we're going to find external events in any sense worth pursuing for investigation of what the world is like.
Why can't these external events just be complicated objects?
It can be anything you like, but is the town destroyer's exploit part of the American Revolution, or isn't it?
Well,
that event.
It
well,
sounds,
it's your choice. But there's no answer to that.
Yeah, but now it sounds like you're saying that, well, I have representations of events, right? The representations
I have representations.
You have representations.
I have representations,
Okay.
Some which we informally call events.
Right, but now one might ask, what on earth is a representation if it's not a representation of something?
Well, see, that's a mistake that comes from a philosophical tradition. The way the term represent is used in the philosophical tradition, it's a relation between an internal object and an external object.
Exactly.
It's not the way it's used either in ordinary speech or in the sciences. So when a perceptual psychologist, say, talks about an internal representation of a cube or something, there doesn't have to be any cube there. They're talking about something that's going on in the head. In fact, what they may be studying, and usually are studying, is a relation between things like tachistoscopic presentations and internal events. There's no cube, but nevertheless they talk about it as an internal representation. I mean, the concept internal, there's a long discussion of that in here. The concept internal representation is used in the sciences, and I think that's ordinary speech too, in ways which don't involve a relation between an internal thing and an external thing.
Right.
I mean, that derives from a particular interpretation of the theory of ideas, which said, well, ideas represent something out there.
I should interject here.
Incidentally, I should say that that's not the interpretation of the theory of ideas that were given by the people who used it. So like, say, Hume, for example. I quote him in there. He raises a serious empirical question. He says it's about the nature of the terms he uses, the identity that we ascribe to things, meaning how do we individuate things?
Right.
And he asks the question, well, is this a peculiar nature common to the thing, or is it what he calls fictitious, a construction of the mind?
Right.
And he says fictitious. There is no entity, there is no common nature, there's no nature common to the thing, there's a construction of the mind, which we used to talk about the world.
But he's
an
idealist.
No, he's not an idealist.
Hume is not an idealist?
No, not here. He's saying we interact. He believes there's an external world out there. There's a coffee cup on the table and so on. But he says that he's talking about the individuation of things, how we organize things, how we construct our picture of the world.
Right.
And that involves the way our minds work. And that doesn't mean the world isn't there. It's just what his predecessors called our cognoscitive powers, which use the data of sense to construct an account of the world. And he's saying, well, you want to look at the identity of things, the identity that we ascribe to things, like what makes us call something a book or an event and so on. He's saying, well, it's fictitious in the sense that it's a construction of the mind based on the data of sense. That's not an idealist position. In fact, that's the position of modern science.
Because people will call you a crypto-idealist.
Well, then they're misunderstanding what idealism was.
Okay. Let me, there's an issue that I wanted to get to here, and this involves the thing we mentioned about representations and whether a representation requires there being something that it is a representation of.
Yeah.
Now, in a very important and somewhat influential book by Saul Kripke, there's a revival of the sort of Wittgensteinian argument about rule following. Let me just read the relevant passage here. So in that book, Kripke says, if statements attributing rule following are neither to be regarded as stating facts nor to be thought of explaining our behavior, it would seem that the use of the idea of rules and competence in linguistics needs serious reconsideration, even if these notions are not rendered meaningless. Now, I know you've
I've written
on that in Knowledge of Language.
The crucial word is if.
Right.
Okay, and beyond, and the fact is that in the sense in which the term rule is used for thousands of years, in fact, in the study of language, it's not the kind of rule he had in mind. So if you read a book, you study Latin, let's say, or you studied it 1,000 years ago, they would have a rule that tells you, when to use the ablative case or something.
Right.
That's not a rule in Wittgenstein's sense. It's a description of a part of the language.
Right.
So the questions about rule following just don't arise.
But we don't need to get hung up on rules and so forth.
But
here.
that's what he's talking about.
I understand that, but in a certain sense, he's talking about any sort of computational state. So take just a computer, right? Forget about human beings for a second.
See, computers are a different story.
Okay.
Let's take an insect.
Yeah, okay, yeah.
See, why aren't these questions asked about insects?
Right.
I mean, insects, when you study insects, you attribute to them computational states.
Right.
Is that a problem? I mean, is it not real? Like if you say that an insect is doing, determining the position of the sun as a function of the time of year and time of day, and here's the computation it's using, why isn't that science?
That would be, but the argument would be that the reason you can get away with that is because you're talking about what the representations that you're attributing to the insect are externalistically anchored. That is, you couldn't do it unless you had an embedded system.
That's not true. You could do it in an experimental situation in which you have a light, and in fact, if you knew how to do it, you could do it by stimulating the external sensory organs of the insect. It would all be interior. And there doesn't have to be a sun there. No, it's just that, you're talking about it the way it happens actually in the real world, but the same thing, you would say the same thing in an experimental setting where you don't have an external world.
Well,
because you're talking about the internal computations of the insect on the occasion of sense. Doesn't matter what's out there that's giving the sense.
Notice the shift there, though, because you went from saying you don't need the sun in the experimental setting to saying you don't.
Say the same thing.
You could run the experiment in a world that didn't have the sun, and that's a different story, right?
No, it's not a different story. The point is, if you look at what insect scientists are studying, they're studying what 17th century philosophers used to call the constructions of the mind on the occasion of sense.
Right.
Now, it happens that in the world that they're looking at, the occasions of sense happen to be related to the fact that there's something 93 million miles away.
Right.
But the study could go on as if it's what Hillary called a brain in a vat. The studies are internalist because we don't know anything else to study.
But this is disputed, right? I mean, there is this dispute about David Marr, right? I mean, there's two stories on this. Tyler Burge and Martin Davis, for example, argue that Marr is sort of fraught with externalist sort of.
Yeah, but they're just misreading him.
Okay.
I mean, in fact, I have to know Marr personally, but I'm sure if he was here, he would say this. If you look at the informal exposition in Marr's vision, let's say, book vision, you look at the informal exposition, in order to motivate what he's doing, he says, well, imagine, an elephant or something, or anything like a stick figure, and you're trying to, we want to know how that thing out there is interpreted by the visual system as, some three-dimensional object.
Right.
However, if you look at the experimental procedures of Marr, they didn't have elephants out there. In fact, what they were using was tachistoscopes. And so they were having, dots on screens. And if they had known how to stimulate the optic nerve, they would have done that. When you go from the informal exposition to the actual science, you see that, like everything else, it's a study of the internal nature of the beast. And in fact, they would have loved to get to the point where they could tell you something about how you identify an elephant, but they never got anywhere near that. However, even if they did, it wouldn't matter whether the elephant is there or not. It would matter what sensory, what's the occasion of sense. Again, the 17th century formulation of this was, I think, quite appropriate. On the occasion of sense, the cognoscitive, it sounds archaic, but the cognoscitive powers of the mind construct complicated internal structures which have all sorts of properties, Gestalt properties, what Hume later called the identity that we ascribe to things and so on, and that looks correct. And that's the way modern science looks at it. The fact that the informal expositions, to sort of motivate what you're doing, talk about identifying objects in the outside, that's fine, but you have to know how to distinguish informal expositions from the actual scientific program. And if you look at the actual program, they never looked at things outside, aside from tachistoscopic images, because they're as close as you can get to the occasion of sense.
It's about time to move on to our very eager studio audience here, so let's turn to them.
Hi, how are you? You mentioned event semantics and how that's sort of been pulled into, or is a part of some linguistic research, and I'd like to ask a question about that and just hear more about it. The way Piotrowski uses it in the article in the book that's sitting on your table, he'll take a sentence.
We've been referring to this book, and
Yeah.
I should point out it's called Chomsky and His Critics, which just came out from Blackwell's.
Right. And the article is by Paul Piotrowski, I think. And so he'll take the sentence, John boiled the water, and I'm going to ignore the sort of the larger context, but and then turn that into something that's something like there was an event of which John was the agent, and it was concerning a boiling, and the theme was water, or it terminated in a boiling, excuse me, and the theme was water, something like that, right? And then Piotrowski tries to fit that together with a syntactic account of how that how that formal representation can turn into the sentence that you hear. So you recognize in your reply that it's an open question whether that is the subject matter of this whole analysis is in the language faculty or in the cognitive cognitive
In the cognitive
system going
it's
on.
all internal, though.
Right, yeah, absolutely. Yeah.
So it's
Let's
all
assuming
syntax.
that.
It's all syntax in the sense
Okay.
that it's involved with internal computations.
Right. Fine. So the question then is and you say it's an empirical question whether it's in the language faculty or in the cognitive system. So first of all, what would be some ways to determine empirically what that is, and also what would it even mean for it to be? I have a trouble understanding what it would mean for it to be in the language faculty, because then it seems like our language faculty has certain event metaphysics built into it.
Well, not event metaphysics.
Okay.
It's well, first of all, there's no event metaphysics in the ordinary sense of event. Events are things out there,
Okay.
and all of this is formal manipulations inside. And we're now asking the question: what is the architecture of the mind? Which is like asking, what's the structure of some benzene molecule? You want to know the structure of the benzene molecule, you can't just think about it. You have to have some theory that tells you how you look at such questions. Well, the study of I think there are real answers to the question what the architecture of the mind is, but they're not going to be easy to find. You want to find out what the language faculty is? Well, you're going to when you talk about any subsystem of an organism, say the circulatory system or the immune system or the digestive system or whatever it may be, you're kind of presupposing that it makes sense to look at a complex organism as if it has components, each component having kind of an integrated character with its own properties that's worth studying in itself. But it's not separable, like you can't cut the immune system out of the body. But you're saying there's things, it's in every cell, but you're saying, look, it has properties that you can study by themselves, you can learn things about them. When you put the whole picture together, you hope you'll understand something about the organism. Well, same when you're studying the cognitive architecture. We want to see, is there a component, call it the language faculty, we don't know what it is, you have to discover it and refine it and change it. Is there a component which is critically involved in what you and I are doing in some fashion, which has its own intrinsic properties? So is it going to turn out, say, that it has particular interface conditions and some kind of internal recursive computational process? Well, if it does, then the more we understand about that and how it fits into the general cognitive architecture, the clearer these questions become about whether something's inside it or outside it. And those are very concrete questions. I mean, take, say, anaphora, what are called referential relations of intended referential dependency. Okay, are they inside the language faculty or outside? Well, that's a substantive issue. If you'd asked me 10 years ago, I would have said inside. Now I think there's evidence that they're outside, right on the edge. And the reason for that has to do with beliefs about how the language faculty works. So if the language faculty does involve optimal computation that requires cyclic derivations, and if anaphora looks at global properties, condition C of the binding theory, well, it's outside. But that's a question that you can't ask in advance. You have to ask, well, what does it look like? What does it seem these faculties are like? The more you learn about them, the more you can formulate these questions clearly. And that's the kind of question that comes up about the internal notion of event. Is it in the language faculty, the semantic component of the language faculty, or is it in some other faculty that's linked to it? And you can't, you just can't speculate about that. You have to learn about it.
And I guess that's my question. I just from ignorance have a hard time picturing what kind of empirical evidence would count in adjudicating between those.
If I'd known it, I would have said.
Okay,
I think these are the kind of questions, like, what is the empirical evidence that bears on whether an aphora is on one or the other side of the border of the language faculty? Well, the empirical evidence, in my mind at least, turns on whether, in fact, there's a single cyclic derivational process that goes, by what I call phases, stepwise. That's an empirical question, but, all kinds of things bear on it, coming from everywhere. Once that empirical question is sharpened, you can ask whether a global property of an aphora is inside or outside.
Thank you.
Actually, similar questions, I might say, arise on the phonetic side. So take, say, prosody. Prosody appears to have global properties. Okay, so is it inside or outside the cyclic derivation, which is forming bigger and bigger units? Well, if the properties really are global, it's outside. But you can't answer that, and the kind of evidence that bears on that comes from everywhere. It might come from chemistry, for all we know, when we try to figure out how these processes work.
You've made it clear that science plays a primary role in philosophy, and I was curious to know what role, if any, does philosophy play in science?
Well, here I think it helps to look at the question in a little more historical depth. If you had asked Hume, are you a scientist or a philosopher, he couldn't answer, because there was no distinction. If you'd asked Kant, are you a philosopher or a scientist, he couldn't have answered. In fact, until the latter part of around the middle of the 19th century, there was no really clear distinction between science and philosophy. I mean, if you study science in Oxford and Cambridge, it's the Department of Natural Philosophy or Moral Philosophy, because philosophy was just, science was just one part of philosophy. It weren't distinct. By the latter part of the 19th century, they sort of became separated. And after that, it's really a matter of choice. Disciplines don't exist. We construct them. So, deans have to have ways of organizing departments because it's too much trouble to have everybody do everything. But there's no boundary to what's in chemistry, and there's no boundary to what's in philosophy. It just depends what philosophers want. People call themselves, who come out of this tradition and want to study. And a lot of what they want to study is questions in the foundations of science, or say the kind of things that Bas van Fraassen is trying to clear up using the results of science. These are all fine questions, and people tend to call them philosophy. You could call them, parts of them at least, you could call thoughtful science, or reflective moral theory, or you call them anything you want. But there's a range of questions which have come to be in the domain of philosophy, and they can extend all over the place. There are people in philosophy departments who are working on the foundation of quantum theory and making contributions to it.
Hello. I'd like to go back to insect navigation once more. And I take it that we explore insect navigation because we want to find out how insects navigate in their natural environment. And you're right to point out that in an experiment we can replace the sun by an artificial light and so on. But it seems like we still in the whole explanatory context we cannot just do without the sun and the actual objects in the real world, because otherwise, an explanation of insect navigation becomes meaningless. And so it seems to me that we have to have the assumption that insects represent the actual sun and not just dots of light.
No, we don't have to have that. In fact, the way science works, of course, you're interested in the outside world. But if you're taking a physics course here, they don't use videotapes of what's happening outside the window, because it's just useless. It doesn't let you figure out how the world is working. So you disregard that. beyond the earliest stages of science. I mean, at the earliest stages, yeah, you see apples falling from trees and that kind of thing. But as soon as you get anywhere, you start designing artificial situations called experiments in which you try to refine the evidence so that it will shed light on principles which you believe will ultimately bear on what's going on outside the window, but that's not what you're looking at. When you're studying an organism, say an ant, you don't necessarily, I mean, yes, you start with noticing that, you know, the ant is figuring out where the sun is, and as a very strange computation. We can't do it as a function of time of day and time of year. But as you go beyond, you ask, well, what are the actual computations going on inside that? And if you could get far enough, you would set up experimental situations in which you wouldn't bother with the sun. You'd figure out what those internal computations are. You then find that they interact with all kinds of other things. You know, they're not done in isolation. And out of that, you expect you're going to shed some light on what's going on when the occasion of sense that the insect is operating on happens to be connected to an external object, like the one 93 million miles away. But that's just kind of like a consequence of the investigation of the ant.
But if I could follow up on this question, I mean, this seems to be inconsistent with what you say in this reply to Ludlow here, where you're quoting Gallistel, right? So you say, Gallistel 1990 argues that the representations play a key role in animal behavior and cognition. Here, representation is understood as an isomorphism, a one-one relation between mind-brain processes and an aspect of the environment to which these processes adapt the animal's behavior.
It's not inconsistent. He's making an empirical claim, which is a very interesting one, and which is an introduction to a couple of volumes on animal representation.
Right.
And his conclusion, which I quote there, is that for animals, there is in fact a one-to-one relation, an isomorphism between an internal event and some property of the external world, like an odor. It's the example.
Right.
So the property of the external world was a particular odor, which is out there in the world, all right, but you could, if you knew how to do it, you could just use the sensory organs. And he says that's the way animal representation works, with this one-to-one correlation between things that are outside the animal, though you're really studying them at the sensory boundary,
Right.
and the internal representations. Well, if that's correct, that's an interesting fact about animals, and they're very different from humans in that case.
So then maybe he's right about
It could
ants.
be, yeah. It could be
Okay.
that they take the example I mentioned there. I think it's taken from him,
Right.
that an ant, some species of ants at least, will identify a corpse of a conspecific on the basis of a particular odor. Of course, if you give that odor and there's no conspecific around, they'll do exactly the same thing. Because according to this picture, he's saying, well, it's just triggered by the odor, which usually happens to come from a conspecific. But if you could control odors the way you can control lights, you could get the same behavior, according to him, if there's no conspecific.
Uh-huh.
Yeah, but just one more clarification question. It seems to me that no scientist can claim he has explained any kind of animal behavior if what we take to be its natural environment doesn't play an essential role in this explanation. And so I think if the relation between an ant and the sun, for example, it doesn't show up in this theory, then we haven't really explained what we wanted to explain.
Well, it depends what you want to explain. If you, let's say the sciences, as the modern sciences have developed since Galileo, this is something of an innovation, they really are not trying to account for the phenomena of experience. I mean, indirectly, that's what motivates them. But what they're trying to do is discover the principles that enter into the way the world functions. And if you ask the guys in the physics department here, can you explain this videotape of what's going outside the window, they won't even bother answering. I mean, they can't say anything about that. It's way too complicated, way too many factors, and it's not even their topic. Their topic is to find out the principles of nature. So like when Galileo had a lot of problems with this. If you go back and look at the history, he had a lot of trouble convincing the funders, the rich aristocrats, who were the funders in those days, convincing them that it's worth studying something as ridiculous as a ball rolling down a frictionless plane. No, because first of all, there's no such thing. Who cares anyway, you know? It was a conceptual breakthrough to get to the point where you began to understand that the phenomena of the world are of interest for the sciences insofar as they provide evidence for the principles of nature. And as soon as you proceed very far, you find out that the ordinary phenomena of nature is useless for this purpose, and you do what are called experiments, and sometimes thought experiments. Like you look back at Galileo, there's no reason to believe he ever dropped balls from the top of the Tower of Pisa. If you look at the argument, he gives a purely conceptual argument, convincing one, to show that that's what's going to happen. And it didn't matter whether you observed it or not. In fact, you don't observe it. But because his argument was convincing because of the logic of it. And that's true of a lot of his experiments if you read through them, you know, scholars have now determined he couldn't have carried out those experiments. There was no way for him to do it. Some of them he probably did, you know, some of them he was thinking about. But the point is, almost none of them had to do with observations of, you know, what you just, a casual look at the world. The same with the theory of perception. So, for example, take an example of Descartes, which I'll adapt to this situation, but it's a Cartesian example. He says, if I look out there, what I see is a lot of people sitting in a room. Well, Descartes points out, you know, literally that's not what's hitting your eye. What's hitting your eye is, you know, something that's coming from that guy's head and that guy's foot, but there's nothing about people sitting in a room. Nevertheless, what you see is people sitting in a room. And then he says, well, how does this happen? And then comes the whole story about, on the occasion of sense, the cognoscitive powers make these complicated constructions, which include imposing the structure of people sitting in a room on these fragmentary sensations that are coming to me. But you don't, in perceptual psychology, as it proceeds, you don't study phenomena like people sitting in a room. That's just way too complicated.
But this isn't fair to the questioner, though, because he's not arguing against idealization. I mean, you could have a perfectly controlled experiment and still talk about,
That's right.
For example, in a simple, take an old sort of Skinner-type experiment with a pigeon pressing a bar. I mean, you can describe that behavior as the pigeon moving its claw or whatever, or you can describe it as bar pressing behavior, right?
That's
now, so I mean, this is not, it's not an issue about idealization.
No,
the questioner could easily say.
Yeah, but we're asking, he was, well, at least I understood him to be asking something different.
Okay.
If the scientist cannot give an account of my seeing people in a room, they're not giving an explanation. That's far too strong. I mean, the scientists are giving explanations even if they can't get anywhere near describing real-life situations, and in fact, that's about all of modern science. The bar pressing is an interesting case because Skinner did impose on it the interpretation bar pressing, and that turns out to be wrong. It turns out with closer look that the pigeon pecking, which is what it was doing, actually incorporates different instinctive behaviors. The behavior of pecking for a seed and pecking for water turn out to be different instinctual behaviors, which happen to converge in this experiment. You just mislead yourself if you call it.
But isn't that Skinner's mistake? Is that he was an internalist, and if he'd been an externalist, then you would see that pressing for a seed and pressing for water are different behaviors.
No. It has nothing to do with externalism and internalism. I mean, the motivation for distinguishing seed from water comes from observing pigeons. But if you want to really carry it out further, you'll find out what's going on in the pigeon's head on the occasion of sense. And if you could carry out the programs far enough, you'd forget about the seed in the water. Just like David Marr does. He doesn't talk about external things because he's trying to really discover what the principles are. So it's nothing to do with internalism and externalism. What it has to do with is giving the right idealization or the wrong idealization. Okay. And we're always doing that. I mean, every experiment involves, you know, all kinds of interpretation as to what you're going to think about this thing and that thing. As the sciences get more refined, you try very hard to, not to cut it out, because you can't, but at least to be consciously aware of what you're putting in. Yeah. So you can sort of compensate for it if it's the wrong thing to put in.
Okay. Next question.
Hi.
I think I have a much less sophisticated question than the previous one. You have characterized I language generally as an interface of sound and meaning. And at the same time, here you've also been very critical of the various senses of the term meaning and reference. So I just wanted to ask you if you could clarify, what do you mean by meaning?
Well, I mean, that's, again, like David Marr saying, I'm trying to figure out how you see an elephant. We start with the intuitive notions of sound and meaning, whatever they are. And, you go back to Aristotle, and he describes language as a pairing of something like sound and meaning, saying it in Greek. That's where we start with. But as we proceed, we're going to have to refine both of these notions. So sound, as it's used here, doesn't have to do with what you and I call sound in ordinary talk, and meaning will be something very special. So like maybe it'll be, Davidsonian event semantics. Okay, maybe it'll be something built on that, and maybe sound will be something built on, my colleague Morris Halley's conception of instructions for articulatory gestures, or it'll be whatever it turns out to be as the sciences progress. And it'll end up having some loose relation to what we call sound and meaning, but no more so than energy or work or life or any of the other concepts that are dropped in the sciences, although they often keep the sounds when they talk about their new concepts. So that's to be answered, not to start with.
Okay, thank you.
Okay, I guess that's it. Thanks a lot.
Okay.
Appreciate it.
Noam Chomsky is a dominant intellectual figure in our world. He's also a professor of linguistics, a field about which few people know very much. Today we'll try to rectify that imbalance a little bit. Professor Chomsky, can you describe in a few words what modern linguistics is?
Well, it's very diverse, has many different aspects, but the parts that I've personally been involved with for the last half century or so study language as part of the biological equipment of a person, so some component of mostly the brain, which is specialized for particular tasks, including computational tasks and tasks of action that seem to distinguish us rather radically from other species, and apparently are pretty recent evolutionary innovation. And the attempt is to find out, first of all, what a particular instantiation of this capacity is. So say the one that you and I more or less share, not exactly, but closely. Find out what are the rules and principles and so on that allow us to do what we're doing now. And more generally, to find out what is the range of possible diversity of such instantiations, possible languages, something that's determined by our genetic endowment and allows a limited variety of systems, each of which is extremely rich in expressive power. And then there are further questions like asking how, what happened in the history of these systems, how do they change from one to another, how do people use them to talk about the world or make plans and so on, how does it connect to an articulatory and perceptual apparatus, what's going on in the brain while all this is happening, someday, how did the system evolve? Hard question. This whole range of topics falls within what's sometimes called biolinguistics, the study of language as a biological capacity. And most other aspects of the study of language, language in societies, linguistic change, and so on, basically presuppose similar assumptions, more or less, sometimes explicitly, sometimes tacitly.
Your most famous sentence is, "Colorless green ideas sleep furiously." Can you tell us a bit about the significance of that sentence?
Well, actually, it had almost no significance, so I don't know why it's so famous. It was just picked as one of, if you look at, it's actually in a textbook. There was a book called Syntactic Structures, which actually was course notes. It wasn't written for publication. It was course notes for an undergraduate MIT course back in the mid-1950s, which some publisher picked up and stuck in a couple of footnotes and published. But the point of the example was just to illustrate a few elementary points, which were inconsistent with common assumptions. The question is, what makes a sentence an intelligible grammatical English sentence or any other language? One assumption was, well, it has to be meaningful in some independent sense. Well, that one isn't meaningful. Another was it has to have the proper formal elements like ly, ly, less, and so on, have to give a frame, and then you just put words in it. Okay, well, this has the same form as completely crazy sentences. I gave another example, so that can't be it. Another was that its statistical properties are close to those of English texts. So if you look at the probability of every pair of words in it, that'll be like the probability of those words in English texts. Okay, it doesn't have that property. And in fact, of the familiar proposals about the nature of English sentences, this was a short example that happened to be inconsistent with all of them. So it was one of a series of such cases, and for some reason that one became famous. I don't know why.
To me, at least, it's also always demonstrated something more positive about language. In other words, it didn't simply disprove other people's ideas, but to me, I think it's also an example of a particular computational property of language.
Well, it raises the question. I mean, I don't think it really answers anything, but it raises the question: what's going on that makes that sentence so different from, say, the same sentence backwards, or other sentences that look as if they're the same form but are perfectly fine, like, revolutionary new ideas appear infrequently, say, it's more or less the same form. Why is that one perfectly normal and this one somehow a little odd? So it doesn't really answer questions. It poses the question, how are we able to understand these things? In fact, the other sentences in the list, this is an introductory lecture, and there's a series of examples there. The other ones raise much harder questions. The questions about where WH phrases, question words come from and how they fit and what we know about them and so on. Those are hard questions. Still lively questions, in fact.
It's often said that you revolutionized not only linguistics, but also how we study humans in general. What do you feel is the most important aspect of that revolution?
Well, this is in the 1950s, and there was a shift in perspective that was taking place from many points of view at about that time. At that time, study of humans, psychology, was called behavioral science, and it was a study of behavior. Here's what people do, and we got to somehow figure out a way to more or less mimic what they do. Have a predictive apparatus that'll say, here's what they do. In linguistics, was similar. There's structuralist tendencies which were dominant, sought to identify some pretty superficial structural properties that you could find in language, and that that maybe you could find some generalizations across languages. But it was all very phenomenon-oriented. And the shift that was going on was a gradual shift, led to what's now cognitive science, was to search to really a different question. Not what are the phenomena and how do we sort of mimic them, but what are the inner mechanisms that are determining the phenomena. So the behavior, instead of being the topic of investigation, is just data. And it's useful data if it helps you understand something about the inner mechanisms. If it doesn't help you, it's not. And other data would be fine too, and so on. It actually, I think, should be looked at as a shift of the study of psychology from a descriptive, taxonomic investigation to it's something in principle part of the sciences. Maybe it'll become part of the sciences as the results become deep enough. I mean, the sciences, if you study physics, for example, you're not interested in describing the phenomena outside the window. What you study is the data by now, after centuries, comes from carefully controlled, designed experiments intended to illuminate what you take to be underlying principles of nature, which may tell you something about what's going on outside the window, but that's not the topic of investigation. The topic is the principles of nature that determine what's happening. And any phenomena are useful for this if they contribute to it, otherwise they're uninteresting. But the phenomena themselves are not the topic of study. So a physicist or a chemist or a biologist do not take videotapes of what's happening and say, okay, I'll try to find statistical patterns in this or something of that sort. That shift led to, some people call it the cognitive revolution. I don't like the phrase myself particularly, but the shift in the study of language was part of that, and also in many ways an impetus to it. Many other things modeled themselves on it, although other things were happening in the same kind of intellectual milieu. Many of them going on in the same place, Cambridge, Massachusetts, in fact.
You're describing an intellectual shift, and to those of us who didn't experience that, it often seems peculiar that people, in a sense, refuse to think about the mechanism. It almost seems to have been a religious belief on the part of the earlier practitioners.
It's still true. I mean, if you counted noses of people who investigate the field, it remains very substantially a descriptive taxonomic field. That's often even a theoretical drive. I mean, you can read technical professional articles now that say all this search for inner mechanisms is pointless. What we ought to be doing is modeling the actual phenomena. So our goal is to try to develop some quasi-predictive apparatus which will yield something approximating the actual data of sentence production, which would be as if a physicist were to say, well, my goal is to model a videotape of what's happening outside the window. It's an attitude which is quite divorced from that of the modern scientific revolution, but it's very prevalent in fields that have to do with human capacity and behavior. Actually, people who study insects don't do that. If somebody's interested in insect navigation, they don't take they're trying to compile videotapes of ants running around the ground. They're trying to figure out what it is about an ant that enables it to do some rather phenomenal things, which you and I can't do. Like you and I can't carry out what's called dead reckoning. You have to do it with instruments if you're a sailor or something. But this means sort of traveling around on some random path, and when you get where you want to, let's say a piece of food, heading straight back to the nest in a straight line. You and I can't do that, but a desert ant can. And an insect scientist will, as I say, not be taking videotapes of ants, but trying to figure out what are the computational mechanisms in an ant or a bee or something that enable it to carry out extremely complex navigational tasks. Well, that's science. Taxonomy or description would be trying to model phenomena.
So when you talk about biolinguistics, what you're saying then is that we need to approach language in the way that scientists approach insects
Yeah.
or any other form of animal behavior.
Or anything, whatever you happen to be studying, chemical compound. I mean, the thrust of modern science for centuries has been to try to discover the principles, inner mechanisms, and so on, that interact in some fashion to yield some part of the phenomena that we observe. And the more advanced the science, the less they are interested in the phenomena that you find all over the place. So for really advanced science, the striking phenomena are those that are often created in the laboratory in order to test theoretical assumptions that aren't settled yet. And it's the same with linguistics. I mean, why do people study things like, parasitic gaps, which you almost never hear in speech and are pretty hard for people to understand? Well, the point is precisely because they are exotic, meaning nobody's had any experience with them, but people do have sharp and consistent judgments about them. And they answer hard questions about internal mechanisms that you would never even know exist if you just looked at the phenomena around you.
Maybe we can switch to talking about languages rather than language. Languages are disappearing at a rapid pace due largely to globalization and economic factors. A century ago, we had about 5,000 languages, give or take. And some predict that a century from now, we'll have only 1/10 of that number. How should linguists respond to those developments?
Well, first of all, I think we ought to add a corrective, which professional linguists know but isn't in the common discussion. I mean, the languages are disappearing just as fast in places like Europe. I mean, Europe had a huge variety of languages a century or a couple of centuries ago. In fact, even in our lifetimes. And they're disappearing very fast. So one of the main, as you know, one of the main linguistic projects in the world is the European Union project on what they call dialects, but they're really languages like, Italian dialects or German dialects, which are just disappearing. I mean, people can't talk to their grandmothers, because they talk different languages. And that happened not so much through globalization as just through imposition of national states and national cultures. So, you go back a generation or two, and Italian was a second language for almost everybody in Italy. German was a second language. You studied it in school. You spoke whatever language it was, and they were often mutually unintelligible and quite different. And they've been leveled. There's been a kind of a leveling through state formation, television, common educational systems, and so on. So in Europe alone, there's rapid disappearance of language. And the kind that we're concerned with, that you bring up and is of great concern, is that it's happening all over the world. What linguists, of course, this is losing cultural wealth and cultural variety and the richness of human creativity and contributions at a very rapid rate. It's kind of like destroying, the museum, the library in Alexandria or something, or what just happened in Iraq, destroying the record of civilization. And a lot of this happens to be non-writing civilizations, so there's no written record left. And the linguists are, of course, trying to capture as much of it as they can and try to revivify it, try to revitalize the languages. So Ken Hale, our former colleague who died recently, a large part of his life's work was trying to invigorate communities to revive and study and teach and spread their own language. And he brought people to MIT to get graduate degrees in linguistics, people who often had not much formal education, and ended up being very good professional linguists, went back to their own communities, started educational programs, took part in not only maintaining the language, but expanding, reviving knowledge of it and trying to make it a living language again. That's happened in some places. It's failed in other places. Europe as well. So, say in Wales, without any national effort, the language kind of revived. You hear kids in the streets of Cardiff talking Welsh. In Ireland, where there was a national effort, it's apparently mostly failed. When these things work and when they don't work is hard to say, but reviving the communities, the cultures, the languages, and where that's not possible, at least salvaging the record of them is a very significant task.
Would it be harder to do linguistics with fewer languages?
Sure. Just losing evidence all the time. I mean, if we had only, English, let's say, we wouldn't have a clue about the principles of English because you learn about them when you study other languages. I mean, when, say, Jim Huang did the first serious modern studies of Chinese, that immediately led to discoveries about English. That it was not, you didn't learn new phenomena of English, but you suddenly realized that these are strange phenomena and they have to be explained. And that led on to other things. And the same is true of any range of languages you look at. I mean, just as if you didn't have a lot of chemical elements, you might be highly misled about the nature of elements.
Really a reverse question here. A century ago, there was great interest in universal languages like Esperanto. In fact, many of the founding members of the Linguistic Society of America were interested in questions of universal language. And some of the earliest support, financial support for linguistics came from people and organizations that were interested in universal languages. And in part, or a large impetus for that was the feeling that people had difficulty understanding one another across cultures. There's much less interest in international languages today, in part because people say that English is now the universal language. Is that a good development, this ascendance of English?
Well, there are separate issues here. I mean, the interest of linguists, as linguists in universal languages, was based on an illusion which linguists had but no longer have. That was the illusion that Esperanto is a language, and it isn't. Esperanto is a couple of hints that people who know language can use based on their own linguistic knowledge to make a language out of it. But nobody can tell you what the rules of Esperanto are. If they could tell you that, they could tell you what the rules of Spanish are. And that turns out to be an extremely hard problem, a hard problem of the sciences, to find out what's really in the head of a Spanish speaker that enables them to speak and understand and think the way they do. That's a problem at the edge of science. I mean, the Spanish speaker knows it intuitively, but that doesn't help. I mean, a desert ant knows how to navigate, but that doesn't help the insect scientist. You've got to figure out what the ant's doing. And it's now understood that that's an extremely hard problem. You go back a generation or two, it was considered a trivial problem because of lack of understanding of the nature of language. I mean, to take a kind of an analog, if you go back to pre-Galilean times, there was no problem about if I let this go, it's going to fall to the ground. It's going to its natural place. Well, what else is there to say? Well, it turned out there was a lot to say. To be puzzled by simple questions is a very hard step, and it's the first step in science, really. And the same is true about the nature of Esperanto or Spanish, or on which it's largely based, and so on. We don't know the answers to the questions of what the rules and the principles of Esperanto do, because if we did, we'd know the answer to how language works. And that's much harder than knowing how a desert ant navigates, which is hard enough. So now it's understood that Esperanto isn't a language. It's just parasitic on other languages. Then comes a question which is not a linguistic question, but a question of practical utility. I mean, is it more efficient to teach people a system which is parasitic on actual languages and somewhat simplified, so it doesn't have some of the details of actual historical languages? Or is it more efficient to just have them know a lot of languages? And I think it's pretty widely accepted that the latter is better, and not hard. I mean, it's a little misleading in the United States. The United States is unusually monolingual. as compared with, say, Europe a generation or two ago. And the reason is not linguistic, it's that the people who conquered the United States essentially exterminated everybody. If you exterminate the native population, then ends up monolingual. But Southern California alone probably had hundreds, thousands of languages, and they're all gone, or mostly gone. So in the United States, people tend to know one. Well, actually, the languages that are spoken in the United States, which we call English, are sometimes mutually incomprehensible. I mean, I remember giving talks in eastern Kentucky where I could understand the students in the colleges because they were taught standard English as a second language. Like students in Italy were taught Italian as a second language. But when I walked through the streets, I could barely understand what people were saying. Or where I happened to grow up in Philadelphia, which is urban Philadelphia. I mean, I would sometimes take the trolley car somewhere, and there'd be a kid sitting behind me in the next row, and I couldn't understand the word they were saying. I mean, they were talking what's now called, Black English, which is just another language similar to my English, but not the same. So there is a variety of languages in the United States, but much less than in areas of comparable scope, largely because of the nature of the conquest of the continent. But in many parts of the world, it's completely normal for a child to grow up speaking a number of languages. I mean, West Africa, say, maybe the mother speaks one language and the father speaks a different language and your aunt speaks another language and the kid just grows up knowing all of them. So it is perfectly possible for children to grow up without effort, knowing plenty of languages, and even not living in that cultural milieu, it can be done. And the question is whether that's a more efficient mode of organizing the world than teaching an extra language which is modeled on the existing ones, but somewhat leveled so that it becomes easier for, say, Romance speakers.
Linguists talk about language as consisting of a grammar and a lexicon of the words of the language. And I think one of the themes of today's discussion has been the extent to which people ask questions that they hadn't thought about before. And non-linguists, when they look at language, the questions that they ask tend to be questions about words and not about the grammar or the structure of the language. The grammar, for them, is not even worth discussing.
Because it's so natural. I mean, you just do it. Like if ants could talk, they would think there's no problem at all in doing dead reckoning. We do it all the time. What's the big problem? And we speak all the time and understand what we hear and produce novel utterances. And if linguists decide to use us as subjects, they'll give us sentences sometimes which we know are gibberish or make no sense or just don't conform to the language, and others which we have to think about and try to figure out what they mean. But we do it it feels instinctive, so what could be the problem? But that's like things falling to their natural place. There's a huge problem. Or the ant navigating. How is it done? And in fact, the same kinds of questions arise about words. As soon as you start thinking about the meaning of a word, it becomes incredibly intricate. Actually, this goes back as far as Aristotle. Aristotle raised the question, what's the meaning of the word house? Actually, he didn't put it that way. He said, what's the nature of a house? The way we would say it is, what's the meaning of the word house? And he pointed out it can't be just a collection of bricks and wood. It also must be something that has a specific design and function. So a particular arrangement of pieces of wooden bricks could be a house, or it could be a garage, or it could be, we can go out and play with it, could be a paperweight for a giant, or it could be all kinds of things. What it is depends on the design in the mind of the creator, the use to which it's put, the function it serves, and so on. And if we look at the word more carefully than Aristotle did, we find many more varieties of complexity. So for example, if I tell you that I painted my house brown, you know that it means I painted the exterior surface brown. If I want to tell you I painted the interior surface brown, I have to say I painted my house brown on the inside. Markedness, it's called. Like if I tell you I climbed the hill, you know I went up. But if I can say I climbed down the hill, but I have to add something to tell you I was going down. Well, house is the same. It's basically a surface, an exterior surface, although we can complicate our description of it and focus attention on the interior surface. And it's much more complicated than that. It's not just a surface. If it was a surface, only a surface, then you could be near the house if you're inside it. If you're inside a mathematical cube, you're near the cube, because the cube's just a surface. We can't think about it like that. The way we use the word near or in or something, it's not just the surface. It's a closed surface, and it doesn't even have to be closed. Like if you take a lean-to, a thing which just looks like an upside-down L, there's an inside and an outside. If you take a mountain, it's the same thing. It doesn't have to be an invented artifact. And without proceeding, as you go on, you find the simplest word you can think of. Book, tree, person, anything you like, has immense layers of complexity, which are barely understood. I mean, investigating them is also a scientific problem. Barely the surface has been done. So the words seem just natural to us, but that's like navigating seeming natural to an insect. It doesn't mean it's simple. It just means it's the kind of thing we're built to do. And if you want to look at it from if you want to discover what it's about, you have to look at it from the outside. Looking from the inside doesn't help. And you have to look at it the way Galileo looked at the fact that you drop something, it falls down instead of up, and at a particular rate, and as a particular function of time, and so on and so forth. And those turn out to be extremely hard problems and the beginnings of modern science.
Some of what you're talking about raises the issue of the connection between language and perception. And there have been a variety of views on that relation. Probably the best known and the one that linguists have the least use for is the notion that your language affects your perception. I'd say at the opposite end would be the notion that there's nothing special about language, it's just part of that perceptual, or based in that perceptual apparatus. You really seem to occupy a middle ground.
Well, the first point of view, famous is the Whorf hypothesis, it's called, is that the nature of your language determines the way you see and understand the world, which it's been extremely hard to put any meat on that hypothesis. I mean, Whorf, who was a major linguist, happens that he was an insurance salesman, but he made extremely important contributions to linguistics. This hypothesis is the least of his contributions, and his actual proposals, while they kind of seemed persuasive when I was a college student back in the 40s, as soon as you think about them, they're not very persuasive. So one of his main examples was that one of the languages he was studying was Hopi, and he argued that Hopi has a different way of dealing with time than what he called standard average European, which would include English. So you and I think of time, at least I do, I assume you do, as a kind of a line with yourself standing on the line, looking forward toward the future and over your shoulder toward the past. And he argued, well, that's because European languages have past, present, and future tense. But Hopi doesn't have that system. They have some other system. He said they don't think of time that way. Well, there are a couple of problems with that. One problem is that English doesn't have past, present, and future tense. So if you looked at English the way he was looking at Hopi, what you would say is that the way we think of time is past and non-past, and then there's a bunch of modalities like necessity and optionality, and among them is futurity, just one of the modalities, because that's the way English syntax works, but we don't think of it that way. So how do we know that the Hopi don't think of it that way? It's not in their language either. And most of the examples kind of collapsed from that kind of analysis. There has been an effort to try to find something, and there's been a revival of it in the last couple of years and some suggestive work. But if there's an effect, it's extremely hard to tease out on perception. There may be, but it's not going to be easy to find. On the other hand, the other extreme, the idea is, well, language is just part of perception. I mean, now we're back to things falling because it's their natural place. I mean, as soon as you look at perception, it turns out to be an extremely complex affair with none of the properties you superficially imagine. And those properties just don't look like the properties of language, which is a different kind of system. I mean, it just, prima facie, it would be very surprising if language were a reflection of perceptual capacities. The one obvious reason is that we share, to a very substantial extent, we share our perceptual capacities with other primates, but they don't have language. So something's different. And the question is what it is. And it turns out to be radically different as soon as you look into it.
Perception leads me to think about production. I'm going to ask a somewhat selfish question because it relates to my own particular research interests in the last few years. I've been doing a lot of work on sign languages. And at first they seem to be quite radically different from spoken languages because you're not speaking. And I think, to my mind at least, one of the great contributions of modern linguistics was to legitimize the notion of sign language.
Yeah, that's very modern. After the days when you were a student, in fact, as you know. It's really the last 20 years or so that it's been discovered that sign language is a human language with very much the properties of the kind we're familiar with. And that came as a big surprise. And now sign language is, by linguists at least, studied as a language just among other languages. Like, we, as you know, at MIT, there's one graduate course every year, which is called unfamiliar languages or something. It can be a language of Africa or something like that. But a couple of years ago, the language chosen was American Sign Language. It's just another language. Let's try to figure out how that one works. And the similarities between sign, there are many different sign languages, of course, and they're mutually incomprehensible, but the properties of these languages turn out to be remarkably like those of spoken language. I mean, even their neural representation turns out to be similar. So, it was originally assumed that sign language would be mostly right hemisphere specialized because it's visual. Well, it turns out to be left hemisphere specialized in very much the way spoken language is. And if you look at that work by, I'm telling you things you know better than I do, so I feel funny saying it, but if you don't mind not laughing, the work of, by people like, say, Ursula Bellugi and Ed Klima and their lab has led to some discoveries about the neural representation of spoken language, which are surprising too. Turns out the left hemisphere specialization is kind of local rather than global. So like for discourse construction, it seems that right hemisphere dominance is significant, whereas for word or sentence construction, it's left hemisphere specialized. And something similar seems to be true of sign language. Discourse looks right hemisphere specialized, but sentence construction or particular sign construction looks pretty much the same as the spoken language, which is a surprise because the spoken specialization is near the motor areas, and they're just totally different motor areas for sign. So lots of things are coming out which are pretty surprising and are shedding new light on spoken language, but this just looks like another normal language. Actually, acquisition of sign follows the same, as far as is known, essentially the same course as acquisition of spoken language at the same times and the same maturational process and so on. So it has been extremely illuminating. Also, there are apparently invented sign languages, as far as anyone knows. The one that Judy Cagle, others are studying in Nicaragua, looks as if it was invented, not borrowed, or by somebody who did invent it, but just invented by the community, the signing community. So it's a case of a very recent, apparently, invention of a language which looks like pretty much every other language we know.
It seems to happen when you simply bring a community together.
Yeah. Actually, there's some cases on record, few, not many, of children who have invented their own sign language. There's one famous case, the one studied by Susan Golden Meadow, and they found a couple of children, cousins, who were non-hearing, but whose parents were hearing, and the parents at that time were indoctrinated not to teach the children sign. They're so deeply indoctrinated, they were taught not to make gestures. So, parents would walk around with their hands behind their backs. Well, it turned out that these kids, on their own, just playing together, invented a language, a sign language. They were found at, I think it was about ages 3 and 4, and what they were doing without the parents' knowledge, just something they did when they, or if the parents saw it, they didn't know what was going on, some language that they had created. It was at the level of the character of spoken 3 or 4-year-old language. Well, of course, as soon as the kids were found, they were put in an environment where they learned American Sign Language. So experiment ended. But it looked as though it was a spontaneously invented, normal human language by a couple of kids in a single generation.
The legitimation of sign language, does that raise issues about the connection between language and speech? At least when I grew up academically, we thought of speech as essential to language.
It's certainly a challenge. I mean, it's a devastating challenge to it. It seems to indicate that whatever is special about language may be modality independent. I mean, how independent, we don't know, but at least sign and spoken language seem to share deep characteristics, to develop in pretty much the same way, and as to the little that's understood, to have the same kind of neural basis. So yeah, that does dissociate language from speech pretty sharply, or at least a large part of language. I mean, it indicates that whatever the sensory motor apparatus, which is, there independently of language, and it's not all that different than other primates and even mammals, it's certainly imposing constraints on what language is, but it looks like those constraints are much weaker than one would have assumed, say, 20 years ago. And that whatever else is going, that the nature of the computational systems is somehow much less dependent on the specific form of externalization than one would have taken for granted in the past. I mean, that doesn't mean that the study of sound structure of language or production is any less interesting than it ever was. It just seems that it's less essential to the nature of language.
Your most recent work is quite novel. Can you give us a bit of a flavor of some of this new work?
The so-called minimalist work. Well, it's known to any biologist or anyone who thinks about it that if you look at the nature of an organism, there are a number of different factors that enter into what the nature is, like, say, the visual system of a cat, let's say. I mean, one factor that enters into it is the genome. What's the genetic basis for the development of a cat's visual system? So that's one factor. Another factor is what's the actual visual experience that the particular cat had. And it's known experimentally, it's been known for about 40 years, that you can modify the very early, first couple of weeks, the visual experience, which will, in a way which will change the structure of the visual system. It'll even change the neural structure of the system if you present, say, horizontal lines versus vertical lines in the first couple of weeks of life. So one factor is the genetic endowment. Another factor is the experience. If you take human language, there's a very rich genetic endowment that says we're going to have a language of a particular type. I mean, a Martian looking at us the way we look at, say, bees, would say we're all talking the same language, just even less varied than bees. There's a lot of different species of bees. There's only one species of humans, and they seem to have almost the same language from the point of view of an outside scientist looking in. So there's a rich genetic endowment that says, got to be one of these things. But there's also an affective experience, like, we're talking English, not Swahili, so that's some affective experience. But then it's also known that there are other factors, just the way the world works, like chemical and physical laws, or for language, probably the way computational systems work, what efficient computation is, and so on. And that's another factor that enters into what the outcome is. That's an extremely hard problem in biology. It's, you sort of study it, but it's out on the periphery. It's a hard problem. And the work that you're referring to in language, the recent work, is an effort to study how those factors enter into the nature of language. So how do principles of efficient computation, for example, enter into the properties of the language systems that we see? And it's controversial. This is very recent work, but at least my own opinion is that it turns out to be a major effect. And a lot of things that we thought were specific principles of language may in fact just reduce to the way efficient computational systems operate. I mean, at this point, it wouldn't come as an enormous surprise. I mean, I'm not suggesting it, but it would not come as an enormous surprise to discover that some of the crucial factors in, say, insect navigation are also showing up in human language and contributing to its nature. But that's, research topics underway and properly very controversial.
Thank you, Noam. I hope we've learned a little bit today about linguistics. We have some time for questions, if you would.
Yeah, my question is, you often express doubts or question the notion of a publicly shared language, but couldn't we think of, say, standard English or the Latin of the Middle Ages, academic Latin, as something like a invented shared language?
Actually, it's odd that these are called my doubts. Those are the doubts of every linguist. In fact, one of the first things you study in the first freshman course, usually it's done, you're taught a joke that was attributed to Max Weinreich, that a language is a dialect with an army and a navy. But there's no such thing, things are called languages because of colors on maps and, continuity of empires and all sorts of things. But it's certainly true that, within, like Mark and I and you, to some extent share a language. We're all talking to each other without too much trouble. If a linguist were looking at the three of us, they'd say, well, there's three different languages there which are kind of very similar, so they can get by. And over some range, you can decide to call the more or less similar languages a shared language if you want. It's not a linguistic observation. It's a practical discussion. Sometimes things are invented. Like if two professional linguists are talking, we're going to talk our own language, which nobody else is going to understand because there's all kind of special concepts in it and all sorts of other things. And yeah, that's a shared language. I mean, if I talk to, there are things I can talk about to monolingual Japanese, which I can't talk about to my children, let's say, because we just share some sub-language that's invented, purposely invented. When you talk about standard Latin, it was kind of something like that, partly ossified, partly created. But these are not linguistic notions, that you can draw the lines where you feel like.
Professor Chomsky, the expression, the lexicon, came up in the discussion. As you know, colleagues of yours at MIT tell us there is no lexicon. And in fact,
here we are. He's one of the people who's done the major work showing there is no lexicon.
And in fact, there are no lexical categories, adjective, verb, nouns. Any personal views on the existence of lexical categories? Or
categories, no, that's not lexicon, but
yes,
categories like noun, verb, adjective.
Yes, exactly.
Yeah, well, there is a view which I think is compelling and suspect is probably right, that the atoms from which bigger constructions are formed, what I'm loosely calling the lexicon, though it turns out to be pretty complex. Again, I defer to Mark, who's been working on the complexity of it. But abstracting away from that, there are some kind of atoms out of which expressions are formed. Question is, do they have categories? Like, are they in the categories noun, verb, adjective, and preposition, and so on? And there is a view, which I think to which you're referring, which seems to me plausible, is that no, what there are really are roots, and the roots are category independent, and then there are particles, which in some languages you actually see, like they have a morphological realization, but in English you overwhelmingly don't. And it's the connection of those particles, which are in the head, small elements, which are in the head but only come out of the mouth in some languages, not others, that determines whether the thing is going to function as what we call a noun or a verb or an adjective. And that has things going. There are languages where this is almost obvious on the surface, like the Semitic languages. It's not 100%, but the basic structure of the Semitic languages just has roots and then ways of putting them into vocalic patterns, which turns them into what we would call, from our point of view, a noun or a verb or an adjective or something. But the claim that you're referring to is that that's basically the way it works cross-linguistically, which could well turn out to be true. What looks obvious to us on the surface is usually wrong.
Excuse me. There's a debate among some cognitive scientists and philosophers about whether we think in or with our natural language, English, say, or if there's something else going on, often called mentalese. I was wondering, first of all, if you think that question has actually been posed in any coherent manner, and if so, what your opinions about the answer might be.
Well, one of the problems with the proposal, I think there's probably something to it, but one of the problems with the proposals is comes out as soon as you ask yourself, what do we know about mentalese? Okay, so people talk about the language of thought. My friend Jerry Fodor, for example, and maybe he's right, but what do we know about the language of thought? Well, it turns out it's English, or Italian, or whatever else the person who's writing about it says. So we really don't know anything much independent about what the language of thought, mentalese, is supposed to be. That doesn't mean it's not there. It just means we don't know. There's some reasons for thinking there must be something there. There are non-speaking organisms like monkeys and apes and infants who seem to do things very much like what we call thinking, but don't have the language to express it. So it looks as if there's thought going on, but somehow without language. And furthermore, unfortunately, there's almost no science here, so you really have to deal with intuition and introspection. If you introspect, it's almost obvious that there's thought without language. A very common experience, which we all have all the time, is to say something and to realize, no, that's not what I meant, and then to try to say it some other way, which maybe gets closer to what you meant, and then you try, maybe somebody else says it, and you say, oh yeah, that's exactly what I meant. Well, all of this seems to presuppose that there's something that you meant, and whatever it is that you meant, it's apparently not what you said, otherwise the problem wouldn't arise. and to try to figure out what it is that you meant. Well, that's a problem of what thought is about. Unfortunately, there are very few ways of studying what thought is like other than through the medium of language. And that's why it's really hard. I mean, there is work on infants and other organisms which sheds a lot of light on it. So if you read a book like, say, Mark Hauser's book, Wild Minds, he's a primatologist, or a recent book by Anne and David Premack called, I think, Original Intelligence, which is mostly about non-human primates. They have plenty, and other organisms, not just like dogs and so on. They have plenty of evidence of what looks, it's hard to describe it without calling it thinking. It looks like what we would call thinking, but plainly without anything like what we would call language. And maybe out of that will come, and there's work on young children and so on too, which seems to bear on that. But so if you ask my opinion, my guess is, yeah, there's some kind of system of thought in there, which we can only get very limited access to at the moment, from the outside. I mean, from the inside, of course, we all have it.
Thank you. I think we've learned a lot today. Thank you very much.
We're here today with internationally known MIT linguist Noam Chomsky, co-author of a recent Science article on the evolution of language. That article is entitled "The Faculty of Language. What is it? Who has it? And how did it evolve?" Professor Chomsky, in your long writings about the nature of language, acquisition of language by individuals has played an important part in your thinking, and you've commented on it in depth, its nature and its significance. On the other hand, the acquisition of language by our species seems to be a new topic for you, one you haven't talked about in detail before. Are you excited about this? And give us a little bit of background on your engagement in the topic.
Well, from my point of view, it became, it's not lack of interest, it's just that I've never seen anything that could be said about it. It's both too hard and too easy. It's too easy because it is so easy to make up all sorts of possible scenarios. In fact, just they come to mind instantly, and a lot of them are in the literature. It's too hard because there's no way to tell whether any of them have any plausibility, let alone or credibility. The problem, in my view, has always been to try to parcel out the topic in such a way that at least parts of it can be studied. And that's essentially what this is about. Actually, it doesn't say anything about the evolution of language. It just says, here's a way of looking at the topic with various components, some of which can be investigated by the comparative method, which is about the only successful method, some of which might be very significant if certain ideas about the nature, recent ideas about the nature of language are correct. So if it turns out that in fact, in some interesting sense, the computational system of the core computational system has optimization properties, in particular that it's something like an optimal solution to the problem of linking interface conditions. If that's true, then there are many avenues to explore that could turn out to be interesting. They're kind of barely mentioned at the end. So there are other optimization strategies and processes known in nature, and it's conceivable that this could be one of them, in which case, matter of things as remote as, say, insect navigation or foraging strategies or the distribution of the structure of the circulatory system, which optimizes in a certain sense, could turn out to be relevant to the evolution of language. The interface systems, it's possible that here's mostly Mark Hauser and Tecumseh Fitch's work. I don't know anything about it. That they've done a lot of work on primates and even beyond, trying to investigate to what extent sensory motor systems and harder question, conceptual systems in other primates might have, or beyond in fact, might have homologous, might be homologous to humans in some respect. But that is a topic that at least can be studied by comparative approaches. And if it's true that the fundamental nature of language involves interface conditions, which are mostly there independently of language, maybe they were partly selected for language functions. If it involves interface conditions and something like optimization relative to interface conditions, which is a highly speculative idea. If that's true, then at least you can break the problem into parts that can be addressed in ways that are to some extent understood.
You seem to arrange the proposal that you make in the paper between two different poles of thinking about this topic. One is that human language is basically analogous to things found in the animal world, maybe more difficult, more complex, but not different in kind. And the other is that it's completely unique, a completely unique human adaptation. But your paper attempts to steer a third course between the two of them.
It says that...
Can you say more about that?
Well, if this is all based on the assumption that it makes sense to think of language in terms of some kind of optimization of linking of interface conditions. If that basically, if these ideas are wrong, then it's not going to go anywhere. But if there's something to those ideas, then both of the properties that you mentioned could turn out to be correct. That is, the interface conditions could be have homologous structures in other, say, other primates. But the linking seems to be human unique. And the question is where that comes from. And if it turns out to be an optimization process, there are ways of thinking about it that don't involve the selectional leap that seems almost impossible to explain.
Say more about that. In the paper, you describe the interface conditions as interfaces between a cognitive system, cognitive intentional system, and a sensory motor system, with natural language forming a kind of bridge drawn between them at various points.
And that's what seems to be lacking in the cousins, other primates. They don't seem, they have no technique of, what's lacking, and this has been observed for a long time, is something like a recursive procedure that will permit that will generate sound meaning pairs in some sense over an infinite range. Well, if the sound meaning parts are the interface conditions, and the recursive procedure is an optimization procedure, then you've broken the topic of evolution of language into compartments, each of which can be investigated. I mean, most of their work is on the sensory motor systems, which they argue really don't have any particular unique adaptation in humans, at least not a major one. On the conceptual intentional side, it's much more questionable. There are questions of how animal systems signal and how human thought is expressed raise many questions. Not at all clear that the human mode of referring to things is at all related to animal signaling. That seems to have quite different properties. And that's just the beginning. Then you go into more complicated things like, quantifier structures and so on and so forth that we don't even raise. But the real innovation in Homo sapiens appears to be the overwhelming one, is the recursive process of linking two kinds of information. One kind that feeds sensory motor systems, the other that interacts with conceptual intentional systems.
The human side, the human language makes, the bridge makes contact with the sensory motor system, and you said that has analogs in the animal world. Is that really
Maybe
correct?
even homologs, which is different. Yeah, analogs are all over the place, but the question is whether there are really homologous structures that you might trace back to before the split between hominids and other primates, 5 million years ago or something like that.
Is that the idea then that the gestural system maybe of apes is the point at which language...
Well, actually they're talking about things like the articulatory and perceptual systems. Gestural systems is a different question. I mean, human gestural systems could turn out to be like other primate gestural systems.
But isn't that a crucial component? I mean, what we know, for example, about natural language is that, this is a point that you've emphasized in other interviews, is that it's not essentially vocal. That is, it's vocal, but it's also gestural, given the existence of sign language.
Yeah, that raises new dimensions, which we don't go into there. But is there anything, because it hasn't really been explored enough. I mean, to what extent are the gestural systems involved in sign and the gestural systems that we otherwise use seem to be dissociated? Actually, this has been demonstrated pretty persuasively, I think, in acquisition of sign. I mean, there are some dramatic cases, like Laura Petito's work on acquisition of the use of pronouns, first and second person pronouns in sign and spoken language. I mean, basically it works like this. There's a stage in spoken language development, what we're used to, in which children invert you and I. So they'll say, pick you up, meaning pick me up. They regard you as, they hear you as referring to themselves, so they think that's who it is, and they hear I as referring to that person over there, so they think that's who it is, so they interchange. And then after a while, this goes away. It's a kind of a pretty standard, presumably maturational process that goes on. Well, Laura Petito found the same thing happens in sign at about the same age. And there it's quite striking because I and you are iconic. You is this and I is that. And the infants at the same age act counter-iconically. So it's not just abstract, you and I interchange, but that and that interchanges. Furthermore, it turns out that at the same period, they use this and this for pointing correctly. So they have the pointing system, iconically. They have the linguistic system, which is counter-iconic, at the same stage at which spoken language children are inverting the pronouns. So it looks, that kind of evidence seems to suggest that gestural systems and linguistic systems, even though they may have the exact same motor element involved in them, are just different systems. They also seem probably to be neurally dissociated.
In the sense you could do brain studies that show they're activating different areas?
It looks like it, yeah. In fact, this is work done by Ursula Blugy and Ed Klima and others at Salk Institute, which has been going on for, I guess, about 20 years now. They discovered, to everybody's surprise, that for signers, they began with aphasia studies. In fact, most of it still is aphasia. That for signers, the language faculty is still left hemisphere dominant. And it had been suspected it's probably right hemisphere dominant because it's visual. But it turns out to look very much like spoken language, despite the difference of modality. And they've also discovered something beyond that. I mean, discover is strong. These are hard things to do. But they have evidence that for both spoken language and sign, local analytic computation, like sentence structure, is left hemisphere specialized, but global computation, like discourse structure, is right hemisphere localized for both sign and spoken. At least that's what their evidence looks like. Imaging studies are just barely beginning. That should have shed more light on it.
Does that provide, as it were, neurological evidence that the sentence is a special sort of unit for linguistic computation? It's not, paragraphs are not just big sentences?
It provides, evidence to the I mean, this is all pretty weak evidence because very little is understood about it, but it looks like that. And going back to the original question, this does raise serious issues about the ways in which the sensory motor system imposes critical conditions on the operations of the computational system, because it seems it's getting to be more and more plausible to believe that human language is not modality specific, even though it's overwhelmingly in the speech-hearing modality.
But that would put serious constraints on our ability to figure out when natural language evolved. For example, there's at least a 2-decade-old research program by Philip Lieberman, Jeffrey Laitman, collaborators, that has attempted to look at the comparative anatomy both of extant primates, their vocal tract anatomy, and also reconstruct the soft tissue anatomy of extinct hominids, on the idea that basically if they couldn't make the sounds, they didn't have the language.
Yeah, that's pretty controversial. I mean, it looks as though, this is, again, I don't enter into this, I don't know anything about it, but Hauser and Fitch both are very skeptical about that, as are others. It seems that some of the properties that they found are all over the primate kingdom, and that it may be that hundreds of thousands of years ago, the hominids from which we're ultimately descended had what looked like the physical capacities to produce language. But your point is correct. If the speech-hearing modality is not critical to it, this would be significant, but not overwhelming. Like another organism could use sign.
Yeah, exactly. It could have existed
as
a great
humans
deal
do.
earlier. Yeah.
But that does raise the question about a search for homologous structures in the sensory motor system. It should be extended, and we all know that, to asking whether what is the character of the gestural systems that are used for language as distinct from the gestural systems which are physically identical but that are part of a different system, gesturing.
How is that possible? I mean, how could it be possible to have two overlapping?
Well, take the pointing case. It's the most dramatic example, but there are others.
It's highly dramatic because we think, I mean, our intuition about sign language, obviously completely mistaken, is that it is somehow iconic.
Yeah. Somehow it is. Like, when you're a signer will set points in visual space and refer back to them. It's the anaphora system. But it does go through the periods which indicate that that even the physically identical gestures are somehow different if they're linguistic and non-linguistic, and the neurological evidence indicates the same. In fact, if you look more deeply at sign language, it supports the same conclusions. I mean, Petito's results are particularly dramatic because it's because of the counter-iconic usage and the parallel to the normal acquisition for speaking hearing children. But this is all fairly recent work. It's kind of developing fast and should settle out. It could turn out that the major constraints, interface constraints, for the computational system are on the conceptual intentional side, which makes the problem very hard, because to study that independently of language is very difficult. I mean, it's hard to study thought except through the medium of language, which will beg the questions.
How, in principle, could we even approach that question?
Well, you can do it. I mean, there's studies of what are called the ape's theory of mind, or the pre-linguistic infant's theory of mind. I mean, at what point do, for example, is a factual question, do, say, other primates attribute something like beliefs to their other members of their species? Can they attribute false beliefs, for example? And there are ways of studying this. There's just some interesting recent published work reviewing it. A book by Ann and David Premack just came out, which reviews a lot of the material on this thing. It's called Original Intelligence or something.
So the major constraints actually
studied,
might be on that side rather than the sensory motor system.
Well, unless something can be learned about by now a lot is known about the perceptual, the auditory and articulatory apparatus. Much less is known about the systems of gesture that are used in sign. What are their structural properties? How are they distinguished from other gestures and so on? But undoubtedly there's going to be something to be said about that. And that may impose the kinds of constraints that are similar to the ones we're more familiar with from articulatory and auditory systems. And in those systems, there's reasonably good evidence, I think. Again, for me, this is secondary. I only know it indirectly, but it looks to me like there's plausible evidence that the systems are not, in any crucial sense, human-specific.
You make a startling suggestion at the end of this article that even the recursive procedures, what you call the narrow faculty of language, the sort of core of it, specifically understood, might actually have been adapted or exapted, co-opted, from another system having to do with navigation. What's that idea?
Well, this goes back to old ideas. I mean, it's everyone knows that if you want to, if you take a mature organism, say, a person or a worm or anything you pick, and you ask about the factors that lead it to be what it is, there are many different factors. I mean, one is whatever effect experience had. Another is what is an expression of the genes. A third factor is how the laws of nature work. I mean, the laws of nature work in ways which permit certain kinds of development, not others. And exactly what the effect is of those constraints is not too well understood. It's a hard problem. Actually, it's a problem Turing worked on for a good part of his life. Classic work is by Darcy Thompson. There's more recent work by others. But there are many properties of organisms that seem to just be consequences of the way the laws of nature work, which is, in a sense, it's a truism, but to find the effect of those is hard. Well, we're talking about computational systems. And how would the laws of nature operate in these? Well, one might expect that the way they work is by imposing conditions of efficient computation, some sort of optimization conditions. And things like that are found throughout nature. So insect navigation seems to have optimization properties. As I mentioned, foraging seems to optimize. There's recent work suggesting that by Christopher Cherniak at the University of Maryland that the arrangement of the neural systems, at least in simple animals, he suggests beyond, may not be genetically programmed, but just be what he calls minimization of wire length. I mean, using the same procedures that engineers use when they try to get the best possible transistor. You just make what he calls the best of all possible brains. It just sort of turns out that way. The circulatory system seems to work similarly. It looks like there's some optimization in the way it sort of scatters around the body. And it's possible that these things are just deep natural laws. And somehow or other, they, here the step that took place is to the step of linking the external conditions. And what could have happened is that as soon as that step was taken, let's link them, it immediately became optimal. And now comes the linguistic questions. To what extent can we show that the actual linguistic systems do have optimal properties? That's what the work in the minimalist program's involved with. And that's how the issue, that's how, at least for me and for, I think, my colleagues, the question of bringing the evolution of language to a stage where parts of it can be investigated, that's where it sort of comes together.
So recursion basically provided the link, but then there's an issue of optimizing the character of the link?
Right. So, for example, if the character of the link is the way I personally assumed it to be, say, 10 years ago, say the article that Howard Lasnik and I wrote summarizing what we thought was the state of the art. If it's like that, it's very far from optimal. I mean, there were all sorts of properties in the system, different levels that aren't interface levels, strange conditions, all sorts of things. And if that's the way the system actually works, it looks very far from optimal. But if you can demonstrate that those empirical assumptions were wrong, that there really are no levels other than the interface levels, and that the operations do reduce in some interesting sense to the one operation that comes free in a recursive system, namely
Combining together.
Take two things you formed and make a bigger one. That comes free, and it can be internal or external. That yields what we call movement in an automatic way. And if you can show that that works by optimal conditions, like some of these probe-goal theories, well, okay, then you're. It is a huge empirical question, but there's a task, and it's a question how far you can carry it out to see if you can show that all of the technology that's used in descriptive and explanatory work in linguistics can be shown to be an artifact, just a reflection of optimal computational procedures. It's a huge task, but there's been, I think, at least to me, some significant progress in it. To the extent that that can be carried out, you have a picture of the evolution of language, which is, to oversimplify it, as we do there, it would look like the following, and this is surely oversimplified. The interface systems are there pretty much independently of language, and you find them, something like them at least, in other organisms, and you can study their evolution by usual methods, comparative methods. Somewhere comes the step of saying, okay, let's link these. Then automatically comes optimization of the linkage, which is the recursive system that meets optimal conditions. And then you have this basic core of human language. And it may not have changed since then. I mean, that's, like the ideal. How close you can get to that is a good question. But if it's correct, then to get back to your original question, could well be that things that look as remote as insect navigation illustrate the principles that showed up in optimizing the link.
I see. It wasn't the link itself that was derived, but the optimization.
The link comes from somewhere. But that's the way evolution works. I mean, if you look at, say, systems that respond to light, like the eye, or maybe in phototropic plants and so on, they got to come from somewhere. And it seems that where they came from was some stochastic process that introduced into a cell a class of molecules by accident, which happen to convert light into chemical energy, rhodopsin molecules. When they get into a cell, then you've got the basis for all systems that respond to light. Mm-hmm. But how that happened, wasn't by selection, it's just something that happened. And it could be that the linkage is something that happened. Once it's established, you turn to the laws of nature to determine how it should work.
There are a lot of puzzles on the question of not only how it happened, but when it happened. Yeah. So, for example, in the evolution of our own species, Homo sapiens, there's a great mystery surrounding a certain kind of explosive Big Bang development that occurred about 30,000 years ago. Yeah. We know that modern humans came in about 100,000 years ago, coexisted with other species like Neanderthals for maybe 60,000 years. And then suddenly there was this very dramatic change, apparently, in human culture. And some have speculated that it was the origin of language only 30,000 years ago that did it. Does that seem remotely plausible?
Well, yeah. I mean, there's a lot of evidence that, roughly in that range, maybe 30, 50,000 years, something like that, there was an explosive change in the degree of inventiveness of tools, of different kinds of symbolism, even of this magnificent artwork that you see in Lascaux and so on. But there's no evidence, as far as I know, for any physiological changes during the first 50,000 years. And it looks as if contemporary humans are genetically, almost identical, no matter when they separated from the original, small breeding group, maybe around 100,000 years ago. So it's a fair question, what happened in those first 50,000 years? It's one of the many mysteries.
And more than that, though, it would suggest that after that link was drawn, we were in some sense genetically distinct from other members of our own species, which would make it puzzling how language could have
unless
spread.
the fact, there's another possible, and this is all total speculation. Here's a possible scenario. Around 100,000 years ago, it was all sitting there in the brain. But then, establishing the link could have been like making the first tools, it just happens. The same sort of question arises about when early hominids began flaking stones to make tools, how'd they figure it out? Once it was done, it had enormous effects on the species. It opened up new sources of protein and so on and so forth, and all sorts of effects. But it happened somehow, we don't know how. And the ability to do it had already been there before it happened, obviously, otherwise it couldn't happen. Now, it's possible that the ability to make the link was there, say, 100,000 years ago, and it just maybe independently, in various separated groups, somehow it happened, like tool making. And once it happened, you've got language, and then they're all going to look alike, because they're all coming from the same genetic base.
So it lay fallow for 60,000 years?
Yeah, just how long did tool making lay fallow? Maybe millions of years, for all we know. And in fact, anything you look at, the same question is going to arise. It's kind of striking to us because we think about language, but you can really ask the same questions about every stage of tool production or any other cognitive capacity.
Well, Professor Chomsky, thank you very much.
Okay.
We're now going to take questions from our studio audience. Please step to the mic and ask your question.
You seem to be substituting the word optimization of the linking process or something like that for the process that others would say is guided by natural selection, more or less. And those others would say that natural selection is, or someday will be, adequate to explain the development of the human faculty of language. So I'm just wondering if you can explain why you think that natural selection isn't adequate or isn't an appropriate term to use here, and how it falls short as an explanatory device.
Well, I don't see any reasonable selectional procedure, mechanism that could have led to the development of an optimal linkage. And there are many aspects of organic growth where we know that selection is just not the factors that are involved. So if you look at, say, symmetry there's a lot of symmetrical structures in organism design. There are many, as I mentioned, optimization processes that take place. Take, say, the way proteins fold, something as simple as that. It's not a matter of natural selection, that's just the way the world works. And the way the world works affects the way organic entities work. So it's just an empirical, there's nothing, everyone agrees that natural selection is an important factor in evolution. But to try to sort out the effects of that factor is extremely hard, even in the most elementary systems we know anything about, because there are all sorts of other factors, like chemical and physical laws, and maybe mathematical principles of organization. So there's no kind of, a priori stand that you have to take and then argue against. The question is just to discover what it is. And here are some suggestions as to what it could be. If someone has some selectional ideas, fine, look at those. But they don't have any particular priority.
Good morning, Professor Chomsky. I'm a biologist, and actually the question I have is sort of a follow-up to this one. When a biologist looks at something as complex as the FLN, the recursion device ostensibly is, the first two questions you ask is what is it for and what is it from? That is, what did it evolve from? And you suggested that maybe it didn't evolve, or at least that's not the right way to look at
Well,
it.
it evolved, but the
I'm
way
its
reduction
property-
molecules getting into the
Right.
cell evolved. Well, it's also evolution.
So its properties, in other words, on that view, are more contingent on its function, its contemporary function, rather than its evolutionary origin.
Well, see, even that's misleading, because there's a factual question about what the function is. I mean, the usual assumption about language has been that its function is to facilitate communication.
Right.
This, I've never believed that, and this point of view takes a very different approach.
Mm-hmm.
It says the function, if you want to use the
Right.
word, of language is to link interface conditions. And when you look, here it's just an empirical question, and when you look closely at the structure of language, I could mention some cases, I think what you find is that the computational system is optimal, is apparently optimal with regard to linking the interface,
Right.
but is very non-optimal with regard to communication.
I see. So, but I actually have a specific question about its origin. So, there is a case to be made that animal minds evaluate contingent circumstances and control their purposeful motion in response to those, that those systems are in fact hierarchically nested and combinatorial. There's actually an argument to be made that that's true. That looks remarkably like the FLN. That looks remarkably like the recursion device. And if that's true, in turn, then it means that the properties of the recursion device, perhaps including some that look suboptimal for its function, are in fact like the bones in a bird's wing. They are historical accidents rather than functional properties of the system. Could you perhaps explore that just for a moment, whether you like or dislike that view?
There's a difference between hierarchical structure and recursion. There's all kinds of, take say the
Yeah.
birds and,
Right.
the bones, and I got 5 fingers,
Right.
other animal has 3, and so on. That's hierarchical structure, but it's not recursion. There's no recursive process that gives you an arbitrary number of fingers, each stage of which has particular significance. Remember, this recursion is not like, walking. I mean, you take 1 step and then 2 steps and then 3 steps. Every stage in the process has particular significance, determined significance at 2 interfaces. And that's something completely different than hierarchical structure.
Yeah, I was actually referring to things like Biedermann's view of perception, for example, that it's inherently combinatorial and hierarchically nested. Do you like or dislike that view?
Yeah, it's fine. I mean, in fact, maybe we could have gone into this. In fact, I mentioned it, that could be that the recursive systems, not only maybe they're connected with whatever's involved in insect navigation, but they could also be involved with what a lot of perceptual psychologists call the rules of vision. The rules that make you see some object, some presentation as a 3-dimensional object in motion. There's a pretty well understood by now computational procedure that determines that from very few presentations, like 3 tachistoscopic presentations, get you to see a rigid object in motion. Okay, there's some kind of principles involved in that, and it wouldn't be outlandish to assume that those were called rules of seeing, are similar in some way to whatever's going on here. Look, this didn't come from nowhere. The question is where it came from, and in my view, an exciting and not implausible conclusion is that it just comes from the way nature works with computational systems, and therefore you're going to find it all over the place.
I guess if there's one more question, I'm really, again, as a biologist, struck by why linguists are, I'm not sure the word is hostile, but apparently indifferent to this question of what language is for. Biologists look at that and say that, look at language, look at its sophistication, and it's Paley's watch on a heath. It's a complex thing that can only ultimately be produced as a result of its adaptive consequences. The only apparent adaptive consequences are the ones we think that leap immediately to mind, that is exchange of information, cooperative exchange of information.
If that's what leaps to mind, it's just a mistake. Just look at if you want to look
Well, it leaps to the mind of almost every biologist in the world, I must tell you.
For a second. When the notion of function is a very, loose and vague notion. We all know that. So what's the function of the skeleton? I mean, is it to keep you from falling into a puddle on the ground, or is it to store calcium, or is
Well,
it
if it's properly
part of
construed, it's not
circulatory
narrow. To ask what the function of a bird wing is a well-focused question.
Maybe, but if you actually look at the history of it, it's not so well the evolution of it. It's quite complicated, a lot of exaptation and so on and so forth. But the notion of what a function is a very vague notion. However, what is usually assumed, plausibly, is you can get some guide to what the function is by looking at the characteristic use. Okay,
Yes.
well, let's take the characteristic use of language. Characteristic use of language is for thought, not for communication. Almost all language use, close to 100%, is internal.
My understanding was that that's controversial. That is, in
It's
particular,
not
that most
controversial.
thought is in fact not linguistic.
Oh, that's another question.
Yes.
There could be plenty of thought that's not linguistic, but I'm asking a different question.
Uh-huh.
What's the use of language? Statistically speaking, it's almost all internal. If you want to check that, just introspect for a couple hours.
Well, but that's based on introspection. I could make
No,
the
it's
counter
based on observation.
Well-
That introspection is a kind of observation.
Yes, I
I mean,
agree with
if
that.
we had an outside way of looking at introspection, we'd find the same thing.
But an equivalently plausible interpretation of that is that that appears to be true subjectively because the purpose of language is to prepare our thoughts for the ultimate purpose of social communication.
Well, you can
It doesn't
say this if
control
you-
thought
yeah,
in
you
the
can
sense
say
that-
this if you want, but now we're off way in outer
No,
space.
those are competing
No,
models that
they're
should be
not.
susceptible
I mean,
to test. Yeah,
all we know is the following, that the overwhelming use of language, close to 100%, is internal. And when you think about what that internal stuff is, it has very little to do with communication. Like you can spend half your life obsessing because somebody criticized you 10 years ago. You don't expect to communicate it, but that's the kind of thing that goes on your mind all the time. Or
Well,
you can think about
But
all
ostensibly,
kinds
you're
of things.
preparing for an inadvertent meeting with that person.
Who
Are you not?
says? Maybe
It's an argument
Maybe
you
it's
could
somebody
make.
who died. I mean, it's just not. It's just factually
Well,
not
yeah.
correct. It's true.
It is
that
an
it's-
arguable point.
It's true that everything's arguable, but the overwhelming evidence is that internal thought is playing some function for us.
Yeah.
Planning, agonizing, whatever we do with
Right.
it, and some tiny piece of it ends up as being communication. Incidentally, plenty of other things are involved in communication too. Now, you can always make up a story. That's one of the things about evolutionary fairy tale manufacturing.
Or about all of science. They're
Not
they're
all-
about stories, yes, they
Yeah,
are.
not
Testable
all-
stories,
not all of
hopefully.
science, just so stories are particularly prominent in this domain. But if you want to use plausible arguments, like characteristic use tells you something about function, then I think you'd have to say that the function of language in this loose sense is for thought. Some of it ends up being communication, very small parts. In fact, even the part that is externalized is communication, only in a very odd sense.
Mm-hmm.
I mean, like if you meet somebody it's very hard for people to be next to each other and not to talk to each other.
Yeah.
It's kind of, it's like dogs looking at, another's eye. You just have to talk to each other. So if you meet you're standing with somebody at a bus stop, it's just uncomfortable if you're not talking to them. So you talk to them about the weather or the baseball game or something. That's not communication. That's just, it's sometimes called phatic communication. It's just a way of establishing human relations.
Social.
But that's not communication in the sense of transmitting information or anything. If by communication you just mean interacting with other people, well, yeah, okay. Then it would turn out, if you do it descriptively, I think it would turn out like this. Overwhelmingly, language is internal. I mean, it's literally close to 100%. Some of it is externalized. Of the part that's externalized, a lot of it is just phatic communication, meaning we want to be part of a group, or we don't want to feel hostile to each other. Like you don't look at a person, you don't like gaze is always off to the side, or you stay at a certain distance from somebody, and that sort of thing. A lot of it just seems to be like that, and some very small part of it is communication in some independent sense of the word communication.
So
you can make up a story saying that it's that very small part that drives the system, but we have no evidence for it. Furthermore, if you look at the mechanics of the system, now we're getting into more technical aspects. I think you can show that a lot of the mechanics of the system are badly designed for communication and well designed for linking the interfaces. Actually, one important case of this, which is, if any of you are writing parsing programs, programs where you're trying to do automated parsing, there's one overwhelming problem that you always face. And that is a word comes along, like a WH word, what or something like that. And you know, because of the way language works, that it's going to be linked to some position in the sentence. But that position happens to be not heard. It's a gap. So you have the problem of taking a word, who, and figuring out what unexpressed, there's no space, there's no break, there's no nothing, but what point in the utterance is it connected with? Just think how easy it would be if you repeated it. So if you didn't say, what did you see, but what did you see what? Okay, then the problem's trivial. However, that's computationally more difficult. If you look at the way our beliefs about the computational systems, if they are recursive as in the way we think, that would involve more computation for linking the interfaces. So here's a pretty striking case, and there are quite a lot more, where the system seems to be mechanically designed so that it reduces computation and increases the problem of perception. And I think there are a lot of cases like that.
Susan? Thank you. Thank you.
It's very interesting to hear how language may have evolved as a response to the interface conditions between attentionality and sensory motor systems. And so we've been talking about the past 100,000, 30,000, whatever, in terms of our time course. What about the future? Are we done? Is the language mechanism now finished? Is this the masterpiece, or are we going to continue to adapt?
There's no relevant evolution going on. I mean, there's some, humans are change all the time. Different groups change, but the time scale is so small that the chances of significant genetic change involving something like the language faculty look pretty marginal.
But even in another 100,000 years, can you envision?
So little is known about this that you can say anything you like. But the chances, I think most biologists would agree that we're just talking about much too small a time scale.
So everyone will speculate about the past,
Furthermore,
no one will
there's all kind of
speculate about the
interbreeding,
future.
Don't forget. There's no, for real changes to take place, there have to be separation of species. They have to stop that, of subspecies. You have to stop interbreeding for a long time before speciation takes place, real genetic change. And how that happens is mostly mysterious, but it does seem to require a pretty sharp break in interbreeding over a long stretch. And that just doesn't happen with humans.
Right. So perhaps we could use simulation to try to explore some of these ideas, since we really can't do it in the real world too easily.
No, you can.
Won't speculate.
But
Okay.
you could do simulation if you understood the processes. But since you don't understand the processes, you can't do simulation.
Thanks.
Just a short question on the role of the sensory motor interface, because in the earlier discussion, it seemed as though what was crucial about the combinatorial system and so on is that it made the link between these two things, and the output of the sensory motor interface is, as you have been saying, so some kind of physical event, either
sound,
hand motion or sounds or something, and if language is sort of making that link between, say, the inside and the physical world, then in the response to the earlier question about, say, the function of language as being a vehicle for expressing thought, then it raises the question of what's the other half of the link in the 100% use or almost 100% use of language as you described. This what's at the other end of the link. The other end of the previous end of which is the conceptual motor or conceptual interface
It's an extremely interesting question, and here we don't have anything in the way of solid evidence, but we have a ton of introspective evidence, and that's evidence. All right, introspect for a while. When you're talking to yourself, you're producing something which is the same as what you hear. Okay.
Yeah, I mean,
and that's an enormous amount of our life. Is producing to ourselves something that in our head sounds just like something we're hearing. Here's a question which I don't know the answer to, and I don't think it's been investigated. Do signers
that was
visualize?
The next question.
Well, I don't think it's been investigated, but I would assume so. If that's the case, then the internal part of the sensory motor system is really functioning.
Okay, so this
I think it's very hard to talk to yourself and not do
use
it in a
language.
sense of English.
Right.
you know.
Okay.
Yeah.
Yeah. So this is. I mean,
In fact, you
yeah,
can
earlier
look, when you're
opinions about
talking to
thoughts
your,
as
when you're talking
self-vocalizations
to
might come in
yourself,
here,
you can
right?
figure out if the sentences rhyme, for example.
True enough.
Yeah.
Yeah.
I mean, all of these
Okay.
things are easy. In fact, automatic. Yeah.
Okay. Thanks.
Thanks very much.
Okay.
Almost exactly 35 years ago, I had the opportunity to give several lectures here, same auditorium, I think, on the topic language and mind. And quite a lot has been learned in the intervening years about language and the brain, hence the mind, in the sense in which I used the term then, the term mind and mental and such terms in those lectures. Pardon? Oh, thank you. And we'll continue to use them now. Always nice to have a friend in the audience. I'm using these terms as just descriptive terms for certain aspects of the world, pretty much on a par with such descriptive terms as chemical or optical, electrical, and so on. These are terms used to focus attention on particular aspects of the world that seem to have a rather integrated character and to be worth considering for special investigation, but without any illusions that they cut nature at the joints. In those earlier lectures, I took for granted that human language can reasonably be studied as part of the world, specifically as a property of the human organism, mostly the brain, and for convenience, I'll keep to that. Both then and now, I'm adopting what Lyle Jenkins, in a recent book, calls the biolinguistic perspective. That's the framework within which the approach to language that I'm considering developed about 50 years ago. Also, for convenience, I'll use the term language to refer to human language. That's a specific biological system. There is no meaningful question as to whether the communication system of bees or what might be taught to apes or mathematics or music, as to whether there's no question as to whether these are languages or whether airplanes really fly or submarines really swim or whether computers think or translate languages or other comparably meaningless questions, many of them based on a misinterpretation of an important paper by Alan Turing a little over 50 years ago, 1950, which has spawned a large and, to my mind, mostly misguided literature, explicitly, despite Turing's very explicit warning not to pursue that direction, which has apparently been overlooked. From the biolinguistic perspective, language is a component of human biology, more or less on a par with with mammalian vision or insect navigation, and other systems for which the best theories that have been devised attribute computational capacities of some kind, what's in informal usage sometimes called rule following. So, for example, contemporary text on vision describes the so-called rigidity principle. It's formulated about 50 years ago as follows. It says, if possible and other rules permit, interpret image motions as projections of rigid motion in three dimensions. In this case, later work provided substantial insight into the mental computations that seem to be involved, and when the visual system follows these rules in informal terminology. But even for very simple organisms, that's no slight task. A great many issues remain unresolved in these areas, which are quite obscure even for insects. The decision to study language as part of the world in this sense should be, in my view, uncontroversial, but it has not been. On the contrary, the assumption that this is a legitimate enterprise was rejected pretty forcefully 50 years ago and continues to be rejected. Virtually all of contemporary philosophy of language and mind is based on rejection of the assumption. The same is true of what's called the computer model of mind that underlies a good deal of theoretical cognitive science, denied in this case not only for language but for mental faculties generally. It's explicitly denied in the technical linguistic literature in what are called Platonistic accounts of language, and also in a different way denied by the conceptualism that was devised by the same authors, inaccurately attributed to many linguists, including me. It's also apparently denied by many sociolinguists. It's incompatible with structural behavioral approaches to language. It's, a little to my surprise, rejected by current studies of language by leading neuroscientists, most notably Terence Deacon in recent work, which has been favorably received by eminent biologists, again, a little to my surprise. The approach, therefore, seems to be controversial, but I think the appearances are misleading. A more careful look will show, I think, that the basic assumptions are tacitly adopted, even by those who strenuously reject them, and indeed have to be adopted even for coherence. I'm going to put aside this interesting topic of contemporary intellectual history, and I'll simply assume that language can be studied as part of the world. I'll continue, in other words, to pursue the biolinguistic approach that took shape about half a century ago, heavily influenced by ethology, comparative psychology, and intensively pursued then along quite a few different paths, including much of the work that claims to reject the approach. Well, assuming that, let's turn to some things that ought to be obvious. It can scarcely be denied that some internal state is responsible for the fact that I speak and understand some variety of what's loosely called English, but not, say, Hindi or Swahili. To borrow and, in fact, adapt a traditional term, we can call this a state, whatever it is that's internal to me, a state of the human faculty of language, primarily a state of the brain. We can call each such state an internalized language, in the technical literature often called an I language for simplicity, I'll call it that. It should also be uncontroversial that the faculty of language has an initial state, part of our biological endowment, which permits a certain range of options, the attainable I languages. The faculty of language then is a special property that enables my granddaughter, but not her pet kitten or chimpanzee, to attain a specific I language on exposure to appropriate data which her mind, in some obscure way, is able to extract from the booming, buzzing confusion and to interpret as linguistic experience. That's no slight task. Nobody knows how it's done, but it obviously is. More accurately, every infant acquires a complex of such states. That's a complication that I'll put aside. The expectation that language is like everything else in the organic world, and therefore is based on a genetically determined initial state that it distinguishes, say, my granddaughter from her pets, that assumption has been called the innateness hypothesis. And there's a substantial literature debating the validity of the innateness hypothesis. The literature has a curious character. There are lots of condemnations of the hypothesis, but it's never formulated, and nobody defends it. Its alleged advocates, of whom I'm one, have no idea what the hypothesis is. Everyone has some innateness hypothesis concerning language, at least everyone who's interested in the difference between an infant and, say, her pets. Furthermore, the invented term innateness hypothesis is completely meaningless. There is no specific innateness hypothesis. Rather, there are various hypotheses about what might be the initial genetically determined state. These hypotheses are, of course, constantly changing as more is learned. That all should be obvious. Confusion about these matters has reached such extreme levels that it's becoming hard even to unravel, but I'll put all that aside. The biolinguistic approach takes mental faculties to be states of the organism, in particular internal languages, I languages, that are states of the faculty of language. I'll focus on language, but most of what follows should hold as well for other cognitive faculties, and in fact for far simpler organisms, say bee communication or navigation, for example. Well, when we adopt this approach, several questions arise at once. The central one is to determine the nature of the initial and attained states. And though the matter, again, appears to be controversial, I know of no serious alternative to the thesis that these are in substantial measure computational states, whether we have in mind insect navigation or what you and I are doing right now. Again, that's held to be controversial, but since there's no alternative ideas, I don't understand why. It's held to be controversial for humans. It's not held to be controversial for, say, insect navigation, but the question's about the same. Investigation of the brain in these terms is sometimes called psychological, and it's contrasted with investigation of in terms of cells, chemical processes, electrical activity, and so on. That's called physiological. These are, again, terms of convenience. They don't have any sharp boundaries. Chemistry and physics were distinguished in pretty much similar way not very long ago. So the formulas involving complex molecules that we now study in school, these were not pretty recently considered to be, I'm quoting, merely classificatory symbols that summarize the observed course of a reaction. The ultimate nature of the molecular groupings was held to be unsolvable, and the actual arrangement of atoms within a molecule, if that even means anything, was never to be read into the formulas. I'm quoting from a standard history of chemistry. Kekulé, whose structural chemistry paved the way to eventual unification of chemistry and physics, he doubted that absolute constitution of organic molecules could ever be given. His own models, his analysis of valency and so on were to have only an instrumental interpretation as calculating devices. Actually, large parts of physics were understood in the same way by prominent scientists, including the molecular theory of gases, even Bohr's model of the atom. In fact, only a few years before physics and chemistry were united in Linus Pauling's account of the chemical bond, America's first Nobel Prize winning chemist dismissed talk about the real nature of chemical bonds as, in his terms, metaphysical twaddle. This was nothing more than a very crude method of representing certain known facts about chemical reactions, a mode of representation only, just a calculating device. The rejection of this skepticism by a few leading scientists whose views were incidentally condemned as a conceptual absurdity, that paved the way to the eventual unification. These are fairly recent debates. This is, I'm talking about the 1920s. These fairly recent debates in the hard sciences, I think, have considerable relevance for today's controversies concerning computational theories of cognitive capacity. That's from insects to humans. Important topic, one that I've discussed a little bit elsewhere, and I think deserves a good deal more attention than it's received. Well, with the biolinguistic approach in place, this framework in place, we want to discover the relationship between psychological states and the world as described in other terms. We want to know how computational states are related to neurophysiological states, states of the brain, or represented in them in one terminology. We also want to find out how these mental states relate to the organism external world, as for example when the motions and noises produced by a forager bee direct others to a distant flower, or when I talk about a recent trip to India, or when I say that I recently read Darwin's Descent on Man, referring to a book. All of this is called intentionality in philosophical jargon. The broad issues were raised prominently at the end of the decade of the brain, which brought the last millennium to a close. The American Academy of Arts and Sciences, at the end of the millennium, year 2000, published a volume to mark the occasion. It summarized the current state of understanding in these areas. The guiding theme of the volume was formulated by a distinguished neuroscientist, Vernon Mountcastle, in his introduction to the collection. It is, in his words, the thesis that things mental, indeed minds, are emergent properties of brains, though these emergences are not regarded as irreducible, but are produced by principles that control the interactions between lower-level events, principles we do not yet understand. That same thesis has been put forth in recent years as, quoting, as an astonishing hypothesis of the new biology, a radically new idea in the philosophy of mind, the bold assertion that mental phenomena are entirely natural and caused by neurophysiological activities of the brain, opening the door to new and promising inquiries, and so on. Contributors to the American Academy volume were, for the most part, quite optimistic about the prospects for overcoming the remaining gaps between psychological and physiological accounts. Mountcastle's phrase, "we do not yet understand," reflects that optimism, suggests we will soon understand. Ed Wilson wrote that researchers now speak confidently of a coming solution to the brain-mind problem. Similar confidence has been expressed for half a century, including announcements by prominent scientists, Nobel Prize winner in one case, that the brain-mind problem has already been solved. We may recall usefully similar optimism shortly before the unification of chemistry and physics. So in 1929, Bertrand Russell, who knew the sciences well, he wrote that chemical laws cannot at present be reduced to physical laws. And his phrase, "at present," like Mountcastle's word "yet," expresses the expectation that the reduction should take place in the course of scientific progress, perhaps soon. Now, in the case of physics and chemistry, it never did take place. What happened was something different and totally unexpected, namely unification of a virtually unchanged chemistry with a radically revised physics. And it's hardly necessary to stress the fact that the state of understanding and achievement in these areas 80 years ago was far beyond anything that can be claimed for the brain and cognitive sciences today, which ought to give us pause. The American Academy volume reviews many important discoveries, but the leading thesis should arouse our skepticism, not only for the reason that I just mentioned. Another reason is that the thesis is by no means new. In fact, it was formulated in virtually the same words 2 centuries ago, late 18th century, by the eminent chemist Joseph Priestley. He wrote that properties of mind arise from the organization of the nervous system itself, and those properties termed mental are the results of the organical structure of the brain, just as matter is possessed of powers of attraction and repulsion that act at a distance, contrary to the founding principles of the modern scientific revolution from Galileo to Newton and beyond. Half a century before Priestley, David Hume had casually described thought as a little agitation of the brain. And shortly after, the French philosopher, physician Cabanis wrote that the brain must be considered a special organ designed to produce thought, as the stomach and the intestines are designed to operate the digestion, the liver to filter bile, and various glands to prepare salivary juices. Lametrie, he had similar proposals. They were suppressed at the time, but they're well known today. A century later, Darwin asked rhetorically why thought, being a secretion of the brain, should be considered more wonderful than gravity, which is a property of matter. Actually, these and many other conceptions developed from an inquiry into what was called thinking matter, in part developed from what's sometimes called by historians of philosophy Locke's suggestion, John Locke's suggestion, that is his observation in his words that God might have chosen to superadd to matter a faculty of thinking, just as he annexed effects to motion, which we can in no way conceive motion able to produce. The theological apparatus may well have been for self-defense, so Locke's correspondence suggests. By the late 18th century, the thesis was widely regarded as inescapable. Newton had demonstrated, to his considerable dismay, that matter does not exist in the sense of the Galilean revolution and of the scientists of his own day and his own sense. That being the case, the mind-body problem could no longer even be formulated, at least in anything resembling the classical form. Current formulations seem at best to restate the problem of unification of psychological and physiological approaches, and to do so in highly misleading terminology. There was no mind-body problem any more than there was a chemistry-physics problem in the 1920s. Unification of Newton's discoveries led to, they really left no coherent alternative to the conclusion that was drawn by Hume, Priestley, others, and rediscovered today in pretty much the same terms, but with the problem of emergence as unresolved as it was 2 centuries ago, and that includes the question whether this notion with its reductionist connotations is even the right notion. Maybe it's the wrong notion, as proved to be the case for chemistry and physics. The traditional mind-body problem is often ridiculed as a problem of the ghost in the machine, but that's a misconception. Newton exorcised the machine. He left the ghost completely intact. A similar observation is made very recently by 2 physicists, Paul Davies and John Gribben, concluding a book of theirs called The Matter Myth. They write that during the triumphal phase of materialism and mechanism in the 1930s, Gilbert Ryle derided mind-body dualism in a pithy reference to the mind part as the ghost in the machine. But already when he coined that pithy expression in the 1930s, the new physics was at work, undermining the materialist worldview on which Ryle's philosophy was based. By the end of the 20th century, they continue, we can see that Ryle was right to dismiss the notion of the ghost in the machine, not because there is no ghost, but because there is no machine. Their point is correct, but the timing is off by at least 2 centuries, actually 3, although it did take some time for Newton's demolition of what was called at the time the mechanical philosophy, the belief that the world is a machine. It took a little time for that to enter scientific common sense. Newton himself was well aware of the conclusion and far from pleased by it. He regarded his own conclusion as an absurdity that no serious person could entertain, and he sought a way around it to the end of his life, as did prominent scientists of his day and much later, always in vain. Over time, it just came to be recognized that Newton had not only effectively destroyed the entire materialist, physicalist conception of the universe, but he had also undermined the standards of intelligibility on which the early scientific revolution was based. The outcome is familiar, at least in history of science. It was described very well in the classic 19th century History of Materialism by Friedrich Lange. He pointed out that scientists have accustomed ourselves to the abstract notion of forces, or rather a notion hovering in a mystic obscurity between abstraction and concrete comprehension, a turning point in the history of materialism that removes the surviving remnants of the doctrine far from the ideas and concerns of the genuine materialists of the 17th century and deprives them of any significance. That, too, is now a virtual truism, at least among historians of science. One of the founders of the modern discipline, Alexander Poiré, he wrote 40 years ago that a purely materialistic or mechanistic physics is impossible, and we simply have to accept that the world is constituted of entities and processes that we cannot intuitively grasp. The problems of emergence and unification take on an entirely new form in the post-Newtonian era, a form that's furthermore unstable, changing as science comes to accommodate new absurdities, as they would have been regarded by the founding figures of the scientific revolution, including Newton, and I know of no reason to suppose that the process has come to an end. It's worth pointing out that the only part of our knowledge, or what we take to be knowledge, for which we can claim much confidence, is our mental world, that is, the world of our experience. As reflective beings, humans try in various ways to make sense out of this experience. One part of this effort is sometimes called folk science, when it's conducted in a more systematic, careful, controlled way. We nowadays call it science. One standard conclusion of contemporary science is that each organism, humans in particular, reflexively develop what ethologists call an Umwelt, a particular mode of constructing and interpreting experience, given the data of sense. It's quite different for us and for bees, for example. Furthermore, there's no great chain of being. In fundamental respects, insects have richer experience and more sophisticated ways of dealing with it for action, using it for action, than humans do. Among other standard conclusions of modern science are those that Priestley and many others drew the conclusions they drew centuries ago about thinking matter, reiterated at the end of the decade of the brain, just 2 years ago, without notable change, or maybe surprisingly, without much awareness that it's revival, not innovation, and that it's revival of something that was taken to be an unavoidable truism 2 centuries ago for quite good reasons. Given the lack of a positive, determinate account of the non-mental part of the world, of the world, what's sometimes called the physical world, talk of the hard part of the mind-body problem. In recent years, that's been taken to be consciousness conventionally. That talk of that kind is misleading at best, if it's even meaningful. It may not be. Sometimes the problem is not very clearly posed. That is, it's posed in terms of questions to which we can't even think of wrong answers. So, for example, there's no sensible answer to the question, what is it like to be me? Or what is it like to be a bat, and quoting Thomas Nagel's famous paper. There are no bad answers to that. There are no good answers, none at all. Formal semantic inquiries often take the meaning of a question to be the set of propositions that are answers to it. And if that is at least a condition on meaning, then it follows that if there are no sensible answers, the question has no meaning. Even when legitimate questions are posed, we don't have any good reason, as far as I can see, to suppose that they are intrinsically harder than lots of other problems, say the problems posed for our understanding by quantum mechanics, or cosmological theories of an infinity of universes, or for that matter, by the properties of motion. We don't have any reason that I know of to question the opinions of Newton, David Hume, and other not inconsiderable figures who in various ways reached Locke's conclusion that motion has effects which we can in no way conceive motion able to produce. Even before Newton, puzzlement about motion was profound. His precursor, Sir William Petty, described springing or elastic motion as the hard rock in philosophy. Philosophy means what we call science. The obscurity was so great, Robert Boyle felt, as to prove the existence of an intelligent author or disposer of things. Even the skeptical Newtonian Voltaire felt that the impenetrable mysteries of motion proved that there must be a God who gave movement to matter, rather like Locke's suggestion. One cannot say that the hard problem was solved. It was just abandoned in the course of a significant revision of the enterprise of science. That is, the recognition that in some fundamental sense the world is just unintelligible to us, and that we have to reduce our sights to the search for intelligible theories. That's something quite different. And even that goal has been strongly contested by prominent physicists. For example, in the critique a century ago of atomic theory, or even of the idea that physics should go beyond establishing quantitative relations between observable phenomena. The significance of that shift should not be underestimated. It was recognized soon enough, for example, by David Hume, who wrote that, in his words, Newton's discoveries reveal the obscurity in which nature's ultimate secrets ever will remain. These mysteries of nature, as Hume called them, referring to the phenomena of motion, will remain beyond our cognitive reach. Perhaps we might speculate, he didn't, for reasons that are rooted in the biological endowment of the curious creature that alone is able even to contemplate these questions. Well, I did talk a little bit about these topics 35 years ago, and what's happened since, including, incidentally, my own belated self-education, inclines me to believe that what I said then should be reiterated much more forcefully and in much greater depth and with much more explicit connections drawn to contemporary discussions about problems of language and mind. Well, let's return to the narrower question of emergence of mental aspects of the world, or perhaps the development of an account of the non-mental world that can be unified with them if the physics-chemistry model turns out to be accurate. The scale of the gap that remains and the very dubious grounds for the general optimism about overcoming it are revealed very clearly in the American Academy Symposium that reviewed the state of understanding at the end of the millennium. One leading specialist on vision, who was toward the optimistic end of the spectrum, nevertheless reminded the reader that how the brain combines the responses of specialized cells to indicate a continuous vertical line is a mystery that neurology has not yet solved, or even, for that matter, how one line is differentiated from others or from the visual surround. Semir Zeki. The AAAS journal, American Association for Advancement of Science journal, Science, a year ago, they devoted an issue to neuroscience. The summary article was co-authored by Eric Kandel, Nobel laureate. It was subtitled, "Breaking Down Scientific Barriers to the Study of Brain and Mind." The article covers a lot of interesting ground, but it ends up with the conclusion that the neuroscience of higher cognitive processes is only beginning. It's surely beginning from a higher plane than was constructed by Descartes, who was in many ways the founder of modern neuroscience, but nonetheless it's still beginning. Fundamental questions remain beyond even dreams of resolution. That includes those that were traditionally considered at the heart of the theory of mind, such as, for example, choosing some action or even thinking about doing so. There's been very valuable work about narrower questions. For example, how an organism executes a plan for integrated motor action, say how a cockroach walks or how a person reaches for a cup on the table. Well, let's return to the narrower question of emergence of mental aspects of the world, or perhaps the development of an account of the non-mental world that can be unified with them if the physics-chemistry model turns out to be accurate. The scale of the gap that remains and the very dubious grounds for the general optimism about overcoming it are revealed very clearly in the American Academy Symposium that reviewed the state of understanding at the end of the millennium. One leading specialist on vision, who was toward the optimistic end of the spectrum, nevertheless reminded the reader that how the brain combines the responses of specialized cells to indicate a continuous vertical line is a mystery that neurology has not yet solved, or even, for that matter, how one line is differentiated from others or from the visual surround. Semir Zeki. The AAAS journal, American Association for Advancement of Science journal, Science, a year ago, they devoted an issue to neuroscience. The summary article was co-authored by Eric Kandel, Nobel laureate. It was subtitled, "Breaking Down Scientific Barriers to the Study of Brain and Mind." The article covers a lot of interesting ground, but it ends up with the conclusion that the neuroscience of higher cognitive processes is only beginning. It's surely beginning from a higher plane than was constructed by Descartes, who was in many ways the founder of modern neuroscience, but nonetheless it's still beginning. Fundamental questions remain beyond even dreams of resolution. That includes those that were traditionally considered at the heart of the theory of mind, such as, for example, choosing some action or even thinking about doing so. There's been very valuable work about narrower questions. For example, how an organism executes a plan for integrated motor action, say how a cockroach walks or how a person reaches for a cup on the table. But no one even raises the question of why the person or the cockroach executes one plan rather than some other one. That question is raised only for the very simplest organisms, single-cell organisms. In fact, the same is true even of visual perception, which is often considered a passive process. A couple of years ago, two cognitive neuroscientists, one a colleague of mine, published a review of research on a problem that was posed in 1850 by Helmholtz. His words, even without moving our eyes, we can focus our attention on different objects at will, resulting in very different perceptual experiences of the same visual field. There's been interesting work on that, but the phrase "at will" points to an area that's beyond serious empirical inquiry. It remains as much of a mystery as it was for Newton at the end of his life, when he was still seeking what he called a subtle spirit that lies hidden in all bodies and that might, without absurdity, account for their properties of attraction and repulsion, the nature and effects of light, sensation, and the way members of animal bodies move at the command of the will. These are all comparable mysteries for Newton, perhaps even beyond our understanding, he thought, like the principles of motion and the classical problems of the theory of mind, at least since Descartes, who incidentally also regarded them as possibly beyond human understanding. Even if we restrict ourselves to the study of mechanisms, the gaps are quite substantial. One of the leading cognitive neuroscientists, Randy Gallistel, pointed out recently that we clearly do not understand how the nervous system computes or even the foundations of its ability to compute, even for the small set of arithmetic and logical operations that are fundamental to any computation. He happens to be talking about insects, but obviously extends beyond. In another domain, one of the founders of contemporary cognitive neuroscience, Hans Lukas Teuber, he introduced an important review of perception and neurophysiology by writing that it may seem strange to begin with the claim that there is no adequate definition of perception and to end with the admission that we lack a neurophysiological theory, though this was the most that could be said. Now, it's true that that was 40 years ago, and there were dramatic discoveries right at the time that he was writing and since, but I suspect that Teuber, who's since died, would have expressed much the same judgment today. Teuber also outlined a standard way to move towards addressing the problem of unification. He explained that his purpose in reviewing the perceptual phenomena and offering a speculative psychological account of them was because this may suggest directions in which the search for neural bases of perception should proceed, namely by clarifying the assumptions that those neural bases must satisfy. Now, that's a classic approach, along with the restriction of the scientific enterprise to more modest goals, namely intelligibility of theories rather than of the world. Another consequence of Newton's demolition of the hopes of the Galilean Revolution for a mechanical conception of the world. Another one was recognition that scientific inquiry is going to have to be local in its expectations. Overarching unification may take place, but perhaps over a long term and in ways that can't be anticipated. The 18th century English chemist Joseph Black set the tone for subsequent scientific work by recommending that chemical affinity be received as a first principle, which we cannot explain any more than Newton could explain gravitation, but let us defer accounting for the laws of affinity till we have established such a body of doctrine as Newton has established concerning the laws of gravitation. And chemistry, in fact, proceeded along that course, separating itself increasingly from physics. Physics followed Newton's admonition that nature will be comfortable to herself and very simple, observing a few general principles of attraction and repulsion that relate the elementary particles of which all matter is constituted, more or less in the way that different buildings could be constructed from the same bricks. The goal was, therefore, to understand, to quantify, to reduce the whole of nature to simple laws, as Newton did for, say, astronomy. I happen to be quoting Arnold Thackeray in his history of Newtonian matter theory and the development of chemistry. He goes on to say, this was the compelling, the enticing, indeed the almost bewitching goal of much work, pursuing the thoroughly Newtonian and reductionist task of uncovering the general mathematical laws which governed all chemical behavior. There was a distinct chemical tradition, followed the path that was outlined by Joseph Black, Lavoisier, who more or less founded modern chemistry, tried to keep neutral, probably to avoid controversy, but his own work helped to found the separate chemical track. Dalton abandoned entirely the Boyle-Newton corpuscular theories of matter. He adopted the radically different view that matter could exist in heterogeneous forms with varied principles. His approach, Thackeray writes, was chemically successful and therefore enjoyed the homage of history, unlike the philosophically more coherent, if less successful, reductionist schemes of the Newtonians. By the end of the 19th century, the fields of interest of chemists and physicists had become quite distinct. Quoting a standard history of chemistry, chemistry dealt with a world consisting of some 90-odd material elements with many and varied principles and properties, while physicists handled a more nebulous mathematical world of energy and electromagnetic waves that were perceived in light, radiant heat, electricity, magnetism, later radio waves, and X-rays. The chemist's matter was discrete and discontinuous. The physicist's energy was continuous, and the gap appeared unbridgeable. Meanwhile, chemists developed a rich body of doctrine, achieving chemistry's triumphs in isolation from the newly emerging science of physics. Thackeray again. As I mentioned, the isolation ended only recently in a completely unanticipated way, not by reduction, but by unifying a radically revised physics with the bodies of doctrine that chemistry had accumulated, which had in fact provided important guidelines for the reconstruction of physics, basically, Teuber's point about perception. And that's happened often in the history of science, and we cannot know whether something similar might be required for unification of the study of brain and mind, assuming that to be a task that is within our cognitive reach, and that we don't know either. Well, I've already suggested, and will repeat, that there are interesting and important parallels between the debates concerning the reality of chemistry up to unification, which was just 65 years ago, and current debates in the philosophy of mind about the reality of the constructions of psychological approaches. The former debates, chemistry, physics, they are now understood to have been totally pointless, based on serious misunderstanding. We simply have no grasp of reality other than what our best explanatory theories can provide. If they happen to be computational theories, okay, that's reality. My own view, I've discussed it elsewhere, is that current debates, very much alive right now, are also largely pointless and for essentially the same reasons. This includes central topics of philosophy of mind and theoretical cognitive science, which those of you in the disciplines will recognize, or even in the general literature. Well, considerations of the kind that I've been reviewing, these were in the background of the so-called cognitive revolution of the 1950s, at least for some of the participants. Although it was unknown at the time, in many ways the shift of perspective brought about by the cognitive revolution actually recapitulated the first cognitive revolution of the 17th century. That includes the focus on vision and language, in the latter case adopting the biolinguistic approach. That is, shifting the focus of attention from phenomena like behavior and its products, say texts, shifting from that to the inner mechanisms that enter into producing the phenomena. That's a shift, but it's actually a shift that was taken in the 17th century. Notice again, and then there was regression for a long time. Notice again that that shift still leaves us a long way from the problems of action. That's a vastly different matter. I've myself often quoted Wilhelm von Humboldt's aphorism that the core problem of the study of language is the infinite use of finite means. So it was a leading concern of Cartesian philosophy before him, and a problem that really couldn't be posed, until, very clearly at least, until the mid-20th century, when the concepts of recursive generative procedures was fully clarified. These procedures constitute the finite means that are put to infinite use, but it's important to be aware, I don't think I've stressed this enough, it's important to be aware that despite quite a lot of progress in understanding the means that are employed for infinite use, the question of how they are used is scarcely even addressed, and it was that question that was the fundamental one for Descartes, Humboldt, and other early modern figures. And again, those questions aren't even addressed for, say, insects, let alone humans. It's reasonably clear that the human capacity for language is what's called a species property, that is biologically isolated in essential respects and close to uniform across the species. That actually seems less surprising today than it did not long ago, in the light of very recent discoveries about the very limited genetic variation among humans as compared with other primates. It suggests that we've all descended from a very small breeding group, maybe 100,000 years ago. So humans are basically identical from the point of view of, say, an outside biologist looking at us. The biolinguistic approach adopted from the start what has been called, I'll quote the recently published Encyclopedia of Cognitive Neuroscience, what's called the norm these days in neuroscience, the modular view of learning. That is the conclusion that in all animals, learning is based on specialized mechanisms, instincts to learn in specific ways. I happen to be quoting Randy Gallistel again. These organs within the brain, as he calls them, perform specific kinds of computation in accordance with specific design. Apart from extremely hostile environments, the organs change state under the triggering and shaping effect of external factors. They do so more or less reflexively and in accordance with internal design. That's the process of learning, although growth might be a more appropriate term, avoiding misleading connotations of the term learning. The language organ, the faculty of language, fits that pattern, the normal pattern. According to the best theories we have, each attainable state of the system, each I language, is a computational system that determines, generates, in a technical sense, infinitely many expressions. Each of these expressions is a store of information about sound and meaning, which is accessed by performance systems. The properties of the I language result from the interplay of several factors. One factor is individual experience, which selects among the options that are permitted by the initial state. A second factor is the initial state itself, which is a product of evolution. And a third factor is general properties of organic systems, in this case, computational systems, incorporating, it's reasonable to expect, principles of efficient computation. Now, the general picture involving, crucially, the third factor is familiar in the study of organic systems generally. This classic work of Darcy Thompson and Alan Turing on organic form and morphogenesis is an illustration, big topic currently in contemporary biology. One example, current example, that might be suggestive in the present connection, present context, is recent work by Christopher Cherniak, a mathematical biologist at Maryland, who's been exploring the idea that minimization of what he calls wire length, as in microchip design, should produce what he calls the best of all possible brains. And he's tried to explain in these terms the neuroanatomy of nematodes, one of the simplest and best studied organisms, and also various pervasive properties of nervous systems, such as the fact that the brain is as far forward as possible on the body axis. He wants to try to show that that's just a property of efficient computation based on wire length minimization. Well, one can trace interest in this third factor, general properties of organisms, back to a Galilean intuition, namely Galileo's concept that, in his words, nature is perfect, from the tides to the flight of birds, and it's the task of the scientist to discover in just what sense this is true. Newton's confidence that nature must be very simple, which I quoted, that reflects the same intuition. However obscure it may be, that intuition about what Ernst Haeckel called nature's drive for the beautiful has been a guiding theme of modern science since its modern origins with the Galilean Revolution, perhaps even its defining characteristic. It's hard to say exactly what it is, but that it's a guiding intuition is not in doubt. Biologists, however, have tended to think rather differently about the objects of their inquiry. Very commonly, they adopt what François Jacob, the Nobel laureate, his image of nature as what he called a tinkerer, which does the best it can with the materials at hand, often a pretty rotten job, as human intelligence seems to be keen on demonstrating about itself. One well-known contemporary biologist, Gabriel Dover, British geneticist, he concludes in a recent book that biology is a strange and messy business, and perfection is the last word one could use to describe how organisms work, particularly for anything produced by natural selection, though, of course, produced only in part by natural selection, as he emphasizes, and as every biologist knows, and to an extent that can't be quantified by available tools. Well, we just don't know which of these conflicting intuitions is more accurate, the Galilean intuition or, say, Jacob's intuition. And we will not know until we know the answer, and they seem very remote, those answers. The same author, Gabriel Dover, writes that we are nowhere near relieving our deepest ignorance about the biological world around us. He goes on to reserve his sharpest words for those who seek to give scientific respectability to complex behavioral phenomena in humans that we cannot even begin to investigate seriously. He calls that a sign of intellectual laziness at best and shameless ignorance at worst when confronting issues of massive complexity which far exceed the reach of contemporary science. He gives some examples, but for charity, I'll ignore them. The long-term goal of investigating the third factor, that is the role of general properties of organisms in determining the faculty of language and the states it can attain, internal languages, that goal was actually formulated in the early days of the biolinguistic turn, but it was put aside as unfeasible. And attention focused on the first two factors, experience and the initial state. In technical terminology, that's called the problems of descriptive and explanatory adequacy. The latter is the question of how the initial state enters into determining the transition to the final state, the state attained. The earliest attempts 50 years ago to replace traditional or structuralist accounts of language by generative rule systems revealed very quickly that very little was known about the sound and meaning and structure of language, and that huge problems had been unwittingly swept under the rug, rather as in the days when it was assumed that bodies fall to their natural place. As has often been the case, one of the hardest steps in the development of the sciences is the first one, namely to be puzzled by what seems so natural and obvious. To gain some realistic sense of what had been overlooked was an enormous task in itself, even more so in the light of the recognition that the apparent complexity and diversity of languages that was very soon discovered just had to be an illusion. The reason for that conclusion is a standard one in biology, namely, as in the case of other organs of the body, experience can play only a very limited role in determining the state that's attained, in this case, the attained eye language. So even a young child has mastered a rich and highly articulated system of sound and meaning and structural properties that goes far beyond any evidence available and that's shared with others who have different but also highly restricted experience. So it has to be the case that the initial state plays an overwhelming role in determining the language that the child attains in all of its aspects. Experience surely has a role, a triggering and shaping role, as in the case of other organs, but it has to be a limited one. So there's no reason to suppose that language and other higher mental faculties depart radically from everything known in the biological world. The task was to show that the apparent richness and complexity and diversity is in fact an illusion, that all languages are cast to the same mold, and that experience serves only to set options within a fixed system of principles, all determined by the initial state, much as in the case of other biological systems. Well, a great deal of the research the last 40 years in these areas has been driven by a kind of tension between descriptive and explanatory adequacy. That is, the tension between the search for true theories of eye languages, the attained state on the one hand, and a true theory of the invariant initial state of the language organ on the other. The invariant initial state is the topic of what's come to be called universal grammar. It's adapting a traditional notion to quite a new context. The search for descriptive adequacy, like a true theory of Hungarian, that leads to complex, intricate theories of particular constructions in particular languages differing from one another. In contrast, the search for explanatory adequacy seeks to find the common ground from which the existing languages and all possible others arise, given the data that are structured as experience by the operations of the initial states, again, in some unknown manner. The first proposals from the 1950s suggested that the initial state, the topic of universal grammar, that the initial state provides a kind of a format for rule systems and their organization and a procedure for selecting one instantiation of the format over another in terms of its success in capturing authentic linguistic generalizations and empirical notion that incorporates also a kind of a theory internal version of standard best theory considerations. The rules themselves at the beginning were adaptations of informal traditional notions, which had proven to be utterly inadequate when they were subjected to close examination. So that meant, for example, rules for forming relative clauses in Hungarian, or passives or in Japanese, or causatives in the Romance languages, and so on. The general approach did offer a kind of solution to the core problem of the study of language. It's sometimes called in the literature the logical problem of language acquisition. That is, how does the initial state map constructed experience to the final state? But as was emphasized, that solution holds only in principle, because in practice the conception was unfeasible because of the astronomical computational demands. Well, from about 40 years ago, attempts were made to reduce the scale of the problem by seeking valid general principles that can be abstracted from particular grammars and attributed to universal grammar, meaning to the initial state of the language faculty, leaving a residue that might be more manageable. Actually, some of those proposals were the kind of proposals that were then being explored. I reviewed in the lectures here 35 years ago. After that time, by then already there was some progress. After that time, there'd been considerable progress, but it still left the tension unresolved. That is, the general picture was somehow fundamentally defective. There was no true solution, feasible solution to the logical problem of language acquisition. Well, a possible resolution of the tension was reached after a good deal of effort about 20 years ago with the crystallization of a picture of language that marked a very sharp break from a long and rich tradition tracing back to classical India and Greece. This is sometimes called the principles and parameters approach that dispenses entirely with the core notions of traditional grammar, notions like grammatical construction or grammatical rule. From this point of view, categories such as, say, relative clause or passive construction are understood to be real enough, but only as taxonomic artifacts. So, for example, aquatic organisms, which would include, say, dolphins, trout, eels, and some bacteria. It's a category, but not a biological category. The phenomena, the phenomenal properties of these artifacts result from the interaction of invariant principles of the initial state, faculty of language, with parameters that are finite number of parameters fixed in one or another way. It would incidentally follow that there are only finitely many possible human languages apart from idiosyncrasies and choice of lexical items, and even these are sharply constrained. That means that the problem of unfeasible search is eliminated. It's a major conclusion, if correct. The conception has now been applied to typologically different languages of just about every known kind. It's led to many discoveries, a host of new questions that were never before contemplated, sometimes suggestive answers. This principles and parameters approach is an approach. It's not a theory. Within the general approach, there are many diverse theories. There's actually a very good introduction to the topic just published by Mark Baker called Atoms of Language. He himself has made major contributions to the approach. He's been working primarily on languages that appear to be at opposite ends of the spectrum of typological possibilities, picking that on purpose, of course. Mohawk and English, that's the pair that he's studied most intensively, trying to show that although they are about as different phenomenally as two languages can be, they are in reality virtually identical, apart from very small changes in a few parameters. So that, say, a Martian observer who views humans as we view other organisms would conclude that they're essentially identical, dialectal variants of the same language. There's been extensive work of a similar character carried out worldwide with quite revealing results. One major program funded by the European Union is studying the vast number of languages in Europe, huge number in fact, misleadingly called things like German and Italian and so on, though they're totally different languages, included by those in those characterizations. I don't, and it's being done elsewhere as well. I don't want to suggest that the approach has been established. That's very far from true, but it has been very successful as a research program, as a stimulus to empirical and theoretical inquiry. Progress towards the goals of descriptive and explanatory adequacy has far surpassed anything that precedes, not only in depth of analysis of particular languages, but also in the range of typologically different languages that have been investigated, and also new areas of linguistic structure that had barely been explored before. Related fields, such as the study of language acquisition, have also been completely revitalized within a similar framework. They now look totally unlike anything that was around 20 or 30 years ago. There are some important steps towards convergence, although it's certainly going to be a long and difficult course, even if the approach turns out to be more or less on the right track. We're far from having a clear idea of what the principles and parameters actually are, but I think it's fair to say that the study of language in the last 20 years has moved to an entirely new plane. Well, I want to pick up these topics tomorrow and then move on to the issues, particularly the role of the third factor, general properties of organisms, say something about that, and then to move on to what are called the questions of intentionality. That is the question of how language, now understood within the biolinguistic framework, relates to the rest of the world.
Professor Chomsky has agreed to take a couple of questions that were submitted by the audience. Since these questions were submitted at the beginning of the lecture, they may not have been part of what's covered today. It might be a sneak preview of tomorrow. Do you still believe that the human language faculty evolved all at once in a sudden evolutionary leap? Doesn't this conflict with the general finding that evolution is gradual?
This idea, sometimes called a monster mutation, was invented, as far as I'm aware, by Elizabeth Bates, and has been repeated by many other people. It's been attributed to me for some reason. I haven't the slightest idea why. I've never said a word about it, and I have no idea whether it's true. Nor does anyone know anything about these topics in general. Why it was invented, why it was attributed to me, you can try to figure out. The fact of the matter is no one knows anything about these things, even for much simpler questions. So, for example, one well-known fact about biological organisms is they all, above the level of bacteria, they all seem to have essentially the same body type, same body forms. And it's now kind of understood how that works. Certain regulatory genes have been, master genes have been discovered that create the forms, and it just runs through the whole organic world of animals. Well, very recent work, actually a couple of papers in Nature just a few weeks ago, show laboratory experimental work that shows how this might have happened in one monster mutation. Well, okay, maybe not. There's recent work about the evolution of the human brain, articles in Science a couple of weeks ago, suggesting, in fact, that one small mutation took place which suddenly led to explosion of brain size. Maybe not. These are, I don't have anything to say about these matters. I just repeat what's in the technical literature. But why this conception was attributed to me is a total mystery as far as I know.
I hope this is not of the same ilk. It's a do you still question again. Do you still view language as self-contained module that is independent of other cognitive systems? Wouldn't it be simple to assume that language ability is grounded in the same cognitive mechanisms as other forms of human cognition?
Well, I take for granted that the human language, I mean, it's kind of like asking whether the visual system is distinct from other systems of the body. Of course it isn't. Or say the immune system. Of course it's not distinct from the rest of the body. Like you can't cut the immune system out and leave the rest of the body. I mean, it's impossible. Every subsystem of the body that's isolated for particular inquiry is isolated because it has a kind of an integrated character, and you think you can learn something about it. It doesn't mean that it's in a little box that you can pull out, right? So the immune system's in every cell, but it's still a system. And presumably the same is true of the language faculty. I mean, we might, it brings together many different components which come from all over the place. For example, the language faculty, what you and I are now doing, makes essential use of the delicate architecture of the bones in the middle ear. Okay, they're terrific for, wonderfully designed for understanding language. Of course, they evolved for reasons having absolutely nothing to do with language. They evolved from the fact that apparently that the skulls of early mammals, about 160 million years ago, were getting bigger. And as they got bigger, a bone in the reptilian jaw started to migrate. And for mechanical reasons, apparently, it ended up in the middle ear, which turns out to be great for language. And the same is true of, the computational principles that are at the core of language. I mean, we might discover that those are the same computational principles that are used by insects for navigation. If we did, that'd be a fascinating discovery. It would mean that it's one of the things that was recruited to form the language faculty. The idea that the language faculty is isolated from other cognitive systems just makes no sense at all. Can't be. I mean, we use the language faculty to express our thoughts, to think to ourselves, to communicate, to have and communicate attitudes, to perceive the world. Of course, it's integrated with the entire collection of cognitive faculties and other faculties. Again, the interesting question that should be asked about that question is why it says, do I still believe? Because nobody could possibly believe this. There's a huge mythology about these things which has been developed. It's kind of characteristic of studies of human higher mental faculties. They are pursued at a level of irrationality that is just hard to deal with. If the hard sciences had, in fact, centuries ago, the hard sciences were dealt with in a similar way, but we should be able to escape from that.
Have your views regarding poverty of the stimulus changed in light of these studies?
There are no such studies. All studies show what everybody knows in advance, that the amount of data available for language acquisition is extremely small. This notion of poverty of stimulus is a little bit like what I call the innateness hypothesis. Everyone believes in poverty of stimulus, not only for language, but for everything. I mean, there was a certain embryo once upon a time that turned into my granddaughter, okay? Why didn't it turn into a worm, let's say? Is it because of the nutritional input? Like would a different nutritional input to the cell have turned it into a worm? Well, nobody even takes these questions seriously. They're so idiotic. What is assumed automatically by every scientist is what's called poverty of the stimulus in the case of language. It's considered controversial in the case of human mental faculties, but taken for granted without even any discussion throughout the rest of biology because it's so obvious. It cannot possibly be that what you and I are now doing is based on early, or for that matter, late input for the environment, because there isn't any, virtually none. In fact, it's easy to demonstrate that the things that even a young child do have a statistical level that's barely at the point of noise. in actual discourse. The point is kind of obvious. There's nothing to discuss about it. Everyone agrees that there is poverty of the stimulus. The only question is, well, what is the initial state that in fact, first of all, structures data as experience, which is no trivial task, and then takes that experience and almost instantaneously and reflexively, as Gallistel points out, constructs an attained state. That's the problem. If somebody has some ideas about it, be my guest. It's a great topic.
You have suggested that human beings possess a language acquisition device. Is this device a real entity or a metaphor?
Well, kind of like asking whether the genetic endowment that leads to an immune system is a real system or a metaphor. I mean, we end up doing what you and I, well, let's go back to my granddaughter and her imagined pet chimpanzee. Let's suppose that the two of them are exposed to exactly the same data, okay? One of them ends up doing what you and I are now doing, the other one does nothing. Suppose that she also happens to have a pet bee, okay? Well, the pet bee and my granddaughter are exposed to the same visual data. In the case of the bee, it'll end up with a complicated, intricate system of communication that humans can't possibly duplicate. It's way beyond our cognitive capacities to communicate the distance and height and quality of a flower. Humans simply can't do that, but the bee does it reflexively. Well, observing facts like that, every scientist just takes for granted there's something special about my granddaughter or the bee and the chimpanzee which uses the same data to end up in very different states. And unless, it's miracles, that has to do with their genetic endowment. So therefore, we can talk about a language acquisition device, a chimpanzee call acquisition device, a bee communication acquisition device. These aren't metaphors. These are just descriptions of subcomponents of an organism which you try to understand. There's nothing metaphoric about them, and there really should be nothing controversial about them. I mean, unless one thinks that the bee, the chimpanzee, and my granddaughter should end up the same way with the same data. Unless anybody thinks that, then the answer should be obvious.
Is there any evidence of evolutionary change in the historical record of human language?
No. As I mentioned before, that at least current understanding is that there's extremely little genetic variation among humans as compared with other primates, meaning which is taken to mean that we're basically all kind of cousins, coming from the same small breeding group not very long ago. Like 100,000 or 200,000 years is essentially nothing in evolutionary time. So there's just been no time for any evolution. Nobody knows exactly when language got into the picture, but probably about the same time, roughly plus or minus 100,000 years. And there's been just no time for any evolutionary change to take place. That's why, say, my granddaughter, I don't know why I'm focused on her, but my granddaughter, if she'd grown up, say, in Tokyo, would be talking perfect Japanese, because she's genetically identical to the kids who grow up in Tokyo as far as this capacity, or probably just about every capacity is concerned. So then, if that's true, there can't have been any meaningful evolutionary change in the brief history of language. It's just way too short.
Now, this is the last, and it's a very open-ended question, so feel free to ignore it or do what you like. What details or results of current neuroscience bear on your current biologically based language theories?
Well, current neuroscience is providing some new ideas, not so much neuroscience as new techniques. For example, imaging, brain imaging, is providing rather interesting suggestive results, fMRI and things like that. You don't know exactly what to make of them because, these are investigating systems that are just not understood on the basis of signals that are detected from the outside. Some of the results are quite
in a way, startling. So, for example, Proceedings of the National Academy of Sciences just recently, a couple of months ago, published a paper by Laura Petito, an investigator who's was in Montreal, now in Dartmouth. She apparently seems to have shown that sign language, the deaf children who use sign, the neural centers that are involved in processing the sign are close to identical, as far as you can tell, identical with those of hearing infants who are processing auditory input. That's a very surprising result. I mean, a little less surprising than it would have been 20 years ago, because work has shown that these systems are very similar in many structural respects, but that they're neurally represented in the same place is quite interesting if it's true. It would mean that whatever our faculty of language is, it's probably independent of modality, sensory modality, some analytic computing system that could use one modality or another. The fact that, say, vision and hearing end up analyzed in the same place is a little bit surprising because of what's known about the projection of sensory systems into the cortex. But that kind of inquiry is pretty interesting and suggestive, and there is work of that kind coming along. As for neuroscience itself, remember that very little is known. I mean, I quoted the encyclopedia, the current edition of the MIT Encyclopedia of Cognitive Neuroscience, as pointing out that we do not understand the neurophysiology of even the most elementary computations that are used throughout the animal world, say for insect navigation. Even the simplest ones, the neurophysiology is completely obscure. When you try to get to human language, you're off in outer space somewhere. It's an important problem. Maybe someday it'll be understood, but it's pretty remote.
Well, thank you very much for a most stimulating lecture.
Well, I ended yesterday by describing the so-called principles and parameters approach, which gave the first serious conception, to my knowledge, of how the tension between descriptive and explanatory adequacy might be resolved. In this sense, it's fair, I think, to regard it as the first genuine proposal as to what a theory of language might be. Whether that step turns out to have been right or wrong, it offered a kind of a liberating perspective, which led to an explosion of highly productive inquiry, and it opened new problems to investigation, also revitalized the study of language acquisition along new lines, and other language-related areas of the cognitive sciences. To the extent that outstanding problems can be solved, not a simple matter, but to the extent that that's possible, we will have a conception of the initial conditions that map experience to the state that's attained by the faculty of language, to what I called yesterday the internal language, the I language, that determines the infinite array of sound meaning combinations that the speaker of a language has available for use, the potential expressions of the language. These initial conditions include, but are not exhausted by, the genetically determined initial state of the language organ. In addition, there's the third factor that I mentioned yesterday, general principles that are not coded in the initial state, just as properties of protein folding are not coded in the genome, but are available to be exploited in the growth of the organism. There is, I think, some reason to believe that understanding of language has at last reached a level that makes it feasible to address these questions. That is, to pursue the Galilean intuition that nature is somehow perfect, in this case, asking not only what the properties of language are, but why language has these properties and not others. That inquiry in recent years has been called the minimalist program. Notice that that program is theory independent. Whatever you think is the right theory of language, you may or may not decide to pursue these questions. The initial state can, that it can be disaggregated into elements that have a principled explanation and others that remain unexplained at this level of analysis. They have to be attributed, therefore, to something independent, perhaps evolutionary accident or properties of the brain that remain unknown and would have to be investigated along similar lines. The principled elements of the initial state are the conditions that are imposed on the faculty of language by the systems with which it interacts. These are what are called interface conditions. If language is to be usable at all, its design must satisfy these conditions. That is, the information that is in the internal expressions that are generated by the language have to be accessible to other internal systems. That includes language external but person internal systems, including sensory motor systems and conceptual systems that enter into thought and action. So we can therefore restate the deeper problem of determining why language has the peculiar properties that it does, insofar as the properties of an I language can be accounted for in terms of interface conditions and general principles of computational efficiency and the like. They have a principled explanation, and we will have verified the Galilean intuition of perfection of nature in this domain. Well, if one proceeds this far, you face a challenging task. The task is to examine every device, principle, idea, technique that is employed in characterizing languages and try to determine to what extent it can be eliminated in favor of a principled account in terms of general conditions of computational efficiency and the interface conditions that the organ must satisfy to function at all. That's been a focus of a good deal of work in the past few years, and there are by now rather plausible accounts in these terms of some basic processes of the computational system of language. These systems that previously had been stipulated as descriptive technology but can now be reduced to principles of computational efficiency, and also more complex properties of individual languages have, to an interesting extent, been derived from close examination of the way principled mechanisms function under minimization of search and other principles of efficient computation. Furthermore, what appear to be radical differences among languages have, in a number of interesting cases, been reduced to something close to the optimal conclusion. That means that the internal computational processes are identical. The phenomenal differences result not from how the mind computes, but rather how the internal objects that it constructs are related to external events by sensory motor systems. So these the interesting cases involve category of properties, features with no independent meaning that had not really been noticed before, though they're crucial, it appears, and differences in how the apparent diversity of languages seems to be traceable to a very significant effect to slight differences in the way these uninterpretable features are externalized, are used by the sensory motor system. It's as if the mind computes in a fixed way, but with varying effects at the mouth and the ear. The general observation, not this far, but the general point, was a very natural consequence of the principles and parameters approach. It was recognized from the moment that it came to be formulated with at least some clarity. Actually, I discussed it near here in 1979 at Kant lectures at Stanford. At that time, I referred to classic work, biological work on regulatory mechanisms by Jacob and Monod, two Nobel laureates, quoting their observations about how slight changes in regulatory mechanisms, utilizing differently the same structural information, might yield enormous phenomenal differences. There are examples, differences between a butterfly and a lion, or a worm and a whale, basically identical organisms, but with minor changes in how regulatory mechanisms function, same mechanisms. Similarly, slight changes in parameters left open in the fixed schematism of language might lead to what appear to be very different systems. Apologies here for quoting myself in 1979. It was actually in the years that followed that such ideas really did begin to bear fruit in the study of language. Similarly, in the biological sciences, there have been quite dramatic progress along similar lines. Such conclusions would have greatly pleased Alan Turing, I think. He's known to philosophers, linguists, logicians, computer scientists, mainly for his work in other areas, but some of his best-known work was on morphogenesis and the effects of chemical and physical law on the possible course of evolution. These are matters on which he took a rather strong stand and that have become a central topic in contemporary biology. One fundamental problem that remains is why there is parametric variation at all in the computational system. So why isn't there just one language? There are some possible answers that have been suggested, but the general problem, in my opinion, is still mysterious. It's a problem that eludes our grasp, but you can think of possible answers. One might also hope to approach the question of evolution of language in these terms. It's rather curious to compare the enormous number of pages devoted to the evolution of human language with work on evolution of much simpler systems, say bee communication. A couple of years ago asked a biologist friend to do a database search on that topic, and he could come up with very little. Apparently the subject is considered too difficult to pursue, although bees are just a wonderful subject. They only have 800,000 neurons, a brain the size of a grass seed, many different species that yield rich comparative data, a very brief gestation period, lifespan, no need to obtain consent forms for experiments, and so on, every conceivable advantage. But nevertheless, the problem is considered far too hard to study. The question of how the human language faculty it might have evolved is vastly more obscure and hard to study. One can imagine various scenarios. A number have been proposed. Some of them are maybe suggestive. But some leading evolutionary biologists, Richard Lewontin is the most prominent, they have argued strongly that the problem is entirely beyond reach in terms of anything remotely like present understanding. Lewontin at least, extends that to evolution of human mental faculties generally. Well, if we nevertheless want to pose the problem of evolution of language, we have to begin with the recognition shared by everyone that the faculty of language is not a distinct entity. It's not like a box in the human brain with a single location or a single function, whatever that term is supposed to imply. The faculty of language surely recruits processes, capacities, physiological mechanisms that have evolved quite independently. And it could turn out, in principle, that there's nothing in the faculty of language that's specific to language, that the faculty is just a specific form of organization of elements that are recruited to constitute this organ of the body, to borrow Randy Gallistel's term again. If the minimalist approach to language has real prospects of success, and at least my judgment is that it does, we would expect to find that language crucially involves interface conditions and computational processes. Some of these, at least, may have homologous structures in other primates, maybe even beyond. If that's the case, then the study of language will involve in part, the evolution of these elements, the evolution of the way they're organized in the language faculty, and whatever may have evolved independently in the last flick of an eye in evolutionary time in human evolution, and it's extremely short. There is intriguing work, very recent work, on primate perceptual systems that could bear on the topic. For example, a rather surprising discovery that untrained tamarin monkeys distinguish among some language types in ways that are analogous to newborn human infants, in all cases without any experience, though perhaps they use different cues. That's under investigation. Additional work is proceeding along similar lines, also investigating what Harvard primatologist Mark Hauser calls wild minds in natural settings, also experimental work that he and his laboratory are doing on a number of topics, including computational capacities of monkeys on language-like problems. It could turn out that the core computational properties of natural language are found elsewhere in the animal world, perhaps in what perceptual psychologists call the rules of visual intelligence that are used to create what we see, quoting. Conceivably, you might even find them in systems as remote as insect navigation. That possibility and others like them can't be excluded, and they do suggest avenues of research into the evolution of at least some of the factors that enter into human language, avenues that might be promising, in my view at least. If so, that would be the first time that the problem of evolution of language becomes a really serious problem. To proceed further along in any of these areas would require a good deal of background discussion that I can't take time for here. So let me just, and of course this is where the topic gets interesting, but I'll put that aside, and just restate the guiding intuition of the minimalist program, basically Galilean. Insofar as this program succeeds, we will be able to conclude that principles of the kind that one finds, principles that hold for, say, sphere packing in early cell division or formation of polyhedral cells of polyhedral surfaces of viruses, or stability of body forms and symmetries, maybe optimal wiring of neural systems, just general principles of physical and mathematical laws, may also hold for an organ that's a very recent product of evolution and appears to be a crucial component of whatever it is that's specific about human beings, certainly at the core of their existence, their thought, and their interaction, although we have to bear in mind that the classical problems of the theory of mind, the ones that preoccupied Descartes, Newton, and others, they remain as obscure as ever. And the problem of unification, while it takes a wholly different form after the Newtonian revolution, as I mentioned yesterday, that problem remains unsolved. The gaps look as unbridgeable today as they did for chemistry and physics not many years ago, 70 years ago. Well, let me return to the initial question that I began with yesterday, the questions that are sometimes called the problems of intentionality. That is, how does language, this biological entity, how does it relate to the rest of the world? One of these is the unification problem. How do accounts of the brain in terms of computational systems or relate to others, say in terms of cells. As long as that question is unanswered, there's a crucial explanatory gap in accounts of behavior, whether it's insect navigation or human language. There's a gap in accounting for how computations eventuate in action. Notice that this is over and above the questions that are not even posed, that is the questions of choice of action. So like, why does a cricket turn left instead of right? What about the second problem of intentionality? That is the use of language to talk about the world, as when I say that I read Darwin's Descent of Man referring to a book. There are parallel problems on the receptive side, but let's focus attention on the questions as they arise for the speaker. These questions have two aspects. One is, how does the sensory motor system use the instructions provided by the internal language to carry out gestures? That would be articulatory gestures in the case of spoken language. And second, how does the system of thought use these instructions to talk about a book or a river or the crisis in Argentina or whatever it may be? It's this second aspect that's held to be particularly vexing. But perhaps one can gain some insight into it by asking about the less contentious interface with sensory motor systems. So we now put aside the explanatory gap that holds for all animal behavior, and we ask how the phonetic information that's generated by the internal language is accessed and used by the sensory motor system for articulation, alternatively perception, but I'm putting that aside. Let's adopt a conventional, but in fact non-trivial assumption, namely that the phonetic information of each expression is encoded in a single internal generated object, what's called its phonetic form or phonetic representation. Here you have to be careful to divorce the notion representation of any connotations drawn from other uses of the term, as in the classical theory of ideas or in discussion of representational art, for example. These problems have been studied intensively with high-tech equipment for half a century and long before that in other ways, but understanding remains quite limited. The problems are not easy. Well, maybe everybody's overlooked an easy solution, which works like this. We all agree that the lexical item, any lexical item, say book, has a sound, and sounds are perfectly robust and familiar notions. So we can tell without difficulty whether some event is the sound of book or the sound of river. Unproblematically, we can speak of the various events that are sounds of book, of the word book, on various occasions of use. So let's just say that the internally generated phonetic representation of the word book just picks out a sound, or many sounds if we like. That relation we can give a name. We can give that relation a name. Let's call it phonetically denote, P denote. Let's say that that relation holds between the internal object and the sound. Its properties will be the properties of the technical notion, denote or refer, that's devised for formal systems, say the relation between the numeral 3 and the Platonic entity 3 in a system of formal arithmetic of the Phrygian variety, for those of you who know some logic or metamathematics. Further inquiries about the sound don't have to bother us. They can be forwarded to the physics department. Perhaps they'll tell us that the sound is some indescribable four-dimensional space-time construct based on motions of molecules. Perhaps inquiries can be forwarded to the sociology department too, if we want to make the task even more hopeless, by introducing some unexplained notion of common language that involves norms and conventions, attitudes, experts, and so on. Well, however we proceed, there aren't any ontological problems, that is, no problems about existence. No one doubts the existence of the particular motion of molecules that I produce when I say book. So there's no problem about the existence of sounds. The notion is perfectly robust, to borrow the standard philosophical term. Problems of communication are very easily solved. You identify what I'm saying because your internal representation P denotes the same sound as mine, or at least a sufficiently similar one. Okay, without proceeding, we've now solved the problems to which acoustic and articulatory phoneticians have devoted so much labor without much success. Well, it's clear enough why this solution has never been proposed. It's a bad joke. The new theoretical notions, sound and P denote, are completely useless. They merely restate the problem in vacuous terminology, leaving the problems, in fact, even in worse shape than before. The proposal has all the virtues of theft over honest toil, to borrow Bertrand Russell's aphorism. The actual course pursued is much harder. We have to discover the elements of the phonetic representation of the word book and others, the properties that constitute it. Those are commonly called its features. And we have to determine how feature complexes are accessed by the sensory motor systems and related to external events, maybe ultimately motions of molecules. There's no determinate mind external object that's picked out by an element of the phonetic representation as its sound. Rather, these internal objects provide information that's accessed by other systems to yield or interpret mind external entities in a variety of ways that depend on circumstances, expectations, and a host of other factors. In fact, the real world problem is so intricate and involves so many variables that no one even contemplates studying it. Actual inquiry keeps to highly idealized experimental situations, as always in the natural sciences. Well, let's now consider an easy answer to the problems that arise on the meaning side, following point by point the preceding ridiculous account of the sound side of language. We all recognize, I made up the other one, but the one I'm going through now is real, unfortunately. We all recognize that the word book has a meaning, just as it has a sound. The entity book, whatever it is, has an internal semantic representation that incorporates all information about its meaning that's determined by the language, just as the internal phonetic representation incorporates all language-determined information about sound. And we know exactly what the word book or its semantic representation picks out in the world, namely books, just as the phonetic representation picks out the sound or the sounds of the word book. So we can therefore set up a relation that's a counterpart of P denote, let's call it S denote, meaning semantically denote. S denote holds that relation, holds between the internal semantic representation of the expression book and books. You understand that I'm talking about books, not tables, because your word book S denotes the same things as mine, and the child acquires the S denotation relation by virtue of causal properties of the world that relate external phenomena to mind internal entities. Let's call them concepts, to use the standard term. Those who are concerned about the status of the external objects that are S denoted don't have to have any qualms. These are some indescribable constructions based on whatever physics tells us about the world, and we can forward further inquiries to the physics department, or maybe the sociology department, again, if we want to make it even more hopeless. There aren't any problems about the existence of books. Those are the things that are on bookshelves and tables. It's true that if you and I both took Darwin's Descent of Man out of the library, there is a question about whether one book was taken or two, but we can settle this any way we like. And if someone is concerned that books are simultaneously abstract and concrete and have a host of other extremely odd properties when you look closely, we can answer robustly that that's just what books are. It's a problem of metaphysics, not semantics or cognitive science. Well, it should be clear that something's gone badly wrong. We're back to theft rather than honest toil. For one thing, referring is something that people do, not words. It was stressed 50 years ago by Oxford philosopher Peter Strawson, and known before, of course. And like other human actions, referring is a highly intricate action. It's specific to circumstances, it has normative aspects. The act of referring succeeds or fails in ways that depend on a wide variety of conditions. The act need not even involve terms that have some circumstance-independent relation to the referential intention. So, for example, I can refer to India without using any word or having any thought that has any independent connection to India, whatever India is. If such fundamental properties of referring the act are omitted from consideration, one may be studying something, but it's not the problem of intentionality or aboutness. Well, a fair response that could be given is that exactly in other cases, we have to idealize if we hope to gain some grasp of reality. We have to abstract away from a welter of complexity to focus on the properties of core notions, in this case, S denote or P denote. And that's a reasonable response, but it's a promissory note. As in other cases, it has to be justified by showing how the idealization yields some insight and explanatory power, and doesn't merely reformulate the original dilemmas in misleading ways. That doesn't seem an easy task in the present case, to put it rather mildly. In fact, I think it really is theft rather than honest toil in both cases. The case that's never even discussed, the sensory motor side, and the case that's pretty standard, the analog on the semantic side. Well, how can we approach the problem of what's happening when we think or talk about the world? It's possible, and in my view likely, that the study of sound provides some useful clues to that. In that inquiry, there isn't any reference-like relation between an element of phonetic representation and a mind-external entity. Rather, the speaker-hearer employs the systems of language use to access the phonetic representation, the internal object, so as to produce and interpret organism external events. And perhaps something similar is true on the meaning side. So Smith uses an expression to refer when his attention is focused on some parts of the world, which he views from the complex perspectives that are provided by internalist semantics, very much as in the case of sound. Features of the internal item book in Smith's internal language provide information that's used by other cognitive faculties, constraining the ways that Smith uses it to talk about the world, think about the world differently from other words. Smith succeeds in communicating with Jones to the extent that Jones attends to related parts of the world and has appropriately related perspectives and understanding of circumstances and background. Similarly, Jones's ability to perceive what Smith is uttering depends on his ability to map the noises that he hears to his own internal language. And these are always matters of more or less, not yes or no. Well, that's the point of view that I've personally regarded as reasonable since I began thinking seriously about these topics about 50 years ago, at that time influenced by Oxford ordinary language philosophy and the later Wittgenstein. But as I later learned, the approach has traditional antecedents. There's an important 18th century critique of the theory of ideas based on the observation that the phrase, "he has an idea," should not be understood on the model of "he has a diamond," invoking a reference-like relation between the term idea and some extra mental entity. That's putting aside for the moment whether that's even a proper step in the case of Diamond. I think it's not. Rather, the phrase, he has an idea, 18th century commentators pointed out, the phrase he has an idea means something like he thinks. The phrase is what Gilbert Ryle called a systematically misleading expression in an influential contribution to 20th century ordinary language philosophy, actually resurrecting a traditional critique. And the same conclusion holds for belief, thought, desire, other terms of so-called folk psychology, as expressed in its English language version, which is far from universal and in fact rather idiosyncratic. The basic insights generalize to the whole vocabulary and even more dramatically to more complex expressions constructed from lexical items. If this is anything like correct, most of the work that's going on in philosophy of mind, philosophy of language, and theoretical cognitive science is just off on totally the wrong track. It's my opinion, has been for years. The roots of these insights are far deeper. In fact, they extend well beyond misleading analogic interpretations of surface form, as in the case just mentioned, the 18th century case resurrected by Ryle. Perhaps the first study of these matters was by Aristotle. He asks, for example, what's the nature of a house? And he concludes, quoting Aristotle, we can define a house as stones, bricks, and timbers in terms of its material constitution, or as a receptacle to shelter chattels and living beings in terms of function and design. So I may think that the place that I call home is a house, but I could be wrong. It could really be a library in which some odd people spend much of their time. And in fact, someone entering it for the first time might be pardoned for reaching that conclusion. The answer depends on choice of perspective and on circumstances, which I might not even know. So if that thing was designed to be a library and is characteristically used that way while I'm gone, in fact, much of the time I'm there, then perhaps it really is a library. It's not a house, contrary to what I thought. Or perhaps it's really a garage, or maybe it's an oddly constructed and misplaced paperweight belonging to a giant, and so on. There simply is no mind-independent truth of the matter, and material constitution, as Aristotle recognized, is only one factor in reaching answers. We can also integrate the factors of material constitution and function design. That's, in Aristotle's terms, combining matter and form. And we can bring in other factors too, some of which he also explored. Well, for Aristotle, these are questions of metaphysics, that is, the way the world is. Notice that he talked about defining house, the thing, not the word house. From the 17th century, there's been a very reasonable tendency to reformulate such analyses in epistemological conceptual terms, that is, as properties of something real, but the construction and interpretation of experience that's provided by our cognitive capacities. That's our cognoscitive powers in 17th century terminology, which include the internal semantics of the language. And in fact, there was quite illuminating discussion of these issues by Hobbes, Cudworth, Locke, many others, sometimes adopting David Hume's principle, that, quoting him, that the identity with which we ascribe to things is only a fictitious one established by the mind, not a peculiar nature belonging to what we are talking about. Well, in all of these matters, textual interpretation is uncertain, but the general idea seems clear enough and very plausible. The house that Smith lives in, or the books that he's reading, surely do not have their strange and quite intricate properties by virtue of some mind-independent constitution. And the properties really are strange and intricate as soon as you look at the meanings of the words carefully. Dictionaries have nothing to say about this, they just presuppose it. Rather, they have these properties by virtue of the way Smith and others think in particular circumstances and the internal meanings of the terms in which these thoughts are internally or sometimes externally expressed. These devices, in turn, are a property of fixed and shared internal human nature, as are other aspects of their lives and being. The semantic properties of expressions are used to think and talk about the world in terms of perspectives that are made available by the resources of the mind, rather in the way that the sounds of language seem to function, in the latter case, as everyone assumes. I've tried to show elsewhere, and won't review, that these conclusions are supported by descriptive observations that are in a tradition, 17th, 18th century tradition, that's been much too long forgotten and greatly reinforced when we look more closely into the meanings of even the simplest words, including those investigated in 17th, 18th century philosophy, British empiricism, and others, words like tree or river or person, or names of substances like water, or the most elementary devices of reference and anaphora, probably every aspect of language. All are far more intricate than has commonly been supposed, so much so that they must come to us from the original hand of nature, in David Hume's phrase, and hence must be fundamentally the same for all languages. These topics have been addressed in illuminating work by Julius Moravcik over at Stanford on what he calls the ideational theory of meaning, bringing classical sources to bear on contemporary issues of language and thought. Others have pursued them too, and the approach seems to me to have a lot to recommend it. Well, what about Fregean systems, the ones that are usually adopted? That is, systems based on the relation of denote or refer, holding between linguistic objects and extra-linguistic entities. It seems to me that these are reasonable enough for Frege's specific purposes, most important for what really interested him, namely formal studies of mathematical objects, at least understood Platonistically in his terms. The ideas also seem appropriate as a kind of a normative ideal for the specific human enterprise of science. That is, one hopes that such notions as a black hole or oxygen or electromagnetic field will pick out something in the world, in the mind-independent world. And we hope that the same will be true of the internal entities and computational principles that are postulated in the study of insect navigation or visual perception or human language. There's also some evidence that animal communication, outside of humans, is based on a notion of representation that's similar to the invented technical concept of reference that's familiar in the study of formal systems. Here the concept representation is understood as isomorphism, that is a one-to-one relation between mind-brain processes and an aspect of the environment to which these processes adapt the animal's behavior, as for example when an ant picks out the corpse of a conspecific by its odor. Actually, I'm quoting here again Randy Gallistel in the comprehensive introduction to a series of essays on animal representation. Well, if the picture that I've just briefly reviewed is anywhere near accurate, it could turn out that the use of language, human language, to refer or in other ways is totally different from animal communication systems in this as in numerous other respects. Human language might not have any denotational semantics, just an intricate form of pragmatics along with very rich internal syntax that includes what's usually called semantics but ought to be called syntax. It's the study of internal representations. Of this amalgam, the parts that we can currently hope to understand in most depth are the internal syntax, what's called semantics. A theory of human action that would bear on, in some revealing way on the act of referring is far more remote than comparable theories for much simpler organisms and actions, domains in which the problem is scarcely even entertained, because it's understood to be far too complicated. Well, so far I've kept the language, but in principle, everything I've said should carry over to the study of other mental qualities. In practice, however, the difficulties mount very quickly. Language appears to be relatively isolated from other cognitive capacities. Here I'm referring to its structure, not its use or particular components which are integrated into the structure, which could be individually shared with other cognitive faculties or even other species, as I mentioned before. One of the reasons why language is a good topic for study, for inquiry into the mind, is its essential role in human affairs, but another is that it is indeed, or appears to be, relatively isolated. When we turn to other aspects of mind, for example, our moral nature, it's much harder to isolate components for separate study. That means to abstract them from reflective thought and a variety of other factors. Nonetheless, those topics, study of our moral nature, have been subjected to investigation in various ways. That includes interesting thought experiments, actual experiments with children in the last couple of years, and comparative studies. Not uncommonly, the real world offers illustrations of how these faculties function, sometimes with very painful choices. Issues like that test our moral faculties and may help us to discover something about their nature. Sometimes this perspective is counterposed to what's called a relativistic one, which holds in an extreme form that apart from their basic physical structure, humans have no nature. They have only history, or that their thought and behavior can be modified without limit. Nothing like this can be even close to true if taken literally, though it seems to be what is sometimes said. In a version due to Richard Rorty, history and anthropology, I'm quoting him, show that humans have extraordinary malleability. We're coming to think of ourselves as the flexible, protean, self-shaping animal rather than as having specific instincts. There can be no moral progress in human affairs, just different ways of looking at things. We should put aside the vain effort of exploration of our moral nature or reasoned argument about it. We should keep to what he calls manipulating sentiments if we happen to be for or against torture or massacre, for example. I suspect I'm misinterpreting because it's hard to believe that the words are intended to mean what they seem to say. Well, such proposals have evoked a good deal of criticism. The Oxford philosopher Galen Strawson, quoting related statements of Rorty's on the irrelevance of the extra-linguistic world to truth, he asks whether the nonsense might be less bad if it didn't build in such an astonishing contempt for the reality of human suffering. His conclusion is it's just as bad. A recent paper on the philosophical foundations of human rights by Matthias Malmann, discussing Rorty and others, points out that, quoting him, nobody would have taken a Nazi seriously who had claimed in 1945 that the sole basis for the moral condemnation of the Holocaust by the rest of the world is just due to some kind of culturally relative emotional manipulation based on shrewdly devised sentimental stories. If that's so, and I assume it is, we want to understand why, and if nobody really means no normal human being, that leads us back to the hard questions of intrinsic human nature. This notion of unique human malleability is not at all novel. It's been a fairly conventional view, at least back to the beast-machine controversies that were inspired by Descartes. For example, the argument of James Harris, British philosopher in 1740, that unlike animals and machines, the leading principle of man is multiform, originally uninstructed, pliant, and docile. The idea that human alleged weakness of instinct leads to vast variety and extreme malleability has had a long and, in fact, inglorious history ever since. Well, with no metric and little understanding, it's hard to know what to make of those judgments. But whatever merit they have, they cannot offer an alternative to the conception that I just outlined. No one doubts that a person's understanding and judgment and values and goals reflect acquired cultures, norms, conventions, and so on. But these aren't mind external entities. They're not acquired by taking a pill. They're constructed by the mind on the basis of scattered and constructed experience, and they're constantly applied in circumstances that are novel and complex. Actually, these facts and their significance were discussed 250 years ago by David Hume, who observed, I'm quoting him, that the number of our duties is in a manner infinite. Therefore, just as in other parts of the study of nature, we must seek a few general principles upon which all our notions of morals are founded, principles of human nature that are original instincts of the human mind. They're perhaps enhanced by reflection, but steadfast and immutable as components of fixed human nature. Hume, notice, is articulating the basic idea behind generative grammar in a different cognitive domain and centuries earlier. Like Adam Smith, Hume took sympathy to be what he called a very powerful principle in human nature, one of our original instincts, and the grounding of much else. That idea was reconstructed in a Darwinian framework about 100 years ago by the anarchist natural historian Peter Kropotkin in what I think should be taken as the founding work in what's nowadays called evolutionary psychology. And there's recent work that suggests some possible evolutionary scenarios. Well, there's little reason to suppose that the variety of cultural outcomes reflects significant variety of genetic endowment. So we're back to the situation we face in the study of language or the visual system or any other basic property of organisms. It's necessary to account for the richness and specificity of outcome on the basis of shared intrinsic nature, tolerating variation, but within a highly structured range as throughout the biological world. Well, to this picture, we should add other conceptions that have been studied in recent years and also resurrecting the 17th century origins of modern science. One strand is the recognition that our innate capacities are only latent. That is, they have to be triggered by experience to be manifested. Then they're manifested in ways determined by our intrinsic nature, much as susceptibility to a disease is innate, though the disease requires an external trigger. That's actually the analogy that Descartes suggested in discussing innate ideas. One of the reasons why Locke's famous critique is beside the point, as long recognized. Another idea that was fruitfully examined in the 17th century is that the phenomena of the world around us do not in themselves constitute experience. They become experience for us as they are constructed by our modes of cognition. I'm quoting 17th century work. They must therefore conform to these modes of cognition. This is 17th century picture, came into modern thought through Kant's version of it. These modes of cognition are a distinctive property of our nature. They differ for different organisms. They're what the evolutionary biologist Konrad Lorenz called a biological a priori in work that I, in fact, discussed here 35 years ago. That's also true of the rich mental constructions that we call cultures, norms, and conventions, insofar as they're shared by groups that interact in complex ways. Well, still assuming that each child is intrinsically capable of acquiring any culture over a very broad range, the process of mental construction of experience and interpretation of it is based on the common genetic constitution, which must be rich to the extent that the outcomes are highly structured and constrained in ways that do not simply reflect features of the environment, basically Hume's observation. It seems unavoidable that the so-called relativistic approaches must be profoundly innatist, at least if they're willing to address the issues of nature, acquisition, and use of attained systems, Hume's questions. If so, then they fall together with the study of visual or linguistic systems or other properties of organisms. Hard to see any serious distinctions here, or any interpretation under which relativistic approaches differ from the most highly innatist approaches. Well, one last word on the import of any conclusion, and it has to be a very tentative conclusion about human nature. One way to assess the importance of such conclusions is to observe how deeply they enter into conceptions of right and justice and the struggles that they engender. It's very easy to illustrate from personal relations to international affairs. More generally, every approach to how human relations should be arranged, whether it's revolutionary or reformist or committed to stability, every such approach is based on some conception of human nature, at least implicitly. If it has any claim to moral standing, it's advanced with the claim that it's beneficial to humans, meaning because of their intrinsic nature, at least as one of its crucial qualities. We should face honestly the fact of our ignorance, which is profound, but yet recognize that we have no choice but to proceed on the best tentative assumptions we can reach. For many of the classical mysteries, quite extraordinary bodies of doctrine have been developed in the past several hundred years. They're some of the greatest achievements of the human intellect. They also have far-reaching implications for human life. And there have been some remarkable feats of unification as well, sometimes very surprising in how they turned out, as in the cases I discussed yesterday. How remote the remaining mountain peaks are, even where they are, one can scarcely guess. Within the range of feasible inquiry, there's plenty of work to be done in understanding mental aspects of the world, including human language. We would do well, however, in my opinion, to keep in some corner of our minds Hume's conclusion about nature's ultimate secrets and the obscurity in which they ever did and ever will remain, and particularly the reasoning that led him to that judgment and the confirmation of that reasoning in the subsequent history of the hard sciences. These are matters that are too easily forgotten, I suspect, and that merit serious reflection, perhaps someday even constructive scientific inquiry. Thank you.
We have a number of questions that we'd like to put to you.
Okay.
First of these is, when you say that language is a matter of computation, do you mean in the observer-relative or the observer-independent sense? And do humans really start off in the world with the requisite concepts to express things like carburetor and bureaucrat?
Well, as far as the first part is concerned, we could ask the same question about insect navigation. So take the very complex, you take a look at, say, the study of insects by scientists. You find that they attribute to the insect highly intricate computational systems which enable, say, bees or ants to do things that are far out of our range. I mean, we can't determine the azimuth of the sun as a function of the time of year and day, or do dead reckoning the way an ant can, and so on and so forth. The explanations of these that are offered in the literature are computational systems. Are they independent of the observer? Well, in the sense that any science is independent of the observer. So when you have a model of the, say, planetary system, In a sense, it's relative to the observer. That is, we can't get out of our skins. That's hopeless. But the enterprise of science is an effort to get out of our skins as much as we can. You try to construct an account of the world that is as observer independent as we can manage. There are limits to this, for example, studied in quantum physics, but we can put that aside. So yes, it's observer independent in the sense in which any scientific construct is observer independent, no different. It's true whether it's computational systems of insects, whether it's computational systems of humans, whether it's the planetary system, or anything else that science tries to understand. As for carburetor and bureaucrat, I have to say that my friend Jerry Fodor was a little offended by the fact that the statement you quoted was attributed to me in a recent article. Actually, it's his proposal, and he wrote to me that he's sorry that it came up because he can prove that the notion carburetor isn't innate, since he doesn't even know how to spell it. But the fact is that he was making a very serious point. His point was that we have to somehow account for the fact that terms like carburetor and what was the other, bureaucrat, we do understand. Just as we understand river and tree and person and very simple words, and we understand them on the basis of extremely limited evidence, and we have a rich and complex understanding of them. So we're back to the problem of why we grow arms rather than wings. You can't just wave your hand about it and say, well, it's the culture, because then we have to ask, how did we acquire the culture? And as I said, it's not by taking a pill. The culture is a construction of the mind on the basis of scattered experience. So the answer that Fodor takes a stronger position than I do. I don't want to defend his position, but in general, this is the problem. What is it about the nature of our minds, the intrinsic nature of our minds, that allows us to acquire concepts like river, person, tree, water, book, carburetor, bureaucrat, even though we have very scattered experience? And that's the general problem of developmental biology. And the only answer that anyone knows is the one I just quoted from Hume, talking about our moral nature 250 years ago, and the one that's assumed by every biologist for everything except human mental qualities. It's got to come somehow from the intrinsic nature of our minds. And in that respect, it's innate. The fact that it's difficult to accept is a sign of our irrationality, because it's got to be that way, unless it's a miracle. It's either a miracle or it's pretty much along the lines that Fodor suggested, maybe not as extreme as his position.
Thank you. Somewhat related, the second question is it a good idea or not to search for evolutionary precursors to language, whether in cognitive, sensory, or motoric systems?
Yeah, it's a good idea. In fact, if you can find any, fine. In fact, I suppose the question was written before the comments I made. Yeah. Well, yeah, I think it's a fine idea. In fact, I think we're just getting to the point where it may be possible to do it. I mean, if in fact something like the program that I very sketchily outlined, if something like it turns out to be correct, that is, if we can give a principled explanation for significant aspects of language in terms of interface conditions, and computational principles, then it makes perfect sense to search not only for, I wouldn't call them precursors, for homologs, homologous structures in other organisms that happen to be like this. And as I say, we might find very remote ones. We might, I don't think anyone expects it, but you can't exclude the possibility that we might discover that the basic computational principles of language show up in insect navigation. It's not impossible. In fact, it's not even crazy. It wouldn't be a precursor to language, like bees aren't a precursor to humans. Remember, species are not precursors of one another. Like bees are no more precursors of us than we are of bees. It's just different evolutionary lines. If you can find sensory or perceptual or other computational components in the nature of other organisms that have some potentially homologous relationship to human language, yeah, that would be interesting, of course. That's what evolutionary studies are about.
Well, further proof that these were written before you spoke is given by the next question. Why are children geniuses of language between ages 1.5 and 4, yet other cognitive abilities are still developing at a much more concrete, much less abstract level?
It's kind of like asking why why children undergo puberty around age 12 instead of age 35. That's the way that's the way we're designed. We're designed so that certain things happen at particular times. In that respect, we're like every other organism in the world. I mean, binocular vision, being able to focus your eyes and use that for depth perception and so on, that comes along at around 4 months. So we might ask, well, why does it come along at 4 months and not at 1 month or 6 years? Well, the answer to that would have to be something about the way we're genetically programmed. All of these questions are much too hard to answer. Nobody knows answers to any questions like that, even for primitive organisms, what we call primitive, like insects, which are by no means primitive. But to try to answer the question for language is far beyond reach. Nobody knows how genetic instructions create an organism. It's one of the reasons why the Human Genome Project is looked at with some skepticism by many biologists. You could know the entire human genome, and that would tell you very little about humans, because you don't know how you go from genetic instructions to an organism. That's an incredibly complex process, only tiny bits of which are understood. And this is just one of those many questions, all of them very poorly understood.
Somewhat different direction is indicated by the next question. If the study of language is a branch of natural science and language consists of a lexicon plus computations, how would you respond to Searle's critique that computation is not a notion of natural sciences like mass or photosynthesis, but an abstract mathematical notion which is entirely relative to the observer?
Yeah, same. Well, first of all, it's not relevant. It's relative to the observer in the same way that any scientific construct is. Yes, in that sense, of course it is. Is it an abstract mathematical concept? Sure it is, just like Fourier analysis, calculus. Anything that's used in the sciences is an abstract, in the advanced sciences, is an abstract mathematical concept that is applied to particular situations. That's why Newton and Leibniz had to invent calculus in order to study the effects of motion. And the same is true here. Computational systems are particular kinds of mathematical notions that appear to be very well adapted to problems like, say, insect navigation, bee communication, human language, and some other things. So the point is correct. Yeah, it is an abstract mathematical concept used in these areas to give us the best theories that we can find. If somebody can find a better theory that doesn't involve computation, great. Let's have a look at that for insects or humans or anything else. But until then, we just work with the best theories we can find. Notice that this is very similar to what I talked about yesterday concerning chemistry. Up until very recently, in fact, less than a century ago, 1920s, leading scientists described chemistry in exactly the same way. They said it's just a computational system, it's just an invented computational system, it's a calculating device, it yields the phenomenal effects that you see in experiments, but it's not real. It can't be real. It's just something that people invented in order to have some way of organizing the phenomena that they discover in experiments. Why can't it be real? Well, because it couldn't be reduced to physics, which was true. Couldn't be reduced to physics. Reason, physics was wrong. So it couldn't be reduced to physics. After physics was radically revised by the development of quantum physics, Linus Pauling succeeded in giving a quantum theoretic account of the chemical bond. He won the Nobel Prize for it. It's 1935. It's not that long ago. And then chemistry and physics were unified, and everyone recognized that all of this talk about calculating devices was complete nonsense. Chemistry was the best theory you could devise for dealing with these problems. And that's the only notion of reality that we have. We don't have any other notion. The only notion of reality we have is whatever our best theories provide. There's nothing else. So chemistry was as real as you like, happened to be more real than physics, which was on a wrong track. When physics changed, they became unified. You get contemporary science. In this case, the best theories we have, as far as anyone knows, are computational theories. So that's reality. If neurophysiology doesn't integrate with them, we don't know where the problem is. Maybe in the brain sciences, maybe in the computational theories, maybe everything's on the wrong track. That's often happened in the history of science too. You know, you don't know the answers until you find the answers. But there are no questions about reality and calculating devices and observer relativity and so on. They simply do not arise for reasons which are well understood. We have a couple of centuries of history of the hard sciences from which we ought to be able to learn some lessons, including these. And they apply in this case as in earlier cases.
As a theoretical chemist, thank you for transcending some boundaries. Moving along. You mentioned yesterday that a number of theories of biolinguistics are, quote, pointless or obviously misguided. Why then do other scholars continue to pursue them?
Got to ask the other scholars. I can't. It depends. I mean, I mentioned a few and gave some reasons why I think they're misguided. Incidentally, those were not theories of biolinguistics. Mm-hmm. Those were theories of language which deny that language is a part of the world.
Gotcha.
I think that's seriously misguided.
Mm-hmm. You have disqualified Quine's radical translation paradigm, calling it a new, quote, methodological, epistemological dualism, close quote. Could you explain this more?
Well, the radical translation, there's a little misunderstanding of this. The radical translation paradigm, the fact that this will only be intelligible to those of you who know this stuff, but Quine's conclusion about what he calls indeterminacy of translation that comes from this paradigm, I don't disagree with that conclusion. I think the conclusion is correct. It just seems to me a truism. That's what I thought when I was a student of Quine's in graduate school 50 years ago, and we argued about it then, and I still think so. It's true, but it's a truism. In fact, it's just one example of underdetermination of theories by evidence, known to be a truism, at least since Hume. Quine's argued that there's something more involved, but I don't think he's demonstrated it. You can look at the literature and see. As for the radical translation paradigm, that's an approach to the study of language that we would never adopt in the study of anything else, say insect navigation or any topic. You would never adopt that paradigm. In that case, you have to ask, why do you adopt it for why do you propose it for human language? Well, as far as I can see, that's a kind of methodological dualism. It's saying we somehow have to approach higher human mental faculties by methods that we would never use anywhere else in studying the physical world. Now, that's not old-fashioned metaphysical dualism. It's something much worse, methodological dualism. Metaphysical dualism, mind-body dualism, that was a scientific theory. It was a substantial scientific theory. It was the early scientific revolution, Galileo through Newton. It was a serious scientific theory. There was a conception of matter in terms of a mechanistic picture of the world, what's called contact mechanics, common sense mechanics. Things interact if they're in contact, what we all intuitively believe, even if we've taken a physics course and know that it's false. We still believe it because we can't help it. It's our nature. So contact mechanics was developed, gave a picture of matter. There were clearly some things it couldn't accommodate. It's Descartes' point, and he was correct. He therefore postulated a different principle to account for them. That's science. It's the right way to do science. He was shown to be wrong in a surprising way, namely matter doesn't exist. Okay, therefore you can't, doesn't matter, it's of no interest that other phenomena don't fall within the concept of matter because nothing does. Okay, so that ends metaphysical dualism. There's no more mind-body problem. Methodological dualism is just pernicious. There's no reason why we should study human higher mental faculties in suicidal ways, which we would never use in studying other topics. Why should we do that? That's a kind of a methodological dualism which has no saving graces as far as I can see.
Thank you so much, and thank you for a couple of wonderful presentations. Please join me in thanking Dr. Chomsky.
About quite a few years ago, in the 1960s, I agreed in a weak moment to give a talk with the title Language and Freedom. And when the time came to think about it, I realized I might have something to say about language and about freedom, but the word "and" was posing a serious problem. There is a possible strand that connects language and freedom, actually has an interesting history of exploring it, primarily in the 18th century, but in substance it's pretty thin and speculative. And not surprisingly, I have the same problem today. There are useful things, I think, to say about universality in language and also about universality of human rights, but that troublesome connective is still raising difficulties. The only way I can think of dealing with the dilemma is to say a few things about each of the two topics with barely a hint about the conjunction, leaving that problem for you to deal with unless Liz solves it in her remarks. Well, let me begin with universality in language. The most productive way to approach the problem, as far as I know, is within the framework of what's come to be called the biolinguistic perspective in the last 40 or 50 years. It's an approach to language that began to take shape in the early 1950s. It was very much influenced then by recent developments in mathematics and biology. And the approach interacted productively with a more general shift of perspective in the general study of mental faculties, sometimes called the cognitive revolution. It would be more accurate, I think, to call it a second cognitive revolution, which revived and extended important insights and contributions of the cognitive revolution of the 17th and 18th century, which really deserves the name, I think. It was regrettably had been forgotten by the 1950s, in fact, long before, and is still largely unknown. In the 1950s, the study of language and mind was commonly considered part of what were called the behavioral sciences, all aspects of sociology, psychology, and so on. Well, as the name indicates, the object of inquiry in the behavioral sciences was taken to be behavior. And for linguistics, that meant also the products of behavior, like texts or a corpus elicited from a native informant. Linguistic theory consisted of procedures of analysis, primarily segmentation and classification. It's both European and American, guided by limited assumptions about structural properties and their arrangements. One prominent theoretician in 1955, Martin Jost, hardly exaggerated in an exposition of the fields when he identified the decisive direction as the decision that language can be described without any pre-existent scheme of what a language must be. And prevailing approaches in the behavioral sciences generally were rather similar. It was very common to suppose that apart from some initial delimitation of elementary properties that could be easily detected in the environment, what Quine in his highly influential framework called a quality space, apart from that, undifferentiated learning mechanisms of some kind would account for what organisms know and do that would include humans. The biolinguistic approach, along with related areas of the cognitive sciences, adopted a quite different stance. It took the object of inquiry to be not behavior or its products, but rather the internal systems that enter into behavior, into action and interpretation, and at a deeper level, the basis in our biological nature for the growth and development of these internal systems. The goal was to discover what a 16th century innovator, Juan Huarte, described as the essential property of human intelligence, the capacity of, I'm quoting him, the capacity of the human mind to engender within itself by its own power the principles on which knowledge rests. These are ideas which were developed in quite important ways in the years that followed, up to the early 19th century. For language, the principles on which knowledge rests are those of the attained state of some internal faculty, the language faculty. The knowledge that rests on those principles covers a very wide range, from sound to structure to meaning. In even the most elementary cases one can think of, turns out that what is known is quite intricate when you look closely, even the simplest words, for example. So I'll just take one that interested British empiricists. Just consider the Charles River over there, or wherever it is. Thomas Hobbes was interested in the idea of what a river is, and he suggested that rivers are mentally individuated by their place of origin. So it would be the same river if it went somewhere else, but originated in the same place. The concept river is what he and others at the time called a common notion that is part of innate knowledge, and this would be one of its inherent properties. Well, that's part of the picture, but it's not quite accurate, and it only scratches the surface of the common notion, as we can quickly discover just by thinking about it a little. We all know that it would remain the very same river under quite extreme changes, but it wouldn't be a river at all under extremely slight changes. So it would still be the Charles River, contrary to Hobbes, if the course reversed, it went the other direction. Or if it was divided into separate streams that converge in some new place, or if whatever H2O happens to be in it, assuming there is any, is replaced with chemicals from some upstream manufacturing plant, and many other changes, still be the Charles River. On the other hand, it wouldn't be a river at all if it was directed within fixed boundaries and was used for shipping freight, let's say. Then it would be a canal, not a river. Or if the surface were hardened by some virtually undetectable physical change, a line was painted down the middle, and it was used to commute downtown to Boston, highway. As we proceed, we find much more intricate properties. That's true no matter how simple the words we investigate. Commonplace facts like these completely undermine a conventional, almost universal approach to reference that's based on some word-object relation which is completely mystical. Insights about these matters were explored from Aristotle up through the British empiricists, but they've been mostly lost today. I think the proper conclusion is that even the most elementary human concepts appear to be entirely different from anything found, so far at least, in animal symbolic or communicative behavior, which is a significant problem for evolutionary biology, one of several in this connection. And the problems mount very rapidly when we move from simple words to expressions formed from them. I won't spend time on examples. What is known turns out to be extremely intricate and subtle and almost divorced from any evidence we have. Well, that poses one essential task of inquiry, namely to determine the principles on which such knowledge rests for the widest variety of possible human languages. And behind it is a deeper problem to discover what Huarte called the power to engender these principles of internal language. In current terms, that would mean the virtually uniform biological endowment that constitutes this particular cognitive faculty, the human language faculty. The power to engender an internal language, that's the topic of what's commonly now called universal grammar. That's adapting a traditional term to a new context. And it's in this context that a coherent and useful notion of universality in language arises. These would the universals of language would be the universal properties of the biological endowment, essentially the genetic component of the language faculty. One significant insight of the first cognitive revolution was that properties of the world that are informally called mental may involve unbounded capacities of a finite organ. It's the finite use of infinite means in Wilhelm von Humboldt's phrase. And in a rather similar vein, Hume before him had recognized that our moral judgments are unbounded in scope and must be founded on general principles, finite general principles that are part of our nature, although beyond what he called our original instincts. And that observation poses Quarte's problem in a different domain, and in fact is one of the thin threads that link the two topics that were announced today. By the mid-20th century, when all of this had been completely forgotten, it had become possible to reinvent and face those problems in a more substantive way than before. By that time, there was a clear understanding of finite generative systems with unbounded scope, and that could readily be adapted to reframing and investigating some of the traditional questions that had been necessarily left quite obscure before that understanding developed, although it's important to stress only some of the traditional questions. Von Humboldt, in the phrase I quoted and elsewhere, was talking about infinite use, which is quite a different matter from unbounded scope, and the same is true of the Cartesian science from which this flowed. Another influential factor in the renewal of the cognitive revolution was the work of ethologists, at that time, early 50s, just coming to be easily accessible, with its concern for what was called the innate working hypotheses present in subhuman organisms and the human a priori, which should have much the same character. That's Tinbergen and Lawrence. That framework, too, could be adapted to the study of human cognitive organs and their genetically determined nature, and those few of us who were interested in these topics were reading them avidly at the time. Meanwhile, kind of in parallel, pretty intensive efforts to sharpen and refine the procedural approaches of structural linguistics ran into serious difficulties, revealing what appeared to be intrinsic inadequacies. As you pursued it further, it became increasingly clear that even the simplest elements don't have a kind of a beads on a string character that's required for procedures of segmentation and classification to work. Rather, they relate much more indirectly to sound, to phonetic form. They do have properties and a nature, but their nature and properties are fixed by the role they play within an internal computational system that determines an unbounded range of expressions. And closer study of the postulated mechanisms of learning in the behavioral sciences generally also revealed fundamental inadequacies, and pretty soon questions were arising right within the core disciplines as to whether their concepts, even their major concepts, could be sustained. Well, a natural conclusion from all of this seemed to be that the internal language that's attained has roughly the character of a scientific theory, an idealized scientific theory, that is an integrated system of rules and principles from which the expressions of the language can be derived. And the child must somehow select the internal language from the flux of experience. The problem is similar to what Charles Sanders Peirce, founder of pragmatism, had called abduction, in his consideration of scientific discovery. And just as in the case of the sciences, the task is impossible without initial limitations on admissible hypotheses, as Peirce put it, initial limitations that permit only certain theories even to be entertained, but not infinitely many others that would be compatible with any relevant data. In the language case, it appeared that universal grammar must impose a format for rule systems that's highly articulated and specific to language and is sufficiently restrictive so that the candidate languages are kind of scattered, so that only a small number of them can even be considered in the course of language acquisition. Otherwise, it would be impossible. To quote from work of the 1960s, the most challenging theoretical problem in linguistics is that of discovering the principles of universal grammar which determine the choice of hypotheses, the initial conditions that say, here's the class you can even think of, the accessible internal languages. That's the major problem. At the same time, it was recognized that for language, as for other biological systems, there is a still more challenging problem, at least at the horizons, and that is, still quoting from the 60s, to discover the laws that determine possible successful mutation and the nature of complex organisms. Investigation of factors like those seemed too remote to merit much attention, but they were kind of in the background, even in some of the earliest work. For example, on, for those of you who are familiar with the field, the work on elimination of redundancy in rule systems back in the 50s, which was kind of implicitly guided by such concerns. And they do bear directly on universality in language, namely insofar as these factors, general organism-independent factors, enter into growth and development, less is attributed to universal grammar, to the genetically determined initial state. Well, by the early 1980s, a substantial shift in perspective within linguistics had reframed the questions quite considerably. It led to an abandonment, total abandonment of the format conception of linguistic theory in favor of an approach that sought to limit attainable languages literally to a finite set, apart from lexical choices. As a research program, that shift was highly successful. It led to an explosion of empirical inquiry into a wide range of typologically varied languages. A lot of new theoretical questions were posed that could scarcely have been formulated before. Sometimes they got at least partial answers. At the same time, this revitalized related areas of language acquisition and processing. Another consequence, relevant here, is that the shift removed some fundamental conceptual barriers to the serious inquiry into deeper principles in growth and development of language and beyond universal grammar. According to this conception that took over, acquisition of language is dissociated from the fixed principles of universal grammar, and it doesn't compel the conclusion that the format provided by universal grammar has to be highly articulated and specific to the language faculty so as to restrict the space of admissible hypotheses. Acquisition would simply be a matter of making some choices within a finite set, like answering a finite number of questions in a questionnaire, but the principles of language would be fixed independently of that and would always operate. Well, it had been recognized since the origins of modern biology, since Darwin's day, that general structural and developmental constraints enter into the growth of organisms and their evolution, as discussed by Thomas Huxley, for example. By now, such considerations have been adduced for a wide range of problems of development and evolution, ranging from cell division to optimization of structure and function of cortical networks and complex organisms, even humans. Well, assuming that language has the general properties of other biological systems, we should therefore be seeking three factors that enter into the growth of language in the individual. One of them is genetic factors, the topic of universal grammar. These factors for the infant interpret part of the environment reflexively as linguistic experience, which is non-trivial, and then determine the general course of the development of the languages attained. Second factor is experience, which permits variation within a restricted range. Third factor is principles that are not specific to the faculty of language, probably to the organism. This third factor for language, one would expect to include principles of efficient computation for computational systems. That's what you'd look for, determining the general character of attainable languages and probably much broader in scope. Well, at this point, you have to go on to more technical discussion than is possible here, and I won't try, but I think it's fair to say that there's been considerable progress in sharpening and moving towards principled explanation in terms of these third factor considerations. That considerably sharpens the question of the specific properties that determine the nature of language. With each step toward principled explanation in this sense, you gain a clearer grasp of the universals of language, but it's important to keep in mind that any such progress leaves completely unresolved the fundamental problems that have been raised for hundreds of years. Among these are the still quite mysterious problem of the ordinary creative and coherent use of language, which was a core problem for Cartesian science and the first cognitive revolution generally. Well, at this point, we're moving into domains of will and choice and judgment and the thin strands that may connect what seems within the range of scientific inquiry and essential problems of human life. In particular, the vexed questions about universal human rights. One possible way to connect the dots would be by proceeding along the lines of David Hume's remarks, which I mentioned earlier. His observation, again, that the unbounded range of moral judgments must be founded on finite general principles that are part of our nature, though they lie beyond our original instincts, which he took to include what he called the species of natural instincts on which all human knowledge and belief are grounded. In recent years, there's been intriguing work in moral philosophy and experimental cognitive science that carries these ideas forward, discovering and investigating what seem to be deep-seated moral intuitions that often have quite a surprising character, using simple invented cases. Liz has a lot more to say about this work than I do, so I'll drop it. But just to illustrate, I'll take a real example that in fact carries us right directly to universality of human rights. So this is a real one. In 1991, the chief economist of the World Bank wrote an internal memo on pollution, not intended for distribution. In the memo, he demonstrated that the World Bank should be, this is mostly quotes, the bank should be encouraging migration of polluting industries to the poorest countries. The reason is that measurement of the costs of health-impairing pollution depends on the foregone earnings from increased morbidity and mortality. So it's rational for health-impairing pollution to be sent to the poorest countries where mortality is higher and wages are lowest. And as he pointed out, other factors lead to the same conclusion. For example, the fact that what he called the aesthetic pollution concerns are more welfare enhancing among the rich. Like people like us care about them more than poor people. And as he pointed out, quite correctly, the logic is impeccable, and any moral reasons or social concerns that might be adduced could be turned around and used more or less effectively against every bank proposal for liberalization, so they can be dismissed as irrelevant. This is all quotes. The memo was leaked, and it elicited a storm of protest. Rather typical was Brazil's Secretary of the Environment, who wrote chief economist a letter saying that your reasoning is perfectly logical but totally insane. He was fired. The author of the memo went on to become Treasury Secretary under Clinton and later the president of the place down the street. What's relevant here is the virtual unanimity of the moral judgment that the reasoning is logical but insane. It's hard to find anyone who is willing to affirm the conclusion that does follow by impeccable logic, and that merits a closer look. It's one of these cases of very strong moral intuitions, and when we look at it, we get straight into the heart of the modern history of human rights doctrines. There is a standard codification of human rights in the modern period. It's the Universal Declaration, which was adopted in December 1948 by almost all nations, at least in principle. Contrary to what's often said, the Universal Declaration reflected a very broad cross-cultural consensus, participation from all over the place. And all of its components were taken to have equal status. That is, from what are sometimes called anti-torture rights to socioeconomic rights, such as the ones that are enumerated in Article 25, which I'll quote. Everyone has the right to a standard of living adequate for the health and well-being of himself and his family, including food, clothing, housing, and medical care and necessary social services, and the right to security in the event of unemployment, sickness, disability, widowhood, old age, or other lack of livelihood in circumstances beyond his control. These provisions have been reaffirmed in the enabling conventions of the General Assembly, which are intended to implement the stated rights, and also in international agreements on the right of development, usually in virtually the same words. Well, it seems reasonably clear that this formulation of universal human rights rejects the impeccable logic of the chief economist of the World Bank, if not as insane, at least as profoundly immoral, which was in fact the virtually universal judgment, at least insofar as it was publicly expressed. People thought, I don't know. Here, the word virtually must not be overlooked. It was a virtually universal judgment. As is well known, many nations are condemned as what are called relativists, who interpret the Universal Declaration selectively and reject components that they don't like. There's been a great deal of indignant rhetoric about what are called Asian relativists, or of course the unspeakable communists who descend to this degraded practice. For some reason less noticed is that the leader of the relativist camp happens to be the leader of the self-designated enlightened states, the world's most powerful state. We see examples of this almost daily, although see is perhaps the wrong word because we see them but manage not to notice them. So to illustrate, let's just go back 2 weeks ago to March 1st. On March 1st, there were lead stories in the press on the release of the State Department's annual report on human rights around the world. The spokesperson at the news conference unveiling the report was Paula Dobriansky, who's the Undersecretary of State for Global Affairs. And she emphasized, I'm quoting her, that promoting human rights is not just an element of our foreign policy, it is the bedrock of our policy and our foremost concern. That's as much as it was reported, but there's a little more to the story, as often the case. Dobriansky was Assistant Secretary of State for Human Rights and Human Affairs in the Reagan and Bush #1 administrations, and in that capacity, she sought to dispel what she called certain myths about human rights. The most salient is the myth that so-called economic and social rights constitute human rights. And she denounced the efforts to obfuscate human rights discourse by introducing these spurious rights, which are entrenched in the Universal Declaration, which in turn was formulated at U.S. initiative but is explicitly rejected by the U.S. government. Let me stress U.S. government. The population has sharply different opinions and attitudes, as we would expect when we look at universals of human rights and moral universals generally. And again, there's a very clear current illustration, which isn't being reported. Part of it was the federal budget was announced a couple of weeks ago, next year's federal budget, and along with it, there was released something that wasn't reported, namely a study of public reactions to the budget by the world's most prestigious institution for the study of public opinion, the program on policy attitudes at the University of Maryland. The public, turns out, calls for drastic cuts in military spending, sharply increased social spending for education, medical research, job training, conservation and renewable energy, increased spending for the United Nations and economic and humanitarian aid, and reversal of Bush's tax cuts for the wealthy. Government policy is dramatically the opposite in every respect, and there's very little discussion about that within the political system or the intellectual culture, the media, etc. There's a lot of concern these days, international concern here too, about the consequences of what are called the twin deficits that are expanding, the trade and budget deficits. Closely related to them is a third deficit, the growing democratic deficit. It's the term we use for others who have formal democratic institutions, but they don't function. And that's very little discussed because the democratic deficit is very much welcomed by wealth and power, which have every reason to want the public removed from policy choices and implementation, which should be a matter of considerable concern, quite apart from its relation to universal human rights. Well, in extenuation of Dobriansky, I should say that it's unfair to focus on her because her position is standard. UN Ambassador Jeane Kirkpatrick described the socioeconomic provisions of the Universal Declaration as a letter to Santa Claus. Neither nature, experience, nor probability informs these lists of entitlements, that's in quote, scare quotes, entitlements which are subject to no constraints except those of the mind and appetite of their authors. And the same view was expressed in 1990 by the U.S. representative to the UN Commission on Human Rights, Ambassador Morris Abram. He was explaining Washington's unilateral veto of the UN resolution on the right of development, which virtually repeated the socioeconomic provisions of the Universal Declaration. But these are not rights, Abram informed the Commission. They yield conclusions that seem preposterous. They are little more than an empty vessel into which vague hopes and inchoate expectations can be poured, and they're even a dangerous incitement. The fundamental error of the alleged right to development is that it presupposes Article 25 of the Universal Declaration and assumes that it actually means what it says and is not a mere letter to Santa Claus, and that's preposterous, clearly. So it would seem to follow, then, that we should affirm the impeccable logic of the Summers memo on pollution, though no one says so in public, perhaps because they would be regarded as insane. Well, this teaches us something about several topics. One of them is about universal moral judgment, and the other is about the moral and intellectual culture in which we live, which forcefully rejects universal moral judgments. There are innumerable other cases. I presume you noticed a couple of days ago at the appointment of John Bolton as ambassador to the UN that Condoleezza Rice praised Jeane Kirkpatrick as a model for what an ambassador should be, reiterating what I just said implicitly. Bolton himself has been clear and forthright in expressing his attitudes toward the UN. He said, "There is no United Nations. When the United States leads, the United Nations will follow. When it suits our interests to do so, we will do so. When it does not suit our interests, we will not do so." That position happens to be maybe a little bit extreme, but it's right about at the main bipartisan and educated consensus. But it happens to be opposed by an overwhelming majority of the public. In fact, public support for the UN is so strong that a majority of the public even think that the U.S. should give up the Security Council veto and accept majority decisions, which is an unspeakable notion in the intellectual culture. And the numbers are kind of interesting in all these cases because the people who express these views have never heard them. Each one must think I'm crazy, but that's what I think. If they were ever discussed, there'd be you can guess that the numbers, which are high, would be even higher. But again, the democratic deficit prevails, so we don't have to worry about universal moral judgments. The principle of universality arises in other important connections too. One instructive example has occupied the World Court for several years. After the 1999 NATO bombing of Serbia, a group of international lawyers presented the International Tribunal on Yugoslavia with charges against NATO. They were relying on documentation which was produced by the major human rights organizations and, in fact, admissions by the NATO command. The prosecutors refused to consider the matter in violation of tribunal rules, simply stating that they relied on NATO's good faith. They undoubtedly knew what would happen to them if they didn't. Yugoslavia, however, proceeded. It took the matter to the World Court, and the U.S. alone withdrew from the proceedings at the World Court. The reason was that Yugoslavia had invoked the Genocide Convention, which the U.S. had in fact signed after 40 years, but with a reservation that it does not apply to the United States, which therefore retains the unilateral right to carry out genocide. And the court correctly agreed with the U.S. argument, and the U.S. was excused alone. That's happened before, also in ways that are highly relevant today. As I'm sure you know, John Negroponte was recently appointed as the first director of intelligence. And like Bolton, he too has credentials. In the 1980s, during the first reign of the current incumbents in Washington, at that time he was the ambassador to Honduras, where he presided over the world's largest CIA station. That was not because of Honduras is so significant in world affairs, but it was because he was supervising the camps in which the U.S. terror army was trained and armed for its war against Nicaragua, which was no small matter. The country was virtually destroyed. Well, if Nicaragua had adopted our norms, what it would have done is respond by terror attacks within the United States in self-defense, in this case, authentic self-defense. But it didn't. Instead, Nicaragua pursued the peaceful means that are required by international law. It brought the U.S. attack to the World Court. Nicaragua's case was presented by a distinguished Harvard University lawyer, Professor Abe Chase. The court bent over backwards to accommodate Washington. It eliminated a large part of the case that Chase presented for an interesting reason. The reason was that when the United States had accepted World Court jurisdiction in 1946, it entered a reservation excluding the United States from any multilateral treaties, notably the UN Charter, which bans the unauthorized use of force as criminal, in fact, the supreme international crime in the words of the Nuremberg Tribunal, but of course only when others do it. The court, therefore, restricted itself to bilateral U.S.-Nicaragua treaties and customary international law, but even on those very narrow grounds, it charged Washington with, technical words, were unlawful use of force, which in lay terms just means international terrorism, ordered Washington to terminate the crimes and pay substantial reparations, which would go far beyond overcoming the debts that are strangling the country that were accrued during the U.S. terror war. The Security Council of the United Nations affirmed the World Court judgment in 2 resolutions vetoed by the United States, hence basically unreported and unknown. The U.S. immediately escalated the attack, leaving the country utterly wrecked, with a death toll that in per capita equivalent terms for us would be 2.5 million dead in the United States. That's more than all U.S. deaths in all wars in its history, including the Civil War. Nicaragua has so declined that 60% of children under 2 are suffering from severe malnutrition, probable permanent brain damage. All of this is so deep in the memory hole in the elite intellectual culture that it's scarcely known. If you want to see some examples, take the editorials in the Boston Globe in the last few days, which are puzzling about anti-American attitudes in Nicaragua after its failed revolution, failed for some unknown reason. There are several relevant conclusions from all of this. One is it's another illustration of Washington's self-exemption from international law, including humanitarian law, based on universal principles of human rights. This case, as many others, with very grim human consequences. And it also reveals, again, the self-exemption of the elite intellectual culture from responsibility for our crimes. It's a conclusion reinforced by the fact that Washington has just appointed a leading condemned international terrorist to the position of world's leading anti-terrorist czar. All of this is quite normal. Orwell wouldn't have known whether to laugh or weep. In fact, the U.S. has refused to ratify most of the enabling conventions that were passed by the General Assembly to implement the Universal Declaration, or more accurately, it's accepted none of them, to my knowledge, because the few cases that have been ratified are accompanied by reservations that exclude the United States, just like the Genocide Convention and others. That incidentally includes the anti-torture conventions that have stirred up a lot of recent debate. There's an important article in the matter of the Journal of the American Academy of Arts and Sciences by a distinguished constitutional law specialist, Sanford Levinson. He joined most others in condemning the Bush Justice Department, including the recently appointed Attorney General, for having articulated, I'm quoting Levinson, for having articulated a view of presidential authority that is all too close to the power that Schmitt was willing to accord his own Führer. He's referring to Carl Schmitt, who was the leading philosopher of law during the Nazi period, and whom Levinson describes as the true eminence grise of the Bush administration. Nevertheless, Levinson offers some defense of the Justice Department authorization of torture. He points out that when the Senate ratified the UN Convention against torture and other cruel, inhuman, and degrading treatment and punishment, quoting Levinson, it offered what one might call a more interrogator-friendly definition of torture than that adopted by the UN negotiators. And the unilateral US definition does go some way towards permitting the practices that have recently enraged the world and elicited much highly critical commentary here. Well, it's depressingly easy to continue, but I'll end with one last observation about the current scene. A few days ago, I gave a talk at the Hope Church in downtown Boston. It was a meeting called by Chris Paz to commemorate the 25th anniversary of the assassination of Archbishop Romero of El Salvador, a voice for the voiceless, as he was called, murdered by security forces backed by the United States, many of them graduates of the famous School for the Americas. Romero was assassinated while he was performing Mass, shortly after having sent President Carter an eloquent letter pleading with him not to send aid to the brutal military junta in El Salvador, which will sharpen the repression that has been unleashed against the people's organizations fighting to defend their most fundamental human rights. Well, that was ignored. state terror increased after the assassination, always with U.S. support. The hideous decade, not just there, ended with the murder of 6 leading Latin American intellectuals, Jesuit priests, by an elite U.S. armed and trained battalion that had already compiled a shocking record of atrocities, mostly the usual victims, peasants, working people, priests and lay workers, in fact anyone connected even loosely to the people's organizations fighting to defend their most fundamental human rights. CRISPAS was one of the first of the mostly church-based organizations that were formed after the Romero assassination to support those who are fighting to defend their most fundamental human rights. And they did it in ways that are really of historical significance. They broke entirely new paths in many centuries of Western violence. They did it by going to live with the victims, to help them, in the hope that a white face might protect them from the wrath of the U.S.-backed state terrorist forces. That's never happened before. I had the privilege that night, a couple days ago, of sharing the platform with Mirna Perla. She's a Salvadoran Supreme Court justice who's the widow of Herbert Anaya and is attempting to continue his work under terrible conditions. Anaya was the leading human rights activist in El Salvador. He was imprisoned and tortured by the U.S.-imposed government and then assassinated by the same hands that murdered the Archbishop and the leading Jesuit intellectuals, along with tens of thousands of the usual victims and comparable stories in the neighboring countries and elsewhere. Well, in a society that valued its freedom, it would be completely unnecessary to recount any of this because it would be taught in schools and it would be well known to everyone. And we would now be preparing to commemorate the 25th anniversary of the assassination of the Voice for the Voiceless, just as we would have commemorated a few months ago the 15th anniversary of the assassination of 6 leading intellectuals. If anything like that, remotely like that, had happened in Eastern Europe in those years, we would certainly know about it. And in fact, we would be reacting the same way right now to the continuing atrocities by the military forces armed and trained by Washington. For example, in Colombia, which has been the leading human rights violator in the hemisphere for many years, and throughout all that period has been the leading recipient of U.S. military aid and training. It happens to be a very well-established correlation, not insignificant. Again, it would be well known to everyone in a free society or a society that valued its freedom. Last year, Colombia apparently maintained its record of killing more labor activists than the rest of the world combined. A few weeks ago, the military broke into the most important of the towns that had declared themselves zones of peace, separating themselves from the conflict, they hoped. Military murdered one of its founders and others, including his children and others down to the age of 2. I happened to have met the murdered leader on a recent visit to Colombia. The meeting was arranged by Father Javier Giraldo, who heads the church-based Justice and Peace Center. He himself has been targeted for assassination, and he was withdrawn from the country under threat by the Jesuit order, although he insisted on returning to his work supporting those who are struggling to defend their fundamental human rights. Well, again, all of this should be too familiar even to mention, but fact is that little is known about it apart from circles of people like CRISPAS who are devoted to defending universal human rights. I mentioned these very few examples to remind ourselves that we're not engaged in seminars on abstract principles or discussing remote cultures that we do not comprehend. We're speaking of ourselves, the moral and intellectual values of the communities in which we live, and if we do not like what we see, if we look into the mirror honestly, we have ample opportunity to do something about it.
Since I'm not an expert either on linguistics or on human rights, and since we've just heard from a peerless expert on both of them, I am going to bet that you'll be happy to learn that I want to make my remarks brief and leave as much time as possible for questions for Professor Chomsky and discussion of these issues. Can you hear me okay? Is this working all right? Okay. What I do want to do, though, is say something about the word "and." At least, and try to link some of the developments in understanding universals in human nature to some of the developments in the move towards bringing about a greater balance in universals in human rights. Now, it seems to me that one striking feature about our species, actually in contrast to any other animal that I know of, is how different we are from one another. As you move from one place to another, you see that people speak different languages, that we dance to different kinds of music, that we produce and eat different kinds of food, participate in different kinds of economic and family arrangements, practice different religions, and so forth. The list can go on and on. But I think another equally striking feature of human beings is how seriously so many of us take these differences so much of the time. I think we can see this focus on human differences in many different ways, large and small. To take a small example very close to home, the absolute need of my adolescent children to wear the clothes and speak the language that exactly corresponded to the other people in their social group. To go to the complete opposite extreme, the history of wars and ethnic conflicts in which people are literally willing to lay down their lives for a total stranger who happens to share their language or religion or a piece of cultural territory so as to fight other perfect strangers who don't. I also think that we can see this focus on human differences in some of the callousness and neglect in the discussions of Nicaragua and of torture and so forth that we just heard about. Of course, Professor Chomsky has been at pains to show how public media and public government will manipulate the discussion of events that take place in the world in a way that leads us to focus our attention away from the issues that he was describing today. But I think one of the things that makes it easier for the media and for governments to do this is that there's a side of our nature that does tend to focus on differences and can more readily think, for example, of victims of torture who speak some other language and live in some other part of the world as somehow not being as immediate a concern to us as actions that happened, say, to a neighbor who was superficially more like us. Well, I think that perhaps the greatest contribution of modern linguistics, as led by Chomsky in the second cognitive revolution, is the insight that these human differences are far more apparent than they are real. Beneath the surface variability in human languages are deep commonalities. Common underlying principles have to be there because children have to be able to learn any of the world's languages depending on where they happen to be born. And as a matter of fact, they learn these languages very rapidly with no instruction and from rather minimal and fragmentary evidence. Now, throughout his work, Chomsky suggested that this same point applies to other of the variable systems of cultures. Things like the music of a culture or its belief systems or its moral rules might be understandable within the same kind of framework. Underneath all the surface variability, there may be common principles that make it possible for a child to grow up to be a competent member of any human society in all of these other respects. Now, I think that research over the last 30 years very strongly supports Chomsky's suggestion. And because I don't want to take a lot of time, I just want to cite 3 examples of work that's gone on, both in cross-cultural psychology, looking at variability and underlying principles in beliefs across cultures, and in cognitive development, and also in studies of adult reasoners in our culture. First of all, there's evidence that humans universally tend to structure the world in terms of objects, that is, cohesive bodies that move continuously through space and over time and interact with each other only on contact, contrary actually to suggestions by Quine, who Chomsky already mentioned. There's evidence that all over the world people divide up experience into objects and reason about events in terms of objects. Now, this focus on objects is evident already in human infants. Research done just this year by Francesca Simeoni in Italy shows that newborn infants, 1 day old, already are predisposed to take what visual scenes they see around them and organize them into objects. This predisposition continues to exist throughout human development, and it provides a foundation for our intuitive reasoning about the inanimate material world. The second example is that humans have a universal capacity to represent number. Now, our universal number representations are imprecise, but they allow us to compare numbers and even to perform arithmetic on approximate numbers. This has been shown, I think, most elegantly in some recent studies by the French cognitive neuroscientist Stanislas Dehaene, who conducted experiments on members of a remote Amazon tribe whose language contained no words for exact numbers beyond 2 or 3, and no explicit counting routine. He was able to show that despite the lack of these resources, these people were sensitive to approximate numbers and could mentally add and compare them and manipulate them in ways indistinguishable from, say, educated people also studied in France. Now, these number representations also emerge in human infancy, as work in my lab and many others have shown. They continue to exist in us as adults, and they provide a foundation for the acquisition of verbal counting and symbolic arithmetic. The third example, which Professor Chomsky already alluded to, humans have a universal capacity to represent people as intentional, goal-directed agents whose freely chosen actions are subject to moral evaluation. Now, research by John McHale and Mark Hauser have been looking at the moral intuitions of people across a wide range of different cultures. I'm actually not going to go into their findings, so if people are really interested, we could talk about it in the question period. Suffice it to say that people have quite rich and intricate and converging intuitions about situations that we've never faced or considered before or learned anything by rote about in our ordinary lives. And I think this testifies to the kind of capacity for unbounded judgments that Dr. Chomsky was talking about. I do want to mention one study, though, by Emmanuel Dupuy and Pierre Jacob in Paris, which suggests that this tendency to evaluate the actions of other people may trace all the way back to infancy. This is new work, so I'll actually tell you about one of their experiments. It was conducted with very young infants, I think about 10 months old, who were presented with videotaped vignettes in which people came out, 2 different people came out and engaged in exactly the same set of motor movements. Both people came out and looked fiercely at the camera and then shook a fist and then struck at something. What differed across the 2 clips was what the something was that the people struck at. One of the 2 people struck at another person, a young girl who fell to the ground. The other person struck at this is all simulated, the other person struck at a backpack, which fell to the ground. And then the infants were shown, the 2 people again, smiling nicely and innocently, approaching the baby and making social overtures to see how babies would react. Well, babies had a very clear, reliable preference between these 2 people. They stayed away from the guy who pushed the little girl. They actually looked at that person longer, suspiciously, and interacted much more readily, taking a toy, for example, from the person who hit the backpack. It's very early days for this kind of research, but I think it converges with the cross-cultural studies suggesting that the reason we see universality in moral evaluations of actions across widely divergent cultures in adults may well be because there is a system of knowledge that's emerging early in development that we're all equipped with that allows us to grow up in any of these cultures and express this moral system in different ways. Well, given these universal systems, I think we next have to ask, where does human variability come from? Why don't we all speak the same language and listen to the same music and live in exactly the same kinds of family arrangements and so forth? Well, I think part of this variability comes from another universal human capacity, which is our capacity to combine together distinct core concepts freely and productively. To give you a couple examples to give a feel for this phenomenon, I think it's very likely that tool use develops from an ability to combine together representations of objects as mechanical bodies with representations of goal-directed actions, so that you can come to see an object as, at one and the same time, a material body that participates in a set of human-determined intentions. Similarly, exact natural number representations may result from our capacity to combine representations of numerically distinct individual objects, precise representations of small numbers of objects, with the large approximate number representations that I was talking about a minute ago. Now, some of the research that I've done and that some other people have done suggests that this combinatorial capacity may be tied to natural language. That's a controversial suggestion. It may turn out to be wrong. What I think is clear is that this capacity is unique to humans and it's universal across humans, and it may be at the root of many of the diverse variable systems that we see in different human societies. Well, if all of this is true, that is, if we're all equipped with a common stock of core knowledge systems and a common capacity to freely combine concepts from different core systems together, then it would seem that humans might be gripped by a tremendous illusion. The illusion that different members of different groups really are fundamentally different from one another. And as I was saying before, I think this illusion may be one of the forces, certainly not the only one, but one of the forces that has led in the past to wars and social divisions, that feeds ethnic conflicts today, that may inure us in some cases to reports of torture and human rights violations that take place in foreign lands. Now, this illusion of fundamental human differences may have two different sources. These are not mutually exclusive. They could both be at work. First, as the psychologist Larry Hirschfeld has suggested, it may partly be learned by a pattern of false induction from other kinds of categories. So, for example, Hirschfeld has suggested that children may learn that when two animals, for example, look very different and behave in very different ways, they're very likely to be members of different species. And from that, they may overgeneralize this learning to the human case. But a second possible contributor to this illusion could be a predisposition that's actually present in us as humans at an early age. And we don't have a lot of evidence that this is true, but I think we're starting to see some tiny hints that it might be true. Let me tell you about just one new experiment by my student, Katie Kinsler at Harvard, which has looked at how infants react to people who speak different languages. What she did in this study, she took quite young infants, 6-month-olds, who aren't yet talking or understanding much of anything that's being said to them, and she presented them with two people who were in fact Spanish-English bilingual speakers, but for any given infant, one of these two people spoke to the infant in English and the other spoke to the infant in Spanish. Then the two people were presented side by side, very much like the Dupuy and Jacob study I told you about, and they try to engage the child, and you look at how the child reacts. Now, in this sample of children, they all came from families where the language spoken at home was English. What she found was a real difference in their orientation to these two people. Even though, unlike the Jacob studies, the people weren't doing anything objectively different, the kids were oriented more positively toward the person who had previously spoken to them in English than toward the person who had previously spoken to them in Spanish. It's really too soon to draw large conclusions from this, but I think it at least begins to suggest that early in development, children may already be using some of these superficial differences between people, like the sound pattern of their native language, as indicators of group membership. We could be seeing here, I think, the beginnings of tendencies to categorize people as us versus them. Well, if there's anything to these speculations, I think they suggest that two aspects of human nature may pose a challenge for us, both for our future and for the enterprise of extending human rights around the world. One is our surface variability, and the other is our tendency to take this surface variability much too seriously and infer falsely from it that the variability runs deep. But I think a third aspect of our human nature is actually the most fundamental at all and holds the potential key to a remedy to this problem. That is the combinatorial capacity that allows us to articulate deeply entrenched notions and criticize them and get beyond them. Now, we see this capacity at work in the history of science in a case that Chomsky has discussed a lot in other contexts, though he didn't mention it today, in the development, changing notions of bodies with the revolution in Newtonian mechanics. Now, the core conception of objects that we find in infants and that we find in intuitive thinking all around the world centers on, among other things, a constraint that objects can act on each other only on contact. But of course, as we all know in the history of science, that turned out not to provide a very workable description of object motion, either on Earth or in astronomy. And what happened is that by combining other core concepts together, particularly concepts of space and number, Newton was able to come up with a better account of object mechanics that clashes with the core conception that we hold, but that nevertheless was able to serve as a foundation for the further development of science and technology, and did so for centuries until, of course, that theory was replaced by even more counterintuitive notions of bodies. Now, I think in the case of human rights, a similar process may be evident. We have the capacity to recognize that our notions of human differences are wrong. And the dawning recognition of human universals, I think, can already be seen in the history of the human rights movement, from the very early days where it was confined to relatively narrow circles of people through the progressive extensions to the current Universal Declaration of Human Rights, which applies to everyone. However this notion clashes with entrenched beliefs, it has been articulated and it can be implemented. Of course, societies whose laws and practices violate this principle are far more common today, as Professor Chomsky's examples illustrate, than societies whose technologies violate Newtonian or quantum mechanics. And I think it's important to ask why it might be that insights in this domain are so much harder to grasp and put into action than are new insights in the domain of physics. Now, in part, I think this may well be because of the manipulative effects of government and media that Chomsky has so well described. But in part, I think it also may be because reasoning about other people engages our emotions in a way that reasoning about apples and bricks does not. And that can make the task of overcoming core conceptions more difficult. Finally, in part, I think it may just be because cognitive science is less developed as a discipline than physics is. And the work I was talking about today has, for the most part, not entirely, but for the most part, a much shorter history than the history of insights in physics. In any case, I think that one challenge that we face now as a species is to see our universal human nature through its variable manifestations, and then to craft political institutions that build on this insight. And to end with the word "and" again, I actually think that both the disciplines of linguistics and of human rights are giving us our best starting points here.
So I guess my question is directed to both of you. Thank you very much. I'm actually a philosophy person here, writing on human rights, and you've both confirmed and sort of problematized some things that I've been sort of curious about. One, we talked, Professor Chomsky, your talk, you direct us to make this sort of anti-behavioral move in linguistics, and I think you sort of hint at how we might do so in the political realm, pointing to examples and the sort of influences that lead to different judgments. And we also point to sort of the similarities we have, genetically, with the studies looking at little babies and stuff, and perhaps what you would call the combinatorial capacity. Philosophy we might call practical reason, or something like that, as sort of the basis of our difference and potentially our ability to overcome those differences. But here's another question. In a group of adults, all raised in the same country, mostly exposed to the same influences growing up, in terms of cultural influences, why is such a divergent set of moral appraisals between government elites and people not in government? What's the contribution of that particular institution to this sort of, that sort of is able to overcome what would normally you would think would be very deep-seated moral intuitions?
Me? Or you? Well, first of all, I don't think we have to look very far. It's true of all of us. I mean, the examples I was giving, I purposely gave because they illustrate the educated culture in which we are all part, which is not very far from government elites, or in fact, they're right from here, and many of them people we know, or the media. It's all this it's an intellectual, moral culture that we're all part of, like Harvard Square is right at the core of it. So if we think about it, we can answer the question by looking in the mirror. And I think the answer we find is that when you begin to play an institutional role of some kind, you can only do it, there's only two approaches you can take. One is to just recognize that the institution is inherently immoral and has to be significantly changed, in which case you're out. Or else you somehow stay within it, accommodate to it, begin to internalize its values, and no matter how they conflict with your own, and you live these joint lives. It's true in just about, I think it's hard to find a counterexample. We can find it in our own lives, we find it in governments, we find it in corporations, anywhere we look. You have this is your choice. Will I resist and try to change the structure of the institution if I recognize in one part of my moral capacities that it's wrong, repressive, murderous, and so on, or will I simply accommodate to it in one fashion or another? And there are a lot of ways to do that. One of them is to convince yourself, almost always falsely, that actually you're doing good by doing wrong. That's why when you look at the history of leadership, articulate leadership, you find that everything they do is noble. It's hard to find an exception. Try to find a historical exception, even among the worst monsters, Hitler, Stalin, pick your choice. Everything they did was noble. And there's very good reason to think that they believed it. Because we see, when you look at documentary records, that they talk to each other the same way they talk in public. So you kind of internalize it. So yeah, it's moral. So when Japanese fascists, let's say, were, and there we happen to have extensive records because defeated countries, so therefore you get their archives. I wrote an article about it 40 years ago if you're interested, and the records came out. But the Japanese fascists who were carrying out the most horrendous atrocities in Manchuria and North China were convinced and talked to each other privately about how they were carrying out a noble endeavor, trying to create an earthly paradise for the people of the region, led by Japan's generous and humane concern, and they had to protect them from the Chinese bandits who were trying to destroy the legitimate governments, and it was so hard, and they were suffering so much and trying to do all these wonderful things and so on. You just compare that with the actions, and what you find is that they're very much like us, because we do exactly the same thing, for example, in the cases that I mentioned. And I think the mechanisms are probably about the same, and I think if we think about it, we see them in our own lives.
Other questions?
Hello, I'm from the school up the street. I just came back from El Salvador, and something that I kind of got challenged with, and I want to challenge this a little bit. I am very quick to point the finger at the U.S. military and the U.S. media, and one woman who is my age and lived through the war just looked at me and she's like, you could have taught us whatever you wanted to teach us, but we pointed at each other and killed each other. And so what challenged me was, what is it that shifts perception of humanity to non-humanity? How do people completely dehumanize each other when they're neighbors? And how do we separate this pointing fingers from what is human nature and whether it is human nature, and then how to move forward within that paradox?
Maybe Elizabeth, but I would only say one word, and then I'll suggest that you talk about it, and that is that I don't think it makes a lot of sense to point fingers unless we're pointing them to ourselves. That's where we should start, at least. It's very easy to criticize other people for all the terrible things they do, but anyone who's honest will begin by saying, well, what am I doing? And if we look, turns out it's not so pretty. So just to take one totally different example, everyone is very much exercised about the horrendous atrocities in Rwanda, right? For 100 days, they were killing about 8,000 people a day, roughly, maybe 800,000 people, and we didn't do anything about it, and isn't that awful? Well, in fact, there's a lot more to the story. I mean, I myself was writing about those atrocities in the 1970s because they were going on, not at the scale of 1994, but very serious. Something could have been done about it, and something was done about it. One of the things that was done was that the international institutions, World Bank, IMF, and others, imposed structural adjustment programs, which in fact exacerbated the conflicts. Just as they had originally been almost created by Belgian and German imperialism, and then they were exacerbated by the social and economic policies that were imposed, and they finally blew up to some horrendous scale. Well, the problem of using military force in Rwanda, or anywhere, in fact, is very tricky. Military force has unpredictable consequences. I mean, you really have to have strong reason to do it, the big, heavy burden of proof to bear. But there are many things very much like it that are easy to do and that we don't do, although we know about them. Like, for example, right now, there is Rwanda-level killing going on among just children in southern Africa every day. About 8,000 are dying from easily treatable diseases, with something which we could deal with, not by military intervention, but just by a few cents. In rich countries, it wouldn't even notice it. But we prefer not to look at that because there would be a marginal inconvenience. So we therefore go see Hotel Rwanda and talk about how awful they are. Well, yeah, they were pretty awful, but we don't have to look very far to find similar things.
You talk about human nature. I mean, I think actually there are two sides to human nature that are relevant here. One, which your remarks point to, is we are frighteningly flexible in our abilities to draw lines around people and consider some people as truly deserving within some circle and other people as totally outside. And in case after case, governments can play on our tendency, our ability to do that and manipulate it, okay? But another aspect of human nature is that we can study ourselves and we can criticize our own notions and we can rise above that. And I mean, I think we see this has happened in the history of science, and that we can be optimistic that it can happen here, particularly given that the evidence shows that insofar as this tendency to draw lines and segregate out people from each other is thought to have some rational or factual basis, the science says that that's not true, that there is no important distinction between any person on this planet and any other that merits the kinds of distinctions that have been drawn and the conflicts that they've led to. So it's the other side of human nature that can examine these questions and critically that I hope we can rely on to address this problem.
We can take one last question. Unfortunately, we'll have to end sharply at 6:30 because of other commitments after the event. We'll take one last question.
How you doing, Professor Chomsky? My question to you, it's a question that I find myself faced with people who particularly have a military background or are very patriotic to our country and our cause. It's that when having dialogue and trying to talk about things that you readily talk about or just the facts like all around the world and things like that, people will say, well, if the corporations in our country don't have power and the money's not concentrated in our country and we don't have the strongest military power and we don't do what we're doing, someone else is going to get the power, and then are they going to be any better than we are? And then they're going to use their power to then exploit people, violate human rights and so forth. And that, well, as bad as the United States is, they settle in a way and say that, okay, well, at least we're not too bad. Look at other people who are we're not killing our own people and this and that. Maybe they would. And responding to those people, I find it's like, well, I don't know what would happen if they had the power. I mean, other places have had the power and they have exploited that power and hurt a lot of people. So trying to accurately, how would you respond to that question? Like, what would you do if we didn't have the power? And the fact that as we go to become more and more egalitarian, like if the people of our country actually exercise democracy, we're educated and they exercise democracy, and the world in the next, say, 10 to 15 years started to move towards more social equality. How would we couple that and protect ourselves, essentially is the question, from a power, a dictator, or any force that could violate human rights on a mass scale? Mm-hmm. How do those two, how can they fit well together?
I mean, first of all, the initial assumptions are, I don't think most people would accept, that we have to keep on torturing and killing people because if we don't, they might torture and kill somebody. Well, I mean, Hitler could have given that argument, so we don't want that one. But I think the basic question you ask is a good one. How can we, if we were to withdraw our own beating people over the heads with clubs, would it necessarily follow that somebody else would take that role, or are there other alternatives? Oh yeah, there are other alternatives. For example, the alternatives that are favored by the overwhelming majority of the population in the United States. I mentioned one piece of it. Let the UN function. The UN isn't perfect. There's a lot of things wrong with it. Just like the Universal Declaration of Human Rights isn't perfect. A lot of things wrong with it. But one step would be to pay some respect to the decent opinion of mankind, to quote the famous author, and let international institutions function so as to reduce the likelihood that anybody will use force. After all, remember the UN Charter in 1945, which unfortunately most people don't know, just like they don't know the Universal Declaration of Human Rights. It was formed. It starts off by saying that the goal is to save the human species from the curse of war, which twice in their generation had led to vast destruction. and which, as everyone knew in 1945, was, if it went on, was going to kill everybody, because this was right after the atom bombs. It's interesting that everyone knew that, but nobody could say it because of U.S. power. So if you look at the charter, long charter, there's a lot about the curse of war, but the words nuclear or any one like them don't appear. But that was what was on everyone's mind. We're at the point where we have now developed a technology that can destroy the world. Okay, so therefore we have to save ourselves from the curse of war, and institutions were constructed to try to overcome just what you're pointing to. The core principles of the UN Charter are that the use of force is illegal, it's criminal. It's the supreme international crime from which all other crimes follow, unless it is used under extremely narrow conditions. One condition is authorization of the Security Council. Okay, you can ask whether that's the right way to do it or not, but it's at least some step towards the right way to do it. The only other condition was if a country is under attack, then you can use force in self-defense. Now, let's come back to ourselves today. In the United States, the elite intellectual culture, the one we're part of, flatly rejects that and says that the United States and alone, maybe we can delegate it to our clients, but essentially the United States alone has the right of what's called anticipatory self-defense, meaning we attack anyone we want because we claim that maybe they'll be a threat to us someday. That's flatly in violation of the Charter. It's the bipartisan consensus. It's the media consensus. It's the elite intellectual consensus. Not 100%, but overwhelmingly. And then people just argue about, well, is this or that the right place to do it? But and of course, nobody else is allowed to have that right. I mean, that's outlandish. Like that Nicaragua, say, would have had the right to carry out terror in the United States in legitimate self-defense is unthinkable. But we have that right just for ourselves. We can delegate it to clients. But I'll say the same thing I said before. The overwhelming majority of the population rejects that. You take a look at the unpublished, almost always unpublished, major studies of public opinion. These, in fact, were released right before the election, when they were crucially important for a democratic society, but suppressed, show that large majority of the public accepts the basic principles of the UN Charter against the use of force. And if we're in a better position to implement those principles than anyone else, because we're way more powerful than anyone else. So if we join the rest of the world in trying to implement those principles, then there's hope that no other power will take the place that the powerful states now have, us in particular. And there are many examples of this. I'll just take another example from last November, which also didn't get reported, and we should ask why. There is a fissile material cutoff treaty. It's a international treaty that tries to prevent there are technically, treaties blocking it, but this one would put some enforcement procedures into preventing the development of materials for nuclear weapons. Okay? You read on the front pages of the New York Times this morning, lead story, the U.S. wants to prevent its enemies, like Iran, from even getting the rights they now have with regard to making these materials. But there is on the agenda a much broader one, which tries to prevent, to cut off the production of material which can be used for nuclear weapons, which are very likely to destroy us all. Well, it's been negotiated for years internationally. It came to a vote at the what amounts to the General Assembly, Disarmament Commission of the General Assembly. It's the whole General Assembly. It came to a vote last November, and the vote was 147 to 1 with 2 abstentions. 147 to 1 is very typical of international votes, not this administration, going way back. Or maybe 150 to 2 or something like that, because the U.S. does insist upon rights that it denies to everyone else. like the right to use force, the right to commit genocide, and so on and so forth. In this case, the United States voted against, it was the only country to vote against the measures to enforce the restriction on production of weapons, of material for nuclear weapons, which is likely to destroy us all. Well, what about the two states that abstained? One of them abstains reflexively. Israel has to abstain because it's relying on the United States for whatever it's doing, so that's reflexive. The other one is a second client state, Britain. And Britain abstained, which it usually does, in fact, abstained on the Security Council resolutions on Nicaragua too, and many others. And in fact, the British representative, if you look at the General Assembly proceedings, explained why he had to abstain. He said, we're very much in favor of this treaty, and we're going to work really hard to get enforcement procedures and so on. But the particular proposal that was voted on, he said, is divisive, which is true. It divided the world 147-1. So therefore, he had to abstain. Well, these things are under our control. We could change all those policies, and the overwhelming majority of the population doesn't want to change. But in order to change them, we have to do something about it. And that's in direct reaction to your question. We do not want, nobody sane wants any country to be developing the kinds of weaponry which will destroy all of us. And one way to prevent that is by putting enforcement mechanisms into the vague treaties that bar it. But the U.S. won't allow that, and it is allowed to get away with it because nobody in the country knows it. I bet if you do a poll at, say, Harvard Faculty Club or wherever educated people are, unless it's somebody who's involved in, disarmament programs, nobody will have ever heard of this. And it's like a death sentence, and it happens all the time. Well, let me start with a couple of words about my favorite century, the 17th century. The famous philosopher, historian of philosophy and science, Alfred North Whitehead, once wrote that for the last several centuries we've been living off the accumulated capital of the scientific genius of the 17th century, which is not much of a distortion. It's pretty much true. In the natural sciences, it's very largely true. In our fields, psychology, linguistics, philosophy, it's much less true, much to their detriment, I think. There was part of the scientific revolution of the 17th century was a cognitive revolution, which was extremely important and developed many of the ideas that were rediscovered without knowledge of their antecedents in what's called the cognitive revolution, should be called the second cognitive revolution of the 1950s, which led to cognitive science, linguistics, related areas, philosophy of language and mind in the sense that we know them today. And in fact, much of that work is still unknown and I think underappreciated. So to take a simple elementary example, one of the notions that plays a fundamental role in studies of acquisition of language or nature of language is what's called poverty of the stimulus. And there's a huge debate about whether it exists, what is it some weird thing about language or something like that. In fact, all of this is a total misunderstanding, for which I admit some guilt. I used the term, probably invented the term, talking about language, but it's a general property of all growth, and that's well known and understood outside the studies of the mind, of cognition, where it's supposed to be something special. So it's taken for granted, for example, no one even bothers to mention it, that the growth of an embryo to a mature, whatever it is a striking illustration of extreme poverty of stimulus. The stimulus from the point of view of the embryo is whatever the nutritional and other environment is, and it's perfectly obvious, and no one bothers to talk about it, that the embryo doesn't become a
person or a chicken or whatever because of the nutritional environment, which is far too impoverished to yield that consequence. So it's simply taken for granted without discussion that results from some internal property of the embryo, what we would now regard as, in part at least, its genetic endowment, plus other factors that enter into morphogenesis and growth and so on. It's only in the studies of the mental aspects of the world that that's considered a strange and debatable thesis, as if they are somehow out of the organic world. Odd kind of dualism that's characteristic of contemporary thought, and particularly the part of it that regards itself as highly scientific. In the 17th century, this was all quite clear. So the classic study of poverty of stimulus in the cognitive domain was Descartes' discussion of how an infant or an adult perceiving something, no great distinction was made between growth and perception, and they are very similar. How in either case the infant or the adult sees what they do. His simple example that he used was a triangle. So suppose I were to draw a triangle on the board over there. What you would actually do, Descartes argued, these are incidentally thought experiments, like most of the 17th century experiments, Galileo's and others. But if anyone were to carry them out, this is what would happen. If you were to look at that thing I drew on the board, your eye would scan it. So there'd be a sequence of impressions on your retina, a sequence of stimuli on your retina. But you don't perceive a sequence of stimuli as you sort of scan the figure in some fashion. What you can perceive is a triangle. And in fact, what you perceive is a distorted triangle, if you look carefully. You don't see a perfect example of whatever it is, which obviously isn't going to be a triangle, but you see it as a triangle somewhat distorted, like maybe one of the lines is curved and two of them don't quite come together, or one of them sticks out a little beyond the other, and so on. That's just your immediate perception. Your instantaneous immediate perception is a distorted triangle. It shows the vast extent of poverty of the stimulus. The stimulus on your retina is just a sequence of stimulations. Descartes thought pressures, but we look at it differently, but same thing. And he argued that the same would be true of an infant. So he suggested that when first in infancy an infant is exposed to, say, that figure, the infant will perceive a distorted triangle, not a sequence of stimuli as the eye scans it, and not a perfect example of whatever distorted figure it is. As far as I know, no one's ever carried out that experiment, but it would almost certainly work that way. The infant does this because of some internal structure that determines that that's the way you perceive geometrical figures. And Descartes and others went on to argue that that's exactly the same if you look at more complex things, like, say, something that you see as, say, that I see here as people sitting in the room. Actually, what I see is something far more impoverished than that, but I do perceive it as people sitting in the room, or men walking down a street, or something like that. It all must come from internal resources. In the case of the triangle, Descartes argued the mind is just constructed so that it generates geometrical figures, pure geometrical figures, and anything else, and it uses those as a kind of a paradigm with which to interpret whatever scattered stimuli actually reach the retina. By now, the last couple of decades, there's the beginning of understanding of the neurophysiological mechanisms that yield these consequences, beginning with the work of Hubel and Wiesel about 45 years ago and others since. But it's still rudimentary understanding, but there's very little doubt that that would happen. Well, that's dramatic and clear and unexceptionable illustration of poverty of stimulus in the visual domain. The other major domain that was investigated in the first cognitive revolution, much as in the second, the one in the 1950s, was language. Those were the two major topics studied then, and they're the two major topics studied now. Some others, but that's the mass of the work. Partly because of accessibility of the materials. In the case of language, what was taken for assumed, and sort of again thought experiments, but seems obvious, is that the basic elements of language, say concepts or words, if there's any difference between them, those must be primarily generated internally. Their complexity and richness is such that they can't possibly be acquired from experience. They were what were called common notions or innate ideas formed by some internal generative process that's structured in some fashion. And there was a good deal of research into, or at least thought about how this is done, suggesting that what's involved is Gestalt, what are now called Gestalt properties, notions of causal relation, notions of agency, anthropomorphic perspectives, all familiar about the way we perceive and think about the natural world. So you see, you talk about a comet as aiming towards the Earth and fortunately missing it, as if it had agency and intention. And the sun rises in the morning. We don't talk about the Earth setting in the morning and so on. That's true of just about everything we talk about, no matter how simple it is. And the properties of the concepts we use are the same, but they can't be coming from the stimuli of the external world. And in fact, as far as we know, there are significant differences among organisms in how they perceive the world and what ethologists called their Umwelt, the world of experience that in which they live will be different for different organisms, different for us and for bees, let's say. Not because the stimuli are different, but because they're differently constructed internally. These the investigations recognize that there have to be both what were at that time called innate ideas or common notions, fixed, universal concepts that are just part of our nature that provide a framework for interpretation, understanding, and so on, but also principles, generative principles of some kind, like the principles that form geometrical figures, which yield the internal symbolic constructions that permit us to express our thoughts using the atomic elements that are given by nature, basic atomic elements. And in fact, the linguistic research of the period did pursue those two lines of inquiry. What's the nature of the concept? What's the nature of the universal principles by which expressions are constructed as modes of expression of thought, sometimes externalized, mostly just in your head when you're talking to yourself. By far statistically speaking, by far the greatest use of language, as you can determine by introspection. A lot of interesting work was done in both of those domains. I won't try to review it. A lot of it is still far from having been reached in many of its details in contemporary work. That's particularly true of the study of concepts, which today is much more impoverished than it was in the 17th century, 17th, 18th century. It was recognized at that time that our most elementary concepts or words don't pick out identifiable things in the world. They don't pick out mind-independent objects. Actually, that insight goes back to Aristotle, Aristotle's example was a house. He said a house is, in his terminology, a house has both matter and form. The matter of the house is bricks, wood, whatever it's constructed of, and that's mind independent. The form of the house is its function, its design, the fact that people live in it or store things in it and so on. And the house itself is a combination of matter and form. So it has both material constitution and design and function. And when Aristotle defines house, he says you define a house as a combination of matter and form. Now, actually, it's important to recognize that the tradition from Aristotle up to the 17th century, and in fact revived in the contemporary period, is to talk about this metaphysically. You're defining a house, not the word house, not the concept house. So he's defining the thing house, one of those things in the world, which, and matter and form were both regarded as part of the world, metaphysical. That approach yields hopeless dilemmas and conundrums. Those of you who've taken philosophy courses will have run into examples of them, like the famous Ship of Theseus, or modern examples, Saul Kripke's Puzzles of Belief. You can run through them if you like, but they run these take off on our concept of city or ship and so on, and show that if you regard them as mind independent, you run into impossible, unsolvable paradoxes. That's taken to be a big problem all the way through from classical philosophy up to the 17th century, and again in the last 40 years. That's regarded as some kind of major puzzle. The 17th century, however, looked at it differently. There was a cognitive revolution, remember, so there's a reinterpretation of the metaphysical approach to an epistemological or cognitive approach. So you're not trying to define house or ship or London or something like that. You're trying to define the concept. And if you discover that the concept doesn't apply in all possible situations, as it doesn't, that's fine. There's no reason why it should. Concepts are not built into us to deal with imaginary situations that we can construct. So yes, they don't apply clearly in all situations. There's no conundrum, no paradox, just the problem of discovering what our conceptual structures are. And that's a very productive and accurate way of looking at it. It's not the standard way today, and it wasn't the standard way prior to the 17th century, but it should be the right way. And if we think about concepts and words a little, it becomes pretty obvious that that must be true. The word house is not a bad example. In fact, if you look at it more carefully, defining it in the word house in terms of matter and form is nowhere near sufficient. Our understanding of what a house is far richer than that. So, for example, if I say, I painted my house brown, you understand me to mean that I painted the exterior surface brown. I can tell you that I painted the interior surface brown, but I have to do it in a more complicated way. I have to say I painted my house brown on the inside. Okay, then you know I meant the inside. That's what's called a marked expression. So if I say I climbed the mountain, you interpret me as saying I went up. But I can say I climbed down the mountain. Okay, then I went down. And house is the same. The exterior surface is kind of unmarked. That's what you take the house to be. You can, with more complexity, identify the interior surface. But a house is not just an exterior surface. It can't be. If it were, it would be a geometrical object. And you couldn't, and if you were, let's say, 5 feet away from the surface on the inside, you would be near the house, but you're not. You're in the house. If you're 5 feet from it on the outside, you're near the house. And it doesn't have anything to do with its being contained. Same's true of, say, a lean-to, which kind of goes like this, or even a straight wall, depending on whether you live on one side or the other. You're near it if you're in the part that's intended to be, that's outside the part that's intended to be inhabited, you're inside it if you're the other one. So and you can go on and on like this. Think through, you'll find many more complicated aspects to the notion. And it's true of any notion. A house may be a little bit misleading because it's an artifact, and one might think that artifacts have those special properties. But the same is true of the simplest words that aren't artifacts. So it takes another word that was studied in the 17th century, first by Thomas Hobbes. Take, say, the Charles River, which somewhere around there, I don't know where exactly. The Charles River we call a river. But if you think about it a little, you can, under very significant changes, dramatic changes, it would still be the same river. On the other hand, under very trivial changes, it wouldn't be a river at all. So, for example, if Hobbes argued that what identifies something as a river as its point of origin, that's part of the truth. It can't be the entire truth, because if the river were, say, if the direction of flow of whatever's in it were reversed, it would still be the Charles River. If it were broken up into tributaries and directed so it ended up in some other place, it would still, under appropriate circumstances, be the Charles River. If whatever minimal amount of H2O is in it were replaced by chemicals from an upstream plant, let's say, it would still be the Charles River, though it wouldn't have any water in it. And probably not much of a change from what it is now. But and so on. Lots of different radical changes would still keep it being the Charles River. On the other hand, trivial changes would keep it from being a river at all. So, for example, if it were directed between two fixed banks, let's say walls, and used for transporting freight, ships with carrying freight, then it would be a canal. It wouldn't be a river, but it's a small change. In fact, if some minuscule physical change were carried out, undetectable except in very sophisticated ways, which was what's called a phase change, just changed its surface so that it became, say, glassy, hard, almost undetectable. I suppose it was changed to become hard, and a line was drawn down the middle of it, and people started using it to commute to Boston. Well, then it would be a highway, not a river, even though the changes are virtually undetectable. And you play with it, you can find many more complexities. What all that means is that a river is not a mind-independent object. It's some mental construct. And the same is true of any other word you look at. One of the terms that raised a lot of interest in the 17th century, mainly because of interest in moral philosophy, was the notion person. So what makes something a person? John Locke, for example, spent a lot of time on this. Well, he argued a person isn't a material object. And without running through the details, he came to the conclusion that a person is individuated in terms of psychic continuity. So if the mind persists and the body changes, it's still the same person. And he concluded, in fact, that if you had two psychic continuities in the same body, it would be two persons. Or if, and in fact, science fiction today plays with notions like that. A single person could inhabit two bodies if it's the same psychic continuity running through it. Again, a science fiction trick. And all of this is known to infants. I mean, I don't know if it's been really studied, but anyone who's had children or grandchildren knows that it's instantaneously understood. In fact, children's literature is based on these notions from the earliest stages, cross-culturally, as far as we know. So the standard children's story is, the handsome prince is turned into a frog by evil witch. Later, the beautiful princess kisses the frog, and out comes the handsome prince, not some other creature. And every child knows it was the prince all along, even if in every physical respect it was a frog, because there was some kind of psychic continuity running through it. My own grandchildren are entranced by a story about a baby donkey named Sylvester who is turned by some process, I don't know what, into a rock, and spends the rest of the story trying to convince his parents that he's really their baby donkey Sylvester. And since children's stories always end happily, something happens at the end and turns back into Sylvester. Everybody lives happily ever after. But the point is that the children have, no matter how young, since they can understand anything, have no problem understanding, take it for granted, that even if it's in every physical characteristic a rock, it's still Sylvester as long as the psychic continuity persists. Locke was too narrow. This notion doesn't only hold for persons, but for organic creatures and probably for inorganic ones if we look more carefully. Well, those are just, and we can proceed. But if you think about it, no matter how simple and elementary the concept you look at, you'll find that those are its characteristics. It is, it's the concepts and words that we have do not pick out entities in the world that, say, a physicist could identify, that can be found, by mind external investigation. Rather, they're basically products of the imagination. That doesn't mean that they're not real, or that we can't use them to refer and communicate. We can. So I can use all these terms to communicate to you, and I can refer to them, referring as an action, not a property of a word. I can refer to them, I can communicate with you, basically. And the reason is that we share a cognitive structure. And if the situation is sufficiently circumscribed so that I can convey to you the perspective from which I'm looking at the world, and you can look at it from the same perspective, then I can use these mental entities to focus your attention on aspects of the world from the same perspective or close enough perspective to mine, and that's a successful act of reference or of communication. So there's no inhibition of communication in these facts, even though there are no mind-independent entities that, say, a physicist could identify, to which our words have some relation, a relation of reference or denotation. In technical terms, that means that the formal concept of reference that you study in logic, that's developed by Frege, Peirce, Tarski, Carnap, and so on, it just doesn't apply to natural language. There is no notion of reference for natural language, as far as we know, or for thought. For language and human language and thought just don't have a notion of reference. They don't have a semantics in the technical sense. They don't have terms that pick out pieces of the world. This appears to be a respect in which humans differ sharply from any other organism. As far as is known, animal communication systems are based on what's sometimes called a one-to-one relation, an isomorphism between some internal symbol and some identifiable aspect of the world. So if you take, say, calls of a vervet monkey, has whatever it is, 5 calls, looking at the vervet monkey anthropomorphically, the way we look at everything, we say the monkey's giving this call because there's an eagle there, and it's telling the rest of the crew of monkeys to run away. Now, what appears to be happening is that there's a reflexive reaction to some, say, motion of leaves or something like that, and then the call comes out. There's apparently an identifiable isomorphic relation between the call and a physically identifiable aspect of the environment, which we interpret and the vervets interpret as meaning get out of the way. Whether they interpret it as a predator's coming or not, nobody knows. We just know that they run away. and that appears to be the case for all animal communication systems as far as anyone's discovered. If that's the case, then one fundamental difference between humans and the rest of the organic world is that we have concepts that do not pick out mind-independent entities. And that's one of the two major problems that any theory of any account of the evolution of human language and cognition will someday have to face. How did this happen? What change in the human brain led to a completely different way of conceptualizing the world, in which we perceive it. Our Umwelt is constructed from internally generated mental objects, which we use to refer and communicate, or to express thought, or just to have thoughts, but which do not pick out common mind-independent entities shared by the group that's interacting, or the person who's thinking. Well, that's one big problem. Another big problem, recognized very well in the 17th century, they weren't talking about evolution, obviously, we do. We can't say anything about it, but we talk about it. The other big problem, which will have to be accounted for, in fact, there are two other big problems that have to be accounted for. One is the fact that our minds are capable of, in fact, constantly do generate an unbounded range of expressions, which, in fact, express thought. They're related somehow to the mental systems that we have. We have some kind of system of thought, and at some stage in human evolution, some small change took, some rewiring of the brain took place, maybe some small mutation. Nobody knows enough about the structure of the brain to imagine what it could have been, but some small rewiring took place, which provided humans with what's called a recursive operation, an operation that allows them to take the atomic elements that are available, whatever they are, and to construct from them an unbounded array of structured expressions. That operation is that there is basically only one such operation that's used to generate any system of it's called digital infinity, like the number system, integers and language and so on. Now again, humans appear to be the only organism that has any such capacity. In fact, it's very hard to find in the organic world altogether. It appears to be some kind of special innovation that took place in humans, and that does provide an unbounded range of expressions with which we can then have complex thoughts, sometimes express them, communicate, one of the forms of interaction, and so on. How that happened is the second big problem that has to be dealt with. And there's a third problem, which these first two problems are researchable. You can study them. There's a third problem which you can identify, but nobody knows how to study it. And from the 17th century point of view, it was the major one. That's what is sometimes called the creative aspect of language use. The fact that not only can you construct these expressions, but that you can do so independently of external stimuli and independently of at least identifiable internal states in a way which is appropriate to situations but not caused by them, which is a crucial difference, and in a way that allows you to express thoughts that others like you can interpret and understand and realize that they could have said them the same way if they had thought about them. That combination of properties is, as I say, sometimes called the creative aspect of language use. It's one dramatic illustration of freedom of choice and will, but in a highly structured, complex sense. For Descartes and the Cartesians, that property was the distinctive property that distinguished mind from body. So and distinguished humans from animals and from automata. The 17th century, much like today, was fascinated with automata and interested in the question, what makes an automaton or an animal, a beast, so-called, different from a human? And the distinguishing characteristic, primary distinguishing characteristic was identified as this one. And again, it was argued that this is true of the youngest children, of all human beings, no matter how mentally deformed or whatever, they all have this property that makes them human. It's just side word. In the terms of the 17th century, this thesis that this identifies the mind was a scientific thesis, was a normal part of science and a sensible, appropriate part of science. It was assumed at the time that the world is basically a complicated automaton. It's more complex than the kind that skilled artisans were creating, but pretty much the same. In fact, it was believed that the world was created by a skilled artisan, a master artisan. Divinity created this complex machine, and then it just kind of works the way it was designed. So it's like the complicated clock or other complex devices that were at the time being constructed by very skilled artisans and delighted people and so on. So it made a lot of sense to ask, well, what's the difference between a skilled one of those machines and, say, us? And since the Cartesian insight appears to be correct, that a machine can't have this property, then you have to assume that there is some other principle in the world, in addition to the mechanical principle, in their terms, another substance, and that's mind. So you have a dualist approach. Well, we all know, or at least think we know, that approach collapsed. And in a sense, it did collapse, but not in the way that's commonly believed. What happened is that Isaac Newton, to his great dismay, he never believed it, showed that there aren't any machines. He showed that nothing in the world works by the mechanical principles. That's what action at a distance means. He thought that was a totally absurd conclusion. He said no person with any sense could possibly accept it, but it just appears to be true. And it took centuries before it really settled in. I mean, Newton, to the end of his life, tried to disprove it. Right into the early 20th century, scientists were trying to show that there are mechanical interactions that mean that the world really is a machine, the kind of entity in which I can't move, say, this bottle over here unless I touch it. We now know that that's false, but it is just our only conception of a machine, and it was the conception of the scientific revolution. Well, Newton disproved it, though he didn't believe his disproof, and with the disproof of that assumption, the machine disappeared, but the mind was left intact. So Newton didn't get rid of the ghost in the machine, he got rid of the machine. And now the entire world is ghostly, and you're left with a completely different conception of science. The 17th century conception was that the world should be intelligible to us. Post-Newton, as the Newtonian revolution finally sank in, it came to be realized, as it is today, that the world is just not intelligible to us. It doesn't make sense. And in more modern scientific theories, it just makes no common sense at all, and nobody cares, because you're no longer trying to show that the world is intelligible. It isn't. What you're trying to show is that you can construct theories of the world that are intelligible, which is a completely different enterprise. It's the lowering of the sights of science, and that's what slowly sank in over the centuries. And from this point of view, the study of mental aspects of the world is just like study of chemical or optical or other aspects. Just studying various aspects of the world, trying to find intelligible theories of them, try to unify them to the extent that you can. Unification does come about often, but often in extremely surprising ways, even in recent times. And you don't know how it's going to come about in the future. Well, that's the nature of the scientific enterprise. Today, it's if you read contemporary literature, you read about what's called the astonishing idea or the radical new hypothesis, dramatic proposal that the mind is just a result of the organic structure of the brain. It's got to be true, but it's not part of the structure of the foot. Apparently, you can cut your foot off and still have a mind. So it's got to be something about some product of the structure of the brain. But that was just taken for granted by the late 18th century, by the time the Newtonian revolution had set in. In fact, it was stated in virtually the same words that are called an astonishing hypothesis today. Another example of how we're slowly coming to comprehend what was very well understood centuries ago. Another illustration of the kind of intellectual tragedy of the fact that we haven't been living off the intellectual capital of the 17th century in these domains, in language, philosophy, cognitive science, and so on, and have a long way to go. But the ideas are pretty clear and understandable, just kind of different than the ordinary way of looking at it. Well, this third property, the creative aspect of language use, remains beyond inquiry. But the second property, the principles that we use to form expressions, to express our thoughts, that's a major topic of investigation. Did pick up again from the 1950s, breaking with the barriers imposed by behaviorist and structuralist dogmatism. They collapsed, fortunately, and we were able to became possible to get back to some of the topics that were seriously investigated centuries earlier, and in fact to go far beyond, because there are new tools, new mathematical tools and others that weren't available then. And that leads to modern linguistics and cognitive science. I don't have time to talk about it, but from then on, you go off into what we understand about the universal principles that enter into what you and I are now doing. Just a final word about it. If it is true, and there's no reason to doubt it, that cognitive capacities, capacity for language and so on, are just aspects of the world like others, then we would expect that when we study, say, language or moral theory or visual perception or whatever, we would expect to find three separate factors that enter into their growth and development. One factor is what in the 17th century was called innate structure. Today we call it the genetic component, not knowing a lot more about it than they did. We have a different word for it. So there is some genetic component that determines that we have language, not, but say my granddaughter exposed my granddaughter and her pet kitten or chimpanzee or songbird or whatever may be exposed to precisely the same data, precisely the same, but only my granddaughter interprets some of it as linguistic experience in a very mysterious way. Nobody knows how this is done. But some of the complex environment is picked out as linguistic experience if you have the right genetic endowment, and then out of that comes knowledge of a language in an almost reflexive way. You're not taught it, you don't really learn it, it just kind of grows in your mind the way other aspects of the organism develop. That's one factor, the genetic component, which interprets part of the data as experience and constructs some intellectual structure in the mind from that experience and then makes it possible for us to use it in the way we're doing now. The second factor is variation in the data. So we happen to be talking some variety of what's called English, but not some variety of what's called Japanese. Well, no genetic differences, but there are some differences in the data which yield those distinctions, presumably very superficial ones. Can't be very much. And in fact, that's I'll come back to that in a second, but that's the second factor. The third factor, which is much harder to study, but is coming into view in the study of language and the study of biology also, are just general principles of nature, which enter into how organisms grow and develop in every aspect. I mean, we know that in some cases. Everyone knows that, say cell division is into spheres, not cubes, but not because there's a gene that tells the cell, become a sphere, not a cube. That's because of physical principles. And no one knows exactly how far that goes, but undoubtedly the just general principles of nature play a major role in determining how an organism gets to its successive states of maturation and development. And the same is true of evolution. There must be fixed principles of nature that just determine the kind of channel within which natural selection can make a few choices. That's the third factor. And the same is true in language. Principles of language is basically a computational system, so you would expect that principles of efficient computation, that don't have anything particular to do with language, should enter into the way a language grows in the mind of a child, no matter what language it is. And in recent years, it's for the first time become possible to explore these properties of language and get some interesting results about them. Just to finish, these two areas, biology and linguistics, have been developing pretty much in parallel for the last 40 years or so, and with a good deal of interaction. That's where the phrase biolinguistics comes from. In both cases, say around the 1950s, it was assumed, both in biology and in linguistics, that in biology, that organisms can vary in every imaginable way. So the variation of organisms is so extreme that each one has to be studied as a special case. And if nature sets a certain problem, natural selection will find a way to solve it. Study a major, take a course in general biology, you still read that. Similarly, in linguistics, it was assumed that languages can vary in every imaginable way, and that it's a mistake to approach some new language with a preconception of what it must look like, because the variation could be arbitrary. Well, both of those ideas are literally incoherent, and they weren't really meant literally because they are incoherent, but that was the kind of the atmosphere. The assumption is, well, variation is so huge that there's nothing much you can say about it. Over the years, both biology and linguistics have been chipping away at those incoherent assumptions with a fair amount of interaction. And by now it's not exotic in either field to say that there really only is one organism with slight variations in timing of regulatory mechanisms and so on, which yield gross superficial differences, but from the same deeply conserved elements, some of which go way back to bacteria. Hox genes are a famous case. And similarly, in the case of language, it's no longer extreme to say that there probably is really just one language with minor variations depending on how this or that option is fixed, and when in a well-constructed, well-designed system, slight changes are made in several places, the superficial outcome can look very different. If you want to see an explicit working out of this that's both very expert and very accessible, there's a book by a fine linguist, Mark Baker, called Atoms of Language, in which he takes two languages that are about as different as you can possibly imagine on the surface, English and Mohawk. Every possible property looks totally different. And he tries to show, and to a certain extent does show, that if you assume a fixed structure of options that can be picked in the course of acquisition on the basis of simple data, then the two languages turn out to be virtually identical, just with different choices of options. Very much like the way say, a butterfly and an elephant that turn out to be pretty much the same animal with just different choices of timing of regulatory circuits and so on. That's the direction in which both fields are going, and probably will converge in that respect. In biology, it's called sometimes the Evo-Devo revolution, evolution, development, revolution. There's some interesting general books on it. In linguistics, it's called the minimalist program, but it's basically the same thing and has developed an interaction. Well, these are researchable topics. The one that, for the moment at least, no one has any idea how to research is the one that was the crucial one for the 17th century, and that is the creative aspect of language use and the general problems of will and choice, which appear to be, as far as we know, independent of external stimulation, internal control, appropriate but not caused, these other properties. I'll stop there.
I thought at first I might try to say something about the topic, but the relevance of statistical information to study the structure and use of language, but I realized very quickly I wouldn't have anything to say about that, except to try to correct some very persistent misinterpretations of things that were written 50 years ago. But you can do that easily enough by yourselves if you're interested. It really just amounts to reading carefully half a dozen pages in several scattered articles and books. So I'll drop that topic and turn to what seems to me, still seems to me after all these years, the right way to do the study of language structure. That means syntax in the broad sense, everything that goes on in the head. Syntax, morphology, phonology, formal semantics, everything that doesn't require access to the world. The modern study of these topics back early 50s did take a pretty sharp break from prevailing notions, actually orthodoxies you might call them. One aspect of the break was to take seriously what was disparaged at the time as God's truth linguistics. That was supposed to be bad. This is kind of period of misunderstanding of logical positivism, which was rampant. So God's truth linguistics meant taking seriously the idea that there is some real entity that's part of the mostly the brain, that constitutes the faculty of language and would be on a par with internal systems like, say, the immune system or the visual system or others. One of the subcomponents of a complex organism that interact to yield our capacities and use of them. So the modern, this approach in later years was called biolinguistics. And that's essentially the approach that began to take shape in the early 50s. Here in Cambridge, in fact, a couple of graduate students. If we take that seriously, if we do assume that there is a real object and we're trying to find out its characteristics and how it interacts with other components of the body, then we should be treating it exactly the way as any other. If we want to look at the growth and development of any system of the body, we expect that there'll be three primary factors that enter into that process. One will be some genetic endowment, which in the case of language will reflexively provide an infant with the not trivial capacity to select out of the environment evidence that's linguistically relevant. So essentially to map external data into linguistic experience. That's step one, provided by some part of the genetic endowment, which then furthermore sets the general framework within which some language can grow and develop and assume one of the possible forms that's permitted by this internal system. If current thinking is on the right track, there may be only a finite number of these. That's the first factor, genetic endowment. The theory of the genetic endowment is often called universal grammar in UG, but that's kind of borrowed from a traditional term, but adapted to a different framework, so it actually means something different. It doesn't refer to properties that are found in all languages, which was one traditional usage. Just the theory of the genetic endowment, whatever it is. And if language is a real object, we can be confident that that exists. It's often called a controversial hypothesis, but I mean, the alternative is magic. I mean, there's got to be something that accounts for the fact that my granddaughter picked out part of her environment as language related and almost reflexively developed the language, while her, say, pet kitten or chimp or songbird or whatever, exposed to exactly the same data, didn't even take the first step and couldn't even conceivably take the second. So either it's magic or there's a genetic endowment. If there's a genetic endowment, either there's a theory of it or there isn't. If there isn't, it means it's some mystery beyond our cognitive capacities. No particular point assuming that, so therefore there is a theory, so therefore there can't be a controversy about the existence of UG, contrary to reams of literature, which I'll avoid. So that's the first factor. The second factor is the external environment, which clearly has an effect. So one of my granddaughters came to know English, another one came to know Spanish, and obviously that had to do with the environment, which sets a choice within a pretty narrow framework. The third factor is just principles that are not specific to the language faculty, just recruited in the course of growth and development. And these could be of many kinds. So, for example, properties of the brain could determine the way language develops. Unfortunately, we don't know anything relevant about them, but someday we might. But that's one third factor property. Another one is principles of learning strategies, which doubtless exist and may very well be recruited in the acquisition of language. And it's at this point that one would expect, as one has always expected, that information about frequency, probability would turn out to be relevant. Has to be shown, of course, but that would be a natural expectation, and there is interesting work substantiating or giving some support for that natural assumption. Another third factor property, which one would expect to be particularly relevant for a computational system like language, it is a computational system fundamentally, would be just general principles of computational efficiency, which may very well be natural laws, not specific to language or to the organism, or maybe to organisms altogether, but just something in nature. That, I think, has increasingly come to be a plausible direction to search. Well, let me give a formulation of this expectation 40 years ago. We expect that acquisition will involve not just habit formation based on a few years of experience, as was then commonly believed, or millions of years of evolution yielding universal grammar, thesis that was then considered outlandish, but also principles of neural organization that may be even more deeply grounded in physical law. A proposal that was considered so outlandish that it couldn't even be heard, but I think we can now hear it. That formulation 40 years ago was misleading in particular in referring to millions of years of evolution. It's now reasonably clear that language emerged pretty suddenly and very recently in evolutionary time, probably in some window 50 to 100,000 years ago or something roughly like that. Doesn't matter if you move the numbers. Either way, it's a flick of an eye in evolutionary time, and something that happened apparently very fast. As soon as it happened, you see all kinds of effects in the archaeological record. It's what's sometimes called a great leap forward in cognitive capacity and what it reveals. And shortly after that came the trek from Africa. This is presumably some small breeding group where this happened, and then they started expanding all over the world, and very quickly were pretty much everywhere. So that's the period in which language seems to have evolved, emerged, and there's nothing surprising about emergence of this kind in evolutionary history. There's plenty of examples of it. In fact, there are some well-known paleoanthropologists like Ian Tattersall who claim much more generally that all of human intelligence emerged, in his word, at essentially this instant of time, instant from an evolutionary point of view. Well, if something like that's correct, then we would expect that that what emerged and is then common to the whole species is not the kind of biological entity that develops over a long period of time by what François Jacob called tinkering, sort of doing the best you can at any particular evolution, doing the best it can at with the tools that are around, which can lead to a lot of intricacy and complexity, path-dependent evolution and so on. But if it emerged suddenly, in an evolutionary sense, you wouldn't expect that. What you'd expect is that somehow what developed is very simple. In fact, maybe almost perfect. That is a perfect solution to design problems that were imposed by the circumstances and conditions prevailing at the time of emergence, which would of course be in a single individual. Mutations take place in a person, not a community. They can take over a community, but that would, something like that would be expected. And the proposal that this is true, which is of course a speculation, is sometimes called the strong minimalist hypothesis, SMT. The hypothesis states that what developed suddenly, what emerged, was in fact a perfect solution to design problems. Well, that's a thesis. It, say 20 years ago, it would have sounded totally crazy. Now it doesn't sound that outlandish, and there's even reason to believe that something like it might turn out to be true. It's not an implausible speculation at this point, and there's been some success in moving in that direction. Well, to the extent that it suggests a kind of a methodological lesson, namely, if you want to study take a look at the range of phenomena that fall under what's loosely called language. There's endless problems everywhere you look, even problems in trying to figure out to which component of human capacity the phenomena belong, or what mixture of components. Are they even language, or are they something else? But one way of approaching them is to see if you can just disentangle them, take them apart, so that some parts of them do conform more or less to SMT, that is, would be perfect solutions to design problems, and then see how far that goes. It's a plausible approach to studying the complexity of language, and it's been reasonably successful in the last 15 years or so. Well, to the extent that this thesis holds, we can search for what we can call principled explanations to phenomena of language, or maybe not, to phenomena that fall within what's loosely called language, namely explanations that reduce the phenomena to third factor properties. And here it appears increasingly that conditions of computational efficiency play quite a substantial role in this, maybe an overwhelming one. Now, that seems to be a very promising way to proceed. You couldn't really pursue it until pretty recently, when a lot of underbrush had been cleared away. But now it seems like a feasible research program, always kind of implicit in the study of biolinguistics, as indicated by the quote, somewhat misguided quote that I gave a moment ago, but now I think realistic. Well, let me say a couple of words about where I think we are now. Starting with this methodological principle, let's say, assuming language to be as perfect as possible, we would start with adopting the simplest possible operation that could yield the fundamental properties of language. The most basic elementary property of a natural language is that whatever's in the head, what's sometimes called the grammar, let's call it the internal language, generates an infinite array of structured expressions which are transferred to two interfaces with other parts of the body. An interface with a system of thought and interpretation and so on, call it the semantic interface, although the term could be misleading, but let's call it that. The semantic interface is one. Expressions have to be assigned some interpretation there, and they also have to be transferred to a sensory motor interface where they can be externalized, typically in speech, but as is now known, it seems comparably in sign, and may not be externalized at all. It's internal thought, for example, which is the overwhelming bulk of language use, statistically speaking. So you have some sort of generative procedure that constructs an infinite array of hierarchically structured expressions and is associated with procedures to map them onto the two interfaces. The simplest possible operation that could produce expressions of that kind just takes, it's going to be recursive, of course, will take two objects already formed and construct from them a new object. And in the simplest case, it won't modify the two objects that were put together. Modifying them would require greater computational complexity. So this operation, call it merge, takes two objects, say x and y, and what it forms is just the set xy. Okay, no modification of either x and y. Just as a matter of logic, there are two possible kinds of merge. One takes x and y, which are distinct from one another, and forms the set xy. Notice, of course, that if you iterate this, you do get structured expressions. The hierarchically structured expressions. So it takes two objects already constructed, x and y, which are distinct from one another, and forms the set xy. Let's call that external merge. The other possibility is that the two objects, x and y, are not distinct. Obviously, that's just logic. And if you look at the mode of composition, it turns out that if they're not distinct, one must be included inside the other. So the second possibility is that you merge two objects, x and y, where one of them, say y, is inside the other, say x, and they're only certain, and y must be, of course, something that had already been constructed. I call that internal merge. Well, so far that's just logic. Internal merge, if you think about its properties, yields what's called the copy theory of movement. So, for example, which incidentally is quite well confirmed empirically by now, that is, it's confirmed at the semantic level. It's obviously false at the sensory motor level. So, for example, if you take the hierarchical expression that corresponds to you saw what, and you apply internal merge, you merge what to the whole thing, what you get is what, and then the set containing what, and the set constructed from you saw what, which happens to be the right interpretation at the semantic level. So the word what is doubly interpreted in a way. It's interpreted in the position where you hear it as a kind of a scopal element, and it's interpreted in its initial position where it's not pronounced, and it's there given the same interpretation as the corresponding sentence, you saw the book or something, as the object of C with all of its properties. So the the result of internal merge in the simplest possible form does give the right interpretation at the semantic interface. And as I say, there's plenty of evidence for that and lots of complications and big literature about it by now. But it seems to be fundamentally right. On the other hand, at the sensory motor side, it's radically wrong. So we don't say what you saw what. Actually, it's not totally wrong. There are cases where a residue of what's moved does remain. Typically, maybe only in cases where there's some phonetic requirement that something be there, what Howard Lasnik called the, I keep forgetting what you called it, stranded affix filter. Yeah, if there's some piece of phonetic material that's just got to be attached to something, then the smallest possible residue of what was moved does remain. And some languages, the whole thing remains. So Chinese, you just say you saw what. But interpreting it with the same dual interpretation. But anyway, radically at the phonetic side, it's wrong. The only thing that remains is the thing that was moved. What did you see? Not what did you see what? Well, that consequence follows from pretty elementary computational considerations. If you were to pronounce all of the, notice this is an artificially simple example. If you take any real example, you find copies all over the place. In fact, even in this case, there's internal copies. But if you were to pronounce all of those copies, there would be a tremendous computational burden. Remember that the mapping to the sensory motor interface includes all of phonology, all of morphology, and probably even the process of linearization. This is contested, but I think it's increasingly plausible that it's true. And that's quite a computational burden. These are the areas of language that are highly diverse, very complex, affected by historical accident, like the Norman Conquest and so on and so forth. But whatever we think about it, that's a huge computational burden. And language seems to universally solve the problem by reducing the computational burden, but of course increasing parsing difficulty, perceptual difficulty. Anyone who's worked on parsing programs knows that one of their basic problems is to try to find what are called the gaps. You hear a what at the beginning of the sentence, you got to figure out where it is, which is a huge parsing problem. So you could say, metaphorically, that the design of language faces two inconsistent desiderata. One, to make the use of language simple, and the other, to make the design simple. And universally, it chooses to make the design simple. There's quite a lot of evidence like this, that language structure is optimized for the thought systems, for the semantic interface, at the cost of considerable complexity, often at the sensory motor interface, meaning in particular for externalization. And notice that one aspect of externalization is communication. There's a kind of a dogma that language is designed for communication or evolved for communication, whatever those phrases are supposed to mean, and maybe nothing. But the dogma, to the extent that you can make any sense of it, seems radically false. It looks as if externalization altogether and communication in particular are ancillary processes, probably both in the design of language and probably also its evolution. Issues that are well worth pursuing. There's a lot of things to say about them, but I'll put them aside, just say so. Just leave it at that. In any event, we seem to have optimization at the, or hope for optimization, something like the SMT at the semantic side, but nothing remotely like it at the sensory motor side. In fact, the operations that map syntactic semantic structures onto the sensory motor face violate every computational principle you can think of. Maybe they do the best that can be done with a hard computational problem, namely relating two systems that have nothing to do with one another. The sensory motor system could have been around for hundreds of thousands of years before language ever emerged. And there's some, but not much evidence for coadaptation. So whenever language emerged, you get this thought system, and somewhere down the line it gets externalized, but that's a really hard problem. And it's solved in a lot of different ways, and as I said, it's subjected to plenty of historical accident and so on, as we know. But it looks ancillary, secondary property. Well, notice that internal merge is automatically available. If you take the simplest possible computational procedure, you just get internal merge without postulating it. That's another way of saying that is that a simple form of transformational grammar, this is a simplified version of transformational grammar, is just the optimal system. If you don't have it, you'd have to have an argument as to why you don't. There'd be an empirical burden of proof to show that you don't have it. That's not the way things have been looked at for the last, say, if you go back 50 years, it was assumed, that, or even back to the late 40s when I started working on this, it was assumed that some sort of phrase structure grammar's got to be there. And then the question is, do you need other devices? So if my own work in the late 40s involved discontinuous features to try to account for long-distance dependencies, something like kind of vowel harmony carried over to the syntactic domain. By the 1950s, it looked as if transformations, things which take a piece of a structure and put it somewhere else, could be the best way of doing that. But it was assumed at the time, by me too, that phrase structure grammar is sort of given, and the question is, what other devices do you need, if any? Well, it looks as if the opposite is true, that transformations are given, and you don't need phrase structure grammar. By the 1960s, it had already was beginning to be shown that phrase structure grammar is extremely complex, has a lot of stipulations and a lot of complexity. And it was shown by the 60s pretty convincingly, I think, that most of this was unnecessary and you actually could do better without it. And by now, the residues of phrase structure grammar that remain are very thin. Nothing more than merge and some sort of algorithm, maybe a universal algorithm, which again has interesting computational efficiency properties that tells you what kind of an object you form, period. It doesn't even have to be part of the grammar. It could be a third factor property. So phrase structure grammar seems to have disappeared, but at least I think so. But throughout all this period, no matter how much one tried, transformations seemed extremely resilient. It seemed to be very hard to get rid of them sensibly. And I think now we have an understanding of why that's true. Transformations are just there free. If you have to have a stipulation to bar them. If there's some theory of language that doesn't use transformations, it has a double empirical burden to bear. One, it has to give empirical evidence to justify the stipulation that you don't have internal merge, since it comes free. And secondly, you'd need to meet the empirical burden of showing that whatever other devices are proposed do exist. Okay, so there's a double empirical burden if you don't assume transformations in the simple form given by internal merge. And personally, I don't think there's any way to meet those two empirical burdens. But anyway, that's sort of the logic of the problem. If you can't meet them, it's important for biolinguistics. If there are two kinds of merge, and if they really are used, there's no stipulation, there's no extra complexity in the system that says don't use one of them. So the ones that are automatically available are just used. If that's true, you'd kind of expect in a well-designed system that the two kinds of merge have different interface properties. They work differently at the interface. Well, at the sensory motor interface, it's kind of obvious. internal merge yields the ubiquitous linguistic property of what loosely called displacement. You pronounce something in one position, but you interpret it both there and somewhere else, like, what did you see? So it has an obvious sensory motor consequence. At the semantic interface, it seems, there's an interesting thesis, plenty of evidence for it, not certain. I know there are people here who've tried to deny it irrationally, in my opinion. The theory, won't mention any names, but it seems to correspond with what's sometimes called the duality of semantics. There just seem to be fundamentally two different aspects to semantics. One is what you get in artificial systems, invented systems, argument structure. So, agent, patient, goal, and so on. That's one aspect of semantics. The other aspect of semantics seems to be everything else, like information that's used for discourse interpretation, like distinguishing new information from old information, or identifying the type of the expression, like is it a topicalization or a declarative or something else, or information about scope, let's say. All of that seems to be another kind of semantic information. And these seem to correspond very closely, and I suspect if we knew enough would correspond exactly to external merge for argument structure and internal merge for everything else. So to the extent that that turns out to be correct, it gives more reason to suppose that we're on the right track. Another desideratum for a well-designed system would be that it stipulate no levels of representation, no significant subsystems, except for the two interfaces, which presumably have to be there, although even that can be questioned. But at least the semantic and sensory motor interface, let's assume, are there. And in a well-designed system, there shouldn't be any others. Work of the 1990s pretty well showed, I think, that you can dispense with the descendants of what used to be called deep structure and surface structure. Not only dispense with them, but you do better by eliminating them if you keep to the simplest possible compositional function, namely merge. That leaves one level. It's the level which is the result of the application of all syntactic operations. It's the output of those and the input of the operations that map to the semantic interface. Now, that was, at the time, that was called LF. Terminologies become confused. LF is the phrase, the term LF, technical term LF, is now often used for the semantic interface. So you need some other name for what used to be called LF. But terminology apart, which at most introduces some confusion, there was these efforts to get rid of any residue of surface and deep structure did leave the level which has the properties I mentioned, properties of LF in the old sense. You can get rid of that too if you develop a specific version of principles that have appeared repeatedly in the structure of in the investigation of the structure of language since the 1950s, and in fact are all over traditional grammar too in some other form, namely principles of compositionality. So if you give a certain version of the properties of compositionality, or in more recent terms of cyclicity or strict cyclicity, then you can get rid of LF as well. The way to do it seems to be to suppose, and again this is computationally makes plenty of sense, that instead of the entire syntactic object being transferred to the two interfaces in a one-shot deal, it's transferred to the interfaces as it's constructed. So as some piece of the syntactic object is constructed, it's transferred over to the semantic and phonetic, it's not really phonetic, sensory motor interface, and it's there interpreted, and you're not allowed to modify the interpretation by any subsequent syntactic operations. So it'll stay the way it is, which of course is a huge computational saving. It means, especially on the phonological, morphological side. So you don't have to go through these operations over and over again because it's going to be stable. If you look at it closely, I'm getting beyond what I can try to explain non-technically, but let's call these units that are transferred over phases, okay? Turns out there's very good reason to believe that it's the interior of the phase that's transferred, not the whole phase. Good reasons for that, which I won't go into. The reason basically is that everything out of the interior can move on, as we know, by internal move. There's pretty good reason to believe that there are two fundamental kinds of phases, maybe only two, but at least two. One is basically verbal, headed by some functional category that says I'm a verbal phase, and another clausal, headed by a functional category that says I'm a clausal phase. These are usually called C and V, naturally. And there's pretty good reason to believe that they exist. What appears to be the case is that in the design properties are such that at these two phases, the interior of the phase is handed over to the sensory motor and the semantic system, and they're interpreted, and there's no further access to their interior. It can't be modified by any further syntactic operation. Now, that enormously reduces complication, and it has other important consequences. I mentioned before that in a sentence like, say, what John saw what, or for that matter, John saw John, we have to be able to know somehow whether the thing that appears twice was created by internal merge or external merge. Because of the duality of semantics, going to have a different interpretation depending on which it is. Well, that information is available at the phase level. In fact, exactly these two phase levels, at the verbal phase and the clausal phase, that information is available. But at any other position in the computation, it's just not available. It takes a little work to show it, but you can. So if there's going to be a correct identification of copies, so you'll know that John saw John is okay, but it means two different Johns. If there's going to be a correct interpretation of the copies, then it seems that for that reason alone, you need these two phases. Same turns out to be true for features that don't have any intrinsic semantic properties, what are called uninterpretable features, like, say, nominative versus accusative case, or plural or singular agreement on a verb, actually on the inflectional element that the verb attaches to. These don't have any intrinsic meaning. They just have a value depending on the structure in which they appear. That information is also available at the phase level, not before and not after, which supports, again, from another point of view, the conclusion that it's precisely at this level that transfer takes place. And there are other things of that nature. So I think there's a fair amount of evidence that not only that computation goes phase by phase, meeting sensible computational principles, but that these are in fact the phases. And that can plausibly be thought of as a consequence of the strong minimalist thesis. If language is going to be perfectly designed, it looks as if that's the way it ought to work. Now, I don't want to say that incidentally, this does not mean, this has been misinterpreted, so let me stress it. It does not mean that there is no further access anywhere in language use to the internal parts of the computation. That can't be true. In using language, in speaking or interpreting, at the very least, you bring together the semantic and the sensory motor expressions, which are generated separately, but use both of them, of course. So there must be some kind of homunculus sitting there which has access to everything that's going on, and in fact a lot more, because in language use you're not restricted to what you hear, of course. It's easy to show that people interpret what they hear on the basis of expectations and background assumptions, and overrides the phonetics of what they hear very often, and so on. So yes, there's a homunculus who's using everything, and it's a reasonable proposal is that what appear to be global properties of expressions, either phonetic or semantic, could well belong to the component of the whole system of human thought and action that involves the homunculus, bringing everything together, including both the semantic and phonetic side. And there are other further problems. They're each an optimal principle of computational efficiency. Am I going on too long? I lost track. A couple of minutes. Yeah. An optimal principle of computational efficiency would be that the information about when you have a syntactic object, any information about it that's relevant to further computation ought to be very easily and quickly identifiable by algorithm, by some optimal algorithm. And what that means is that all the information should be in a particular lexical item that was the basis for the construction of it, what's projected in old phrase structure theories. In the case of the verbal phase and the clausal phase, all relevant information should be in the V and the C. And that turns out to be true. Like what's relevant in a verb phrase for further computation is the kind of verb it is, and not, say, the kind of object it has, or prepositional phrase that's in there, and so on. So we have, that property seems well established, what are called the heads of the phases, which are incidentally very easily determinable by algorithm, and where they're not, you can show interesting problems. The heads carry all the information, and those are the things that are identified. Well, without going on with this, there are plenty of problems which I won't go into, but if you want a good summary of them, there's a good paper by, in the last issue of Syntax, Journal Syntax, by Bex and Groman, which gives a whole pile of problems. Most of them, I think, can be handled properly, but there are some that clearly remain as topics for further inquiry. I'll assume that this is more or less correct and just make a few more comments about it. Well, as I said before, it's extremely easy to find problems, and the infinitely many problems whenever you look at linguistic or apparently linguistic phenomena. And you then have two approaches that you can take. One is to develop some technology to characterize the problem, to describe it, and what's sometimes called giving a solution, but it's really giving a kind of redescription, which may be a valuable step towards organizing the material for further inquiry. And maybe that's as far as you can go. Well, if that's as far as you can go, then the technology has to be attributed to universal grammar, part of the genetic component, and the language is more of a mess than we hoped. Huge problem for any study of evolution of language, if anything like that never comes along. The other possibility would be to try to chip away at it and see if you can get a principled explanation for at least part of it. And often that's possible and moving towards SMT. Well, let me just finish by illustrating what I have in mind with one particular problem. Actually, it's an old saw, and thinking about how you might move towards a principled explanation for it. The old saw is what's called ECP in linguistic terminology. So if you have a sentence like, he wondered who saw what, you can turn it into from a declarative to an interrogative by moving either who or what to the edge of the sentence, giving the proper scope, and making sure that something appears after wonder to give proper scope for the internal question. So you can get either the sentence, what did he wonder who saw, or who did he wonder what saw? Well, the first one is not a bad sentence. It's a little deviant, but I think for irrelevant reasons. The second one, what did he determine who saw, is total gibberish. Who did he wonder what saw is complete gibberish. And it's not obvious why that should be true. I mean, one seems as easy to do as the other, but it's a very solid principle, a solid observation, and holds in many other cases. Well, as far as I'm aware, there's only one proposal around in the literature that seems to have anything serious to say about that. It's called the vacuous movement hypothesis, about 20 years ago. It's based on an observation, namely that in who saw what, or I wonder who saw what, there's no overt evidence that the who has actually moved to the scopal position. You don't hear it, you know. And then you could propose a principle which says, well, if you don't hear it, you don't move it, at least overtly. It still has to be moved covertly somehow to give you the scopal interpretation. So that's the vacuous movement hypothesis, and it pretty much covers the data. There are two problems with it, however. One is that it's a new principle. It's stipulated. No particular reason why it should be true. You know, it just makes as much sense for the opposite to be true. The other problem, which is more serious, is that it's factually completely wrong. There's plenty of evidence, I won't mention it, for movement that yields no overt phenomenon associated with it. So it can't be right empirically. So it has two serious problems, and we ought to look for a different account. Actually, there is a way of thinking about it that may be right, that derives from one of the most interesting cases of movement that leaves no physical evidence behind. That's based on work by Howard Lasnik, mainly, a couple of others, on what used to be called raising the object. Has to do with sentences like, I expect John to be intelligent, where John semantically this belongs in the clause John intelligent, but it's possible to show that it actually appears in the higher clause, which doesn't make any semantic sense. And it gets there by a double movement operation, neither of which doesn't leave any effect, namely the downstairs subject, John, and I expected John to be intelligent. John moves over the verb, and then the verb moves up to the small v that heads the phase, and it leaves things looking exactly as they were. Well, that looked so crazy that for quite a few years I worked pretty hard trying to find counter evidence or some alternative analysis, and you can see the residue of this in various papers, but it didn't work. The evidence looks solid. So we're left with this extremely strange phenomenon. There's a whole variety of semantic and syntactic consequences to a movement that makes a double movement that makes no sense at all because it leaves things exactly the way they started from the point of view of what you hear. Well, that remained as a paradox until it was noticed that you could get a solution to this problem if you assumed that the properties of the head of the phase, C and V, small v, were actually inherited by the element it selected. It would be tense and the verb in this case. I won't go through the details, but if you assume that, then these two movements take place, and you get the array of syntactic and semantic properties on the assumption of inheritance of the feature. Now, the inheritance itself was pretty weakly motivated. There was some motivation, but not much. However, it was pointed out by Mark Richards that the inheritance is actually entailed by the phase impenetrability condition, the condition on transfer of the interior. And that itself is very well motivated, conceptually and empirically. So in fact, I have a line of argument which goes from the empirical and computational motivation for the transfer operation, which yields as a consequence inheritance, which yields as a consequence this array of semantic and syntactic features, properties, that seem to make no sense but are clearly there. Well, that's a good result, the kind of result you want. And if you make one more step, you generalize the inheritance of features to the question element, the Q that call it, that determines that something that a C is a question, not a declarative. If that too is inherited, then you get the vacuous movement hypothesis. You can think it through. I won't run through it, but in fact, it's true. So without stipulating a new principle, which is furthermore wrong, you can get the vacuous movement hypothesis with all of its consequences, including the case I mentioned about the so-called ECP case, just on the basis of pure third factor properties. Well, again, that's the kind of result one wants. And I won't go on, but these are the sorts of directions that I think it would make sense to pursue, that is, chipping away as much as you can at stipulated properties of universal grammar, technologies that are proposed to deal with particular problems, try to see how closely you can show that language does approximate to the perfect design that it would be a rather natural expectation in the light of what appears to be its evolutionary history. Okay, thanks.
So we have time. We have time for just a couple questions. So let me just. Yes, there's a microphone up there.
Sequential and one-dimensional. What are your remarks and reflections on parallel grammars and multiple dimension grammars such as array grammars?
I couldn't hear. I'm sorry. Did you hear?
Carol. I believe the question is what. As I understand, your question is it has to do with parallel grammars.
Well, I mean, this is what I was describing is a parallel grammar. So when you do repeated construction of something by merge, it's all happening in parallel.
How about two-dimensional array grammars?
Two-dimensional?
Array grammars.
Yeah, I think there's good reason for thinking that, I didn't go into it, that there is at least two-dimensionality. This has to do with the nature of adjuncts as distinct from arguments. I think there's some evidence that they're actually in a third dimension. These are actually proposals that go back to ideas of Ken Sapphire and others back in the 80s, but I think you can get a better formulation of them, which would mean, if it's true, that there's actually two kinds of merge. One is just set merge, takes X and Y and forms a set XY, and the other, call it pair merge, takes X and Y and gives the pair XY, which builds in an asymmetry, and adjuncts have an asymmetry. So the adjunct phrase behaves like as if the adjunct wasn't there. It behaves like the thing to which it was adjoined to. And I think there's, it's complicated, but I think there's some evidence for that. However, any further complication that's introduced has to have empirical motivation. Okay? I mean, just, elementary methodological considerations. You pick the simplest possible theory unless you're shown that it's wrong because the facts are more complex.
Okay, I think we have time for one more question. I have to move on. Yes, Josh.
So could you comment on how the current guiding principle of perfection relates to the classical original idea of simplicity in the early days of generative grammar?
Yeah, it's an interesting question. I mean,
the question is how does unless Josh wants to use it, how does the notion of simplicity in the early days of generative grammar relate to this notion of perfection or perfectibility in the current sense?
Yeah.
Is that about it? Yeah.
Well, if you go back to the early days, say the 50s, there were two concepts of simplicity. One is just the general concept that holds for science altogether. Nobody can tell you what it is. But everyone working in the sciences uses it as a guiding principle. So you look for symmetries instead of asymmetries, and you try to have fewer principles instead of more principles, and so on. And there's all kind of work on this, like Hermann Weil's book on symmetry and so on and so forth. But there's some kind of guiding principle that works in the sciences that's just accepted everywhere but never formulated, that says we're looking for the simplest possible solution. That's a general methodological principle. It's no more relevant to linguistics than to physics or history or anything else. That's one notion. A second notion was an internal notion of simplicity. Now that's an empirical assumption. Remember that in those days the assumption was that language acquisition is sort of what Charles Sanders Peirce called abduction. It's discovery of a theory on the basis of data. Now it's perfectly well understood and has been, for hundreds of years, that there's no way to do this. That you can't do it by induction, and there's no generalizations and nothing else. It has to be something like what Peirce described, namely there's got to be some built-in principles, we would now say genetically determined principles, that in his words limit available hypotheses. Okay, they just say, well, here's the only set of hypotheses you're allowed to look at, so it eliminates, huge masses of others. And that can guide inquiry in a particular direction. Now, Peirce was thinking about development of science. How do people discover quantum theory or something? But the same conception has to hold for acquisition of language, if indeed language is a matter of theory language acquisition is a matter of theory construction, which it was assumed to be. And it's in this context that the internal notion of simplicity developed. It was called an evaluation measure. Can we find some measure that we can assign to the possible grammars, internal languages, that'll pick the best one? So there has to be some sharp limitation, Peircean type limitation on the set of admissible grammars, but then you got to pick one. And inside that came the notion of simplicity, so that's where you get notational devices like brackets and parentheses and counting features and stuff like that. But notice that that's an empirical hypothesis. Okay, it says this is the way languages are picked. Okay, all that sort of went out the window when the principles and parameters approach was formulated back around 1980. This was a really sharp change in the way language was looked at. I mean, maybe it's wrong, but it looks right. In any event, it changed perspectives radically. It said there is no evaluation procedure and there's no abductive principle, and the child isn't discovering a theory. There are principles which are fixed, unchanged, and if the SMT is correct, may in fact follow from general natural law to a large extent. But there are principles that are fixed, and then there's a set of choices called parameters, and the child just has to find the values for the parameters. Well, there's going to be finitely many of these, so there'll be finitely many languages, and most of the work on language acquisition since then has been studying very productively what kind of data would allow a child to fix a parameter. And it turns out you can't do it one at a time, and a lot of complexities arise and so on. But with that approach, you eliminate the notion of evaluation procedure. And what we're left with is just the general notion of simplicity. All right, how does that relate to the present case? It's a sort of a way of trying to take the methodological principle of simplicity that's used for all inquiry and see if we can give it instead of an epistemological interpretation, give it a metaphysical interpretation. Say, okay, this is a real property of nature. Okay, it's not just some methodological principle we use, but it's a property of nature that it seeks computational efficiency. It's a natural law. If it is, it ought to show up in, distribution of, determining the neural wiring of a nematode, to pick one example where it seems to work. It should show up in foraging strategies for ants, let's say, and in all sorts of places. It should just be the way nature works. So it's a shift from viewing something as an epistemological principle of some vague kind to a metaphysical principle, if you like, something that's really true of nature, which you can then explore in many different ways. So to take a concrete example, it's always been assumed in the actual study of language that if you have redundancy in a system, there's probably something wrong. So, for example, Morris Halley's famous argument against phonemes back, whatever it is, almost 50 years ago, I guess, was based on the structuralist phonemes, on the observation that if you postulated this level, you had to duplicate rules, one in forming the level and one in mapping the level onto the next stage, and it was the same rules, so it was redundant. Well, just on epistemological grounds, that was taken, at least by sensible people like me, as a proof that the level doesn't exist. But you could reinterpret that as saying that's just not the way nature works. You know, the way nature works is SMT and optimal, neural wiring and so on and so forth. So it's and if you take it that way, it shifts from a methodological principle to an empirical principle that you can investigate. Like you could say, well, does nature really work this way? Let's try other cases. And that's a step forward. But that's the relation. SMT is an empirical hypothesis about the way nature works.